here in the first track. So, from the electromagnetic waves, regularly one question is coming, and there are the two parts. One is about displacement current and one is about electromagnetic waves. So, in this electromagnetic waves topics, first of all let us discuss about what is the meaning of displacement current. Displacement current ID. So, what is the conduction current? Generally, what is the current? The rate of flow of charges through any connecting wire or conducting wire, so is called as a electric current, or that is conduction current, because of the flow of electrons through a conductor, so that current is produced. That current is called electric current, or generally conduction current. But so next, according to Ampere circuit law, for example, if you take so this is one closed path, one closed loop I am taking that. In this, some current, for example, current is coming out of the closed loop and one current is going so into the plane of loop like this. So some current is coming and some current is so into the loop, therefore that is the I2 nagar. Now what, in any closed path, according to Ampere circuit law, so what the line integration of magnetic field over any closed path B bar dot dl bar is always equal to mu naught times the net current so passing through that closed surface, and the current which comes out of the surface can be taken as, surface means closed loop, can be taken as the positive, which is entering into can be taken as negative. And if you take that so mu naught into, so that we can take I1 minus I2 is the, so Ampere circuit law we can study in the moving charges and magnetism actually, right? No, and so this is applicable, so when the current is continuously passing in that. But so this Ampere circuit law is failed when we apply in between the plates of the capacitor. For example, if you take the plates of the capacitor, for example, I am taking that this is the positive plate of the capacitor, this is the negative plate of the capacitor. When you connect it to a battery, right, so it provides a charge, therefore this becomes the positively charged and this becomes a equal amount of the negative charge. And when you switch on the battery, some current, that current is nothing but what IC. For example, if you take the closed path here, now what, this is a conduction current is passing, therefore we can apply so Ampere circuit law here. But in between the plates of the capacitor, so what is there? This is a gap, this is a completely air only, completely gap is there. Means what? So here, for example, if you connect one ammeter, so it shows the current, and if you connect the ammeter here, it shows the current. Means what? The current is coming again like that and the circuit is closed. But in originality, so the circuit is not closed because it is in between the plates of the capacitor. We maintain the gap, therefore the air is acting as the perfect insulator. Therefore now current has to stop here only. But if you connect the ammeter here and here, in both the places current is showing. Means what? The current which stops here coming from here. How it is possible? Because this is completely gap, nothing is there, so there is no any conducting path. It is completely pure gap only, there is no conducting path. So means what? So in between the plates of the conductor, if you apply Ampere circuit law, so that so integration of B bar dot so dl so is equal to mu naught into, in between the plates of the capacitor there is no current, is equal to 0. Therefore, the consistency or continuity is missing in the Ampere circuit law. Then afterwards, one of the scientists in the physics, Maxwell, so he suggested that compulsory in between the plates of the capacitor there is an equivalent current. That current is called as a displacement current. Right? No? So equivalent to conduction current. So again other current is compulsory has to produce, because this conduction current is equivalently coming from the, so this wire only. Means what? This is not acting even though there is no connection between the positive plate to negative plate, and what? Compulsory in between the plates of the capacitor another current has to travel, so that IC current is coming back to the same negative terminal, and that current is called as a displacement current. Yes, the conduction current in the connecting wire is due to what? Due to the flow of electrons. And who is the reason for the displacement current generated inside the plates of the capacitor? And that reason or the cause of displacement current is so what? So a rate of change of electric field. Means what? When you switch on slowly, so what? Electric field between the plates of the capacitor, what? Electric field between the plates of the capacitor, E is equal to, you can say, so Q by A epsilon naught, right? No? So here continuously on the plates of the charge, so charge on the plates of the capacitor, charge slowly increases. For example, 1 microcoulomb, 2 microcoulomb, 3 microcoulomb. So with respect to the time, the charge on the plates of the capacitor slowly increases. Therefore, when the charge increases slowly, the electric field is also increases. Therefore, now electric field is directly proportional to charge, and charge is directly proportional to time. Therefore, now compulsory due to variation of electric field with respect to the time. Electric field is only variable with respect to the time, not with respect to the space. Means what? At this point, at this point, at this point. So with respect to the space, okay, na? With respect to the position, the electric field is always uniform in between the plates of the capacitors. But with respect to the time, during the charging of a capacitor, once if the capacitor is fully charged, so the capacitor does not take extra charge from the battery. Therefore, at that moment, the electric field becomes maximum and so constant. Therefore, now in between, during the charging of a capacitor, in between the plates of the capacitor, electric field is only uniform with respect to the position, not with respect to the time. Right now, therefore, so due to the time, electric field is going to be changed. That electric field E is equal to Q by A epsilon naught. Now, so according to Gauss law, the total flux pi is equal to what? Pi is equal to, so we can say that is a Q by epsilon naught. If you take the, because so if you take the differential on both sides with respect to time, so d pi by, so dt is equal to, you can say 1 by epsilon naught, so dq by dt. Right? Now, so here you can say what? So dq by dt is what? So d pi by dt into epsilon naught is equal to, so dq by, so dt. This dq by dt can be taken as what? That is equal to id. Right? No? So that is called as a, so displacement current. Therefore, now the first expression for the displacement current, what we have? The first expression, so id is equal to given by, so what? That is equal to, so epsilon naught into, so d pi by dt, where pi is called as a, so electric flux in between the, so capacitor plates. First expression for the, so displacement current I is equal to epsilon naught into d pi by dt. Therefore, now if you convert into, now the second one is so E is equal to Q by A epsilon naught, and you can say what? So E into A is equal to what? E is equal to Q by A epsilon naught, correct? Because in place of this one, nothing but what? This is nothing but flux only. So according to Gauss law, electric flux is equal to charge by epsilon naught, that is equal to E into A. And in place of the flux, if you substitute E into A, now the displacement current becomes ED is equal to epsilon naught, so d by, so dt into flux place, you replace with E into A as area of the each plate is the same. Take outside, it is a constant. Therefore, now you can say, therefore, id is equal to epsilon naught A into, so dE by, so dt. So this is the one more formula for the, so electric displacement current. Therefore, when there is a change in electric flux with respect to the time, so id is equal to epsilon naught d by dt into E into AM. And so when the electric field and when the flux changes with respect to the time, id is equal to epsilon naught d pi by dt. And when the, so electric field changes with respect to the time, id is equal to epsilon naught A into dE by dt, another expression. And one more expression is also there. For example, now, so this is one more expression for the displacement current. So we know that between the plates of the capacitor, the potential difference V is equal to what? So E into D. That is the potential difference between the plates of the capacitor, where E is the electric field existed in between the plates of the capacitor, D is the separation between the two plates. Therefore, now from this we can say, now from this we can change as electric field E is equal to V by D. Again in place of the E you can substitute V by D. Therefore, now you can say what? The displacement current ID is equal to epsilon naught A d by dt of in place of the electric field. If you write that is a V by D, again this D is constant. This D is constant, distance between the plates of the capacitor constant, and if you bring outside, so you can get what? That is equal to epsilon naught A by D. So into, so that is the, so dV by dt. That is the dV by dt, and again you know that epsilon naught A by D is the capacitance of a parallel plate capacitor. Therefore, now you can say that finally ID is equal to what? Is equal to C into dV by so dt. This is the displacement current, one more expression, right? And so numerically means the cause of conduction current is different, the cause of displacement current is different. The cause of in conduction current is flow of electrons continuously through the connecting wires or conducting wire, so the charge has to travel. But in case of conduction, in case of the displacement current, so between the plates of the capacitor, charge is not transporting. So what? The charge slowly increases. Due to the charge increases, electric field increases due to change of electric field with respect to the time on the plates of the capacitor. So what? The electric field changes with respect to time, that causes what? A displacement current. Therefore, the cause of displacement current between the plates of the capacitor is so change of electric field with respect to the time, not with respect to the position. Be careful, because with respect to the position, electric field is always uniform. So while explaining the capacitor concept, we will say the electric field between the plates of the capacitor is always constant, but that is according to position, not with respect to the time, until so completely charging the capacitor. Therefore, now, so these are the three expressions for displacement current. And after completion of this one, so Maxwell proposed so one more equation for, and which is change of Ampere circuit law. Now we can call modified Ampere circuit law, or so we can call, so what? That is Maxwell's Ampere circuit law. So what we can say now? Now according to so Maxwell's Ampere circuit law, the line integral of magnetic field over any closed loop is given by delta is equal to so mu naught into so IC plus ID. That's it, and that you can say mu naught into so IC plus epsilon naught, so d pi by dt is the case. But one thing you keep in mind, displacement current and conduction current both will not be exist at a time, same time they can't exist. Where conduction current is equal to 0, displacement current will be existed. Where displacement current is 0, conduction current will be existed, and you know both are numerically equal. Therefore, now what? IC is always equal to ID, and you know, and so if IC is equal to 0, so ID not equal to 0, and if so ID is equal to 0, compulsory IC not equal to 0, because the consistency has to follow according to Maxwell's Ampere circuit law. Therefore, this is the modified Ampere circuit law or Maxwell's Ampere circuit law. So mu naught here extra, according to Maxwell we added displacement current also. Therefore, now what? Numerically which are both are equal, IC is equal to ID. Now based on this, let us solve some numericals. Some numericals. Now here the radius of circular plates. So now numerical number 1. The radius of circular plates of a capacitor is given by, that is equal to 0.1 meter. Next what? The distance between the two plates of the capacitor, D is equal to, they have given 0.5 millimeters. Next what they have given? The rate of change of electric field So dE by, so dt is equal to, so that is the 5 into 10 power, so 13 Newton per Coulomb second, and they are asking, so what is the displacement current ID is equal to how much? So displacement current we have to find out for this one. And so what we can get now, so here, so ID is equal to what? So area we have to find out. So what is the area? Now from this, first of all, if you know, the area of the plates of the capacitor is equal to, they mentioned circular plates. When they are mentioned circular plate, I is equal to pi r square, 3.14 into r is equal to 0.1. We can take 1 into 10 power minus 1 whole square, that is equal to 3.14 into 10 power minus 2 meter square. This is the area. So next what? So what is that d by dt given? But distance is not used here, because according to rate of change of electric field, the displacement current expression what? So ID is equal to epsilon naught A into, so dE by dt only. Therefore, epsilon naught value how much now? Epsilon naught is equal to 8.85 into 10 power 12, so Newton meter square per Coulomb square. ID is equal to epsilon naught A dE by dt apply. So you will get the answer. Therefore, after writing the expression, you can say, so ID is equal to, or direct you can substitute there, that is equal to how much now? So this is epsilon naught 8.85 into 10 power minus 12 into area we have 3.14 into 10 power minus 2 and into d by dt is equal to, so 5 into 10 power 13. If you substitute all values and after simplification, here already I have solved this problem, that is equal to, so roughly you will get that is equal to 14 ampere. So not exactly, so roughly we can get 14 ampere nearly, right? ID is equal to 14 ampere. Next, one more problem is, for example, the flux inside a capacitor changes with time pi is equal to, so t square plus 2t plus 1. The flux inside the plates of the capacitor changes. If it changes accordingly, so with so time as pi is equal to t square plus 2t, so plus 1, then they are asking what is the displacement current at so what time t is equal to 1. Therefore, if you take t is equal to 1, means what? At time t is equal to 1 second, so what is the displacement current? ID is equal to how much? Now the options I will give. For example, A, B, C, D, that is epsilon naught, 2 epsilon naught, 4 epsilon naught, and that is none of the above, for example. Okay, because let us see whether which one option is correct. Therefore, now what? So after one, second displacement current. So what is the d pi by dt? First of all, d pi by dt we have to find out. D pi by dt, so is equal to how much? That is so 2t plus 2 plus 0, and d pi by dt value at t is equal to 1 second is given by, so 2 into 1 plus 2, that is equal to what? 4 Therefore, now what? So the displacement current expression what? ID is equal to given by, so epsilon naught into, so dE by dt. Therefore, that is equal to epsilon naught, this is the flux. Therefore, so d pi by dt, and this d pi by dt is equal to 4. Therefore, 4 into epsilon naught is the correct answer, like that. Okay. So from the electromagnetic waves, the questions are simple, and every time compulsory there is one questions regularly asking. So from this topic, next. One more numeric. For example, here the distance between the plates of the capacitor given, d is equal to 2 millimeters, and that is equal to 2 into 10 power minus 3 meter, and the area of each plate is equal to 60 centimeters square, and that you can write, so 60 into 10 power minus 4 meter square, and that is equal to 6 into 10 power minus 3 meters square. And so the potential is given by V is equal to 400 volts and the time period T. In a time period T is equal to, so 1 into 10 power minus 6, they are asking what is the displacement current ID is equal to how much? ID value how much? That is the data. So here generally what we have taken, so in terms of the voltage, rate of voltage, so ID is equal to C into epsilon dV by dt, correct? But first of all, here we have to find out, so effective capacitance, the capacitance how much? C is equal to epsilon naught A by D, and C is equal to 8.85 into 10 power minus 12 into A is equal to, we have that is 6 into 10 power minus 3 by, so D is equal to how much they have given? D is equal to 2 into 10 power, so minus 3 meters. So after simplification, so you are getting some, so answer for that, that is the, so farad in terms of the farad, microfarad and nanofarad, just you can, so you will get the answer for that. Then after what? So after that, now the displacement current ID is equal to given by, so what is that? There is a C into dV by dt, correct? But the rate of voltage in this they have not given. So what that is given, ID is equal to C into, so dV by dt only. Therefore now what? ID is equal to, so you can change it as a C into just voltage by time period you take, so you can get the answer. So C is equal to, after completion of all values, after substituting all these values, so you can get that, so approximately the answer is ID is equal to, so approximately, not exactly, that is equal to 1 into 10 power minus 2, so amperes you will get, or that is equal to, so 10, that is 0.1 milliamperes also you can convert, therefore 1 into, so 10 power minus 2, or sorry, that is you can convert as 10 into 10 power minus 3 ampere means what? Roughly, so 10 milliamperes you can use. That is the answer for that. So it is not exactly 1.00 something you will get, and after rounding of that number, so you can get what is that? The 10 milliampere, and here you calculate, because all these problems once I have solved, therefore now what? All you can get the answers very easily. So next, let us see last problem in this discussion. Now, one problem is, so the capacitance of a capacitor is, third or fourth problem, that is the capacitance of a capacitor is given by C is equal to 100 picofarad, that is equal to 1 into 10 power, pico means 10 power minus 12, this you can get 10 power minus farad, that is the capacitance. And so the voltage, the potential difference applied is given by 230 volts, and the frequency, the angular velocity omega is equal to, so 300 radian per second they have given, 300 radian per second, and they are asking that what is the RMS value of, what is RMS value of ID, what is the RMS value of displacement current. So that is nothing but actually the problem is related to AC, alternating circuit. So generally what? C is equal to 100 picofarad we have given. So C is equal to 1 into 10 power minus 10 farad, and V is equal to 230 volts. So omega is equal to 300 radian per second. So what is the RMS current? So yesterday in the alternating current point we have discussed. What is that? So the given voltage with the given frequency compulsory. Generally alternating voltage expression what will you take? So V is equal to V naught sin omega t, like that we can take, or V is equal to V naught cos omega t, we can take that generally. But if they will ask, this is what so peak value that is the peak value, and the RMS value is given by V RMS is equal to V naught by root 2 we can take. But here instead of this equation, if they will give direct value 230 volts, the given value always should be taken in the RMS value only. So this is nothing but a VRMS value, and VRMS is equal to 230 volts only. Because so every hot wire ammeter or every so AC meters always gives or always measures RMS values only. Therefore, direct I am taking that. So first of all, we have to find out so IRMS value. So IRMS value what now? IRMS value is equal to, so what? That is equal to VRMS by what? That is equal to XC. Where XC is what? Capacitive reactance. This is nothing but what? So ID, so RMS value. That is given by VRMS is equal to 230, and XC value what? Here only better you can take so VRMS by so 1 by C omega. Correct? Because so the capacitive reactance XC is equal to 1 by C omega, and the inductive reactance XL is equal to L omega. So this omega goes upside, therefore finally you can say it is equal to C omega, so VRMS value. Therefore now what, if you substitute all values, 230 into capacitance how much given? So 1 into 10 power minus 10 into, so that is 230, and so that is 300, and after simplification you will get that value is given by how much? That is so that value after simplification, so you will get so 7 microampere roughly. After solving, so all values you are getting how much? 7 microamperes, you will get that. That is the RMS value of the current. But instead of the 230, if they will give like this, V is equal to V naught sin omega t. First of all, we have to find out the VRMS value from the VRMS value by V naught by root 2. Then after getting the VRMS, same procedure we have to follow. Okay, na? This is the model question. Next one problem. Last problem. So the radius of a circular plate capacitance of a capacitor R is equal to 12 centimeter. That is equal to 12 into 10 power minus 2 meters. Adu radius, and the separation between the plates D is equal to 5 millimeters. 5 millimeter means 5 into 10 power minus 3 meters. Next, the displacement current they have only given. ID is equal to, so 0.16 ampere. Displacement current given, they have only given. So they are asking that, so what is the rate of change of potential difference between the plates of the capacitor? dV by dt is equal to how much? Direct you can take the formula. So what is that? Displacement current ID is equal to epsilon naught A by D. So into what? Into dV by dt. First of all, we have to find out the capacitance. So ID given, ID is equal to epsilon naught is equal to 8.85 into 10 power minus 12. So first area find out. So A is equal to, that is pi r square, and D direct given 5 millimeters. And after completion of that, so here what you can get number? So ID is equal to C into dV by so dt. After that, so dV by the rate of change of potential difference is equal to ID by C. Okay, first of all, find out the capacitance from the given data, and ID value 0.16 ampere. Substitute there, you can get the answer. That answer for this question is so after calculation, so you will get 2 into 10 power 9 volt per second. So means for every 1 second, 2 into 10 power 9 volts means changing for every 1 second. So these are the questions related to the displacement current. Now let's go electromagnetic waves. So what are the electromagnetic waves? All those you can understand from the theory. Right now just only 5 minutes for the theory points. Then after 2-3 problems let us discuss. Now see what are the electromagnetic waves? Electromagnetic waves are produced for what? In which case? When a charged particle is at rest or moving with or is at rest, it produces only electric field. When a charged particle is in motion, is moving with uniform velocity, it produces electric field as well as magnetic field. When a charged particle is accelerating or oscillating or vibrating, right, no, in that case, along with electric field, magnetic field, it produces some waves. Those waves are called as electromagnetic waves. Therefore, to produce electromagnetic waves, the charged particle has to accelerate or retard. Therefore, in that cases, the charged particle what? So will be producing the electromagnetic waves, and those electromagnetic waves are transverse in nature. What is the meaning of transverse in nature? So when the wave propagating in one direction, so the particles of the medium vibrate perpendicular to the wave propagation. When the wave propagating along the x direction, the particles of the medium either may vibrate in the y direction or in the z direction. Y and z both are perpendicular to the x axis. Therefore, that is called as the transverse wave sum. So generally, and the electric and magnetic field both are perpendicular to each other and both are in the same phase. For example, so let me take, so this is the x axis and this is the y axis, this is the z axis. I am taking that. For example, if you take, so this is the electric field, exactly perpendicular to it, magnetic field will be produced like this. This is the magnetic field. Means what? So the electromagnet, for example, this is what electric field if you take, this is the electric field if you take, and this is called maximum value of electric field, that is called amplitude of electric field E naught. And so this is called what? This is the, so it is present in the, so z axis, no. So now what you can say, it is the, now it is the, so this is the B naught, you can take, it is the maximum, this is the magnetic field. This is what? Magnetic field, B field, I am taking that. Magnetic field or B field. Therefore now what? This is the maximum value. Therefore, so here the electric field is oscillating, so what? In the xy plane, and so the magnetic field is oscillating in the xz plane. And here what is that? So along the x axis, so the wave is propagating. This is the propagation direction. This is the propagation direction. Therefore now what? Electric field is along the y axis and magnetic field along the z axis, and what? So the propagation means what? The wave velocity. For example, if you take the c is the speed of the electromagnetic waves in the vacuum, all electromagnetic waves travel with a speed of the light, that is equal to 3 into 10 power 8 meter per second. Therefore, in this direction the wave is propagating. Therefore, electric field, wave propagation and magnetic field, all three are mutually perpendicular to each other. And so if the wave is propagating along the positive x axis, then the electric field is given by, so at the instantaneous electric field is given by, so E naught sine of omega t minus kx. So and the magnetic field is given by B is equal to B naught sine omega t, so minus kx. So what I told you here, so both are, means when the wave is propagating along the x axis, here compulsory x we have to take. If wave is propagating along the y axis, E naught sine omega t minus ky you have to take. If the wave is propagating, so along the positive z axis, so omega t minus kz we have to take. Therefore, in what direction the wave is propagating, in that direction, so what here, what term is there? X. If it is there x, we have to think, yes, the wave is propagating along x axis. If it is the y, ky, so we can think, yes, so the wave is propagating along the positive y axis. Therefore, based on this term which is besides of the k, so we can decide, so what is the direction, either along x axis or y axis or z axis, we can decide about. Therefore, now what? These are the wave equations. When both are traveling in the positive x axis. Right now, and so if you take, this is the y and this is compulsory what? Bz we can take, because Right now, again what I told you, so both are perpendicular to each other. Therefore, if the electric field is propagating, so in the y direction, I mean, if the direction of electric field is along the y direction and the direction of magnetic field of the electromagnetic along the z direction compulsory, both should not be in the same direction. That's why better to represent their direction also. Bz is equal to b naught sin omega t minus kx. Now, so here what is the E naught? E naught is called as what? So, amplitude of the electric field or peak value of electric field or maximum value of electric field. B naught is called maximum value, amplitude or peak value of the magnetic field, and the relation between them is given by, so C is equal to, always remember, that is equal to, so E naught by B naught. So, the C is what? Speed of the light in the vacuum, that already you know that. So, 3 into 10 power 8. So, that is equal to, always one more expression we can say, that is what? 1 by, so root over, so mu naught epsilon naught. So, mu naught value what? 4 pi into 10 power minus 7 Henry, and epsilon naught is equal to 8.85 into 10 power minus 12, and you know this value will come from here only. If you substitute mu naught is equal to, so what? Mu naught is equal to 4 pi, so into 10 power minus 7 Henry per meter, and so epsilon naught is equal to 8.85 into 10 power minus 12, so Newton meter square per Coulomb square. After simplification you will get so this value only. So, from this one we can get, and you know, again you can say, so mu naught is equal to, you can write, that is equal to what? 1 by root over, so mu naught you can write, so what? Mu into, so mu r, because relative permittivity what? So mu r is equal to, you can say that is equal to what? So mu by, so mu naught na, therefore now what? So sorry, here mu r is equal to mu by mu naught. Relative permeability. Therefore, now what we can say, so this you can say mu r is equal to mu by mu naught, means what? If they will give the mu is equal to mu r into mu naught. Therefore, in any other media, so V is given by what? V is equal to given by, so C by under root of mu r into epsilon naught r will come. In any other medium, if you take, so if any, this is what? Only in the free space. In the vacuum or in the free space this value, but in any another media, in any other media, V is equal to C by root over mu r epsilon r, where mu r is equal to relative permeability of the medium, and epsilon r, it is the relative permittivity of the given medium, and those can be related to as what? Mu r is equal to mu by mu naught, and mu is equal to, you can write mu r into mu naught only. Therefore, now what? This is a velocity direction. Next. So, how to decide the direction of electric and magnetic fields? So, the direction is given by the direction relations. The directions are related as, so V bar is equal to always, means what? The direction of V bar is always in the direction of E bar cross B bar. So, remember, V bar, I am not taking V bar is equal to E bar into B bar, I am taking what? So, the direction of V bar is always in the E bar cross B bar. Okay. For example, what is the meaning of it? I will say. For example, so electric field I am taking what? E bar acting along the, for example, so that is the z axis, means what? Y axis, and so magnetic field acting along the positive z axis, you can take what? K cap. So then what is the direction of propagation? Direction of propagation what? Therefore, now what? Here in case of, so E bar cross B bar. So E bar cross B bar direction nothing but what? Wave propagation. Or you can take C bar. That is called what? I cap. So J cap cross K cap, and you know J cap cross K cap nothing but what? That is equal to I cap, because in the cross product of the vectors there are the rules are there or not. So I cap cross J cap is equal to K cap, and what we can say, and then after J cross K cap is equal to what? That is equal to, so I cap, right? No, next what? So K cross I is equal to J cap. So here in this previous case we can take what? That is a minus will come, because so J cross we can take I. Correct or not? In the previous what I told you now. So along the x-axis who is there? So along the x-axis velocity present. Therefore now what? E bar is equal to j and b bar is equal to k cap. Therefore now what? So the cross product of them nothing but j cross k. J cross k nothing but what? So along the positive x-axis. Therefore by using this we can represent. Okay na? So this is very important to represent the direction. Now let us solve some sums on this one. Some sums let us solve on this one. The peak value now. So the peak value of electric field is given by E naught is equal to 120 Newton per coulomb they have given. The peak value of electric field is given by, and the frequency F is equal to 50 megahertz. So nothing but what? 50 into 10 power 6 that is equal to 5 into 10 power 7 hertz we have taken. So next what they are asking that so expression for B. So B is equal to how much? Expression for the B they are asking. How to find out the expression for B? Just they have given that's information only, right? So from this, how to find out? So what is the magnetic field? Let us take that magnetic field, and the wave is propagating along the x-axis. In the question they will mention an electromagnetic wave is propagating along the positive x-axis. Therefore now, so what is that? B is equal to B naught omega t minus kx, correct? Here all values we have to find out, sorry. So B is equal to B naught sine of omega t minus kx we have to find out. Here thing is what? B naught we have to find out, omega value we have to find out, k value also we have to find out. All values we have to find out first of all. First of all, B naught I am calculating. B naught value how much? So now what? B naught is equal to given by, so E naught by C, correct? Just because I have given C is equal to E naught by B and B naught is equal to E naught by C. So E naught value how much? 120. C is equal to how much? 3 into 10 power 8. That is equal to, after solving you can get, that is equal to 4 into, yes, that is what? 10 power 8. So 3 4s, therefore 4 into 10 power, so minus 7 Tesla we can get it. That is a magnetic field peak value. Next, how to find out the omega? So omega value. Omega is equal to what? Omega is equal to 2 pi f, and if you substitute, so what? That is 2 into, so pi value estimate that is equal to, just to better use 2 pi, so into what? 50, so 50 mega 5 into 10 power 7 that is equal to what? So 2 pi into 5, so therefore 10, therefore 6.28 into, so 10 power 8, and this you can take, correct? 5 to the 10, so 10 into 10 power 7, here we got 10 power 7, 10 power 8, therefore 6.28 into 10 power 8 we got so radian per second. So this is the omega value. Next what we have to find out? K value. To find out the K value, K is equal to what? 2 pi by lambda. Generally the K is called propagation constant, or we can call wave number. Right now that K, omega is called angular frequency of the electromagnetic wave, and K is called propagation constant. That propagation constant is relating with wavelength K is equal to 2 pi by lambda. So but again we don't know what is the lambda. Lambda value we don't know better. And so lambda value how to find out? Therefore lambda is equal to C by F, because the frequency and so wavelength of any wave related like this. C is equal to F into lambda, or velocity V is equal to F into lambda, and lambda is equal to C by F, and that is equal to 3 into, so 10 power 8 by, so F value, F is equal to how much given? So 5 into, yes, 5 into 10 power 7, and that is equal to, so this is the lambda, you can get the answer as a 6 meter nana, right? 6 meter you can get, because it is a 3 by 5 means 0.6. So 0.6 into 10 power 1. Therefore, yes, 6 meter you can get the answer wavelength. And after that, the propagation constant K is equal to given by. So this is 3.14. No, 5 2 is the 10. So pi is equal to 3.14. Yes, sorry for that. This is a 3.14 only because 5 to 10, yes, 3.14, and here what, 6 meters, and k is equal to what, Nana? That is equal to 2 pi by lambda, that is equal to, so 6.28, because, so 2 into pi value 3.14, and lambda is equal to how much you got? That is equal to 6. So approximately, so 1.05, so per meter you can get, or radian per meter you can get. That is the radian per meter you can get, and all values you substitute in that expression, so you will get the answer for that. Now what? So B is equal to what? B is equal to B naught sine omega t minus kx. Therefore, if you substitute there, so B is equal to what, Amma? So B naught is equal to the, we got, so how much it is? B naught is equal to 4 into 10 power minus 7 in sine of, so omega value we have, omega is equal to, so 3.14 into, so 10 power 8 t minus kx value. So almost you can take 0.5, so into x, therefore now what? So that is the expression for magnetic field. Okay, so these are the problems, and some other problems also there, and we can find out, and last one problem let us solve. And here electric field will give, in terms of electric field they will give, and they will ask that what is the direction of magnetic field also. So first in this form, so for example Ey is equal to, so E naught sine omega t minus kx they will give, or they will give like this, Ex is equal to omega t minus ky. What is the meaning of it? Therefore now what? The wave propagating is along the positive x-axis, and so the electric field is oscillating in the x direction. Then they will ask that what is the magnetic field. So therefore now first of all here E naught given means compulsory immediately, indirectly they have given B naught only, because both are related with what? So C is equal to, so E naught by B naught. Both are related as so C is equal to E naught by B naught. Here you know E naught volume means they have given B naught only, and as I told you, both are of same phase. Same phase means what? Sine function of the both of them is same, and this angular function omega t minus ky also for both of the vector, both are the waves, electric field and magnetic field, both of them is the same only. Therefore now what? So E naught sine omega t means direct we can find out, but thing is here they have given this is the Ex. So this is the y, this is the x. Therefore now the magnetic field along the z direction. But which direction? Positive z direction, negative direction, we can decide by using that information. So I cap is equal to j cross k, and j is equal to k cross I. By using that information, so we can find out. And one more important, if the, for example, same, if the wave is propagating along the positive direction, so here we have to take what, plus omega t, sorry, negative direction, omega t minus ky. So y plus replace with minus, minus into minus plus, therefore omega t plus ky you can take that. Therefore this is the wave propagating along the negative y direction. So omega t plus ky will come. And if the wave is propagating along the positive y direction, omega t minus ky will come. Along the positive, omega t minus ky, along the negative, omega t plus ky. Remember like that. Therefore, when they will mention, so along the positive x-axis, negative x-axis, automatically direction will be changed. Because in the options, they will give that direction also. Along the negative x-axis, along the positive x-axis, along the negative y direction, along the positive z direction. All those are can be decided by only cross product rule. I cross is equal to j cross k, all these. Therefore, last one sample problem let us discuss. Now, one problem here. The speed of electromagnetic wave in a medium is given by 2 into 10 power 8 meter per second. That is a not space. So the wave is not moving in the space. If it is moving in the space or vacuum, C is equal to 3 into 10 power 8 meter per second and V is equal to 2 into 10 power 8 meter per second, and so the relative permeability mu r is equal to 1, and so the relative permeability is equal to 1. They are asking what is the relative permittivity of the medium they are asking. So what is the relative permeability of the medium? So what we can get now? So I have given one formula. What is that? So V is equal to always C naught by, C by, so under root of what? So mu r into epsilon r. Therefore now what? That is equal to, so this V value how much given? 2 into 10 power 8 is equal to, so 3 into 10 power 8 by mu r value 1 given. Therefore square root of so epsilon r, and this 10 power 8 cancel, and the root over, so epsilon r is equal to what you can get, that is equal to 3 by 2, and if you take the square on both sides, so epsilon r is equal to 9 by 4, that is equal to, so 2.25 is the answer for that. Okay, so these are the model problems, and other problems also there, and be careful. So this form electric field they will give, they will ask magnetic field, and the thing is everything is okay, only to decide the direction is somewhat a problem. Therefore that directions can be decided by using the vectors rules, and remember the vectors rules. So I cap is always equal to j cross k, and this rules only the cross product vector rules. So I cross is equal to j cross k, and j is equal to k cross I, and k is equal to I cross j, like that. Okay, na? Therefore, so these are the vector rules and electromagnetic waves. So thank you all.
Okay, Amma. Good morning, all of you. Today, I am going to discuss about last topic of the organic chemistry. That is what biomolecules. In these biomolecules, mainly we will discuss about carbohydrates and amino acids. Remaining part is total theory part, that is what nucleic acids, enzymes, vitamins and hormones. So totally 6 topics are there, and that mainly we will discuss 2 topics. Remaining 4 topics are total theory part, that we have to concentrate that compulsory. They are asking 2 questions from this chapter, biomolecules, right? So first one, what are the concepts we want here? Concepts say questions now, right? First one, biomolecules we have to discuss about. First part is carbohydrates. In these carbohydrates, mainly we will discuss about monosaccharides, polysaccharides and oligosaccharides. Monosaccharides, oligosaccharides, third one is polysaccharides. These 3 are very, very important. What are the examples are they? So what type of bonds are forming, what type of peptide bonds are forming, then we will see one by one now. First one, monosaccharides, oligosaccharides and polysaccharides. Monosaccharide means the carbohydrates which cannot hydrolyzed further, those are called monosaccharides. Most of the monosaccharides are in our exam, our textbook, glucose, fructose, like this. Next one, oligosaccharides. Oligosaccharide means the carbohydrate which on hydrolysis will give the 2 to 10 monosaccharide. So if you take any carbohydrate that will break down, hydrolysis will get the 2 to 10 monosaccharides you are getting, that is called oligosaccharides. If you are getting 2 saccharides, one carbohydrates you are hydrolyzed, you are getting 2 saccharides, that is called disaccharide. 3 monosaccharide you are getting, those are called trisaccharide, like that 10 up to 10, that is called oligosaccharides, right? One of the example of oligosaccharide is sucrose. Second one is maltose. Third one is lactose. These are the mainly our oligosaccharides. These two also, this one the hydrolysis will get the 2 monosaccharides. This also hydrolysis will get the 2 monosaccharides. This also will hydrolyze will get the other 2 monosaccharides. These 2 are called oligosaccharides. These 3 are called oligosaccharides, also called disaccharides. Someone also trisaccharide like that will be there, that we don't want now, that will leave it. Next one, polysaccharide. Polysaccharide means carbohydrates which on hydrolysis will give the more than 10. That means many more monosaccharides. That means simply our understanding point, 10 greater than 10 monosaccharides you are getting. That type of saccharides are called what you call polysaccharides. And that polysaccharides our syllabus is, one of the polysaccharides is starch, cellulose, glucagon. Usually now, these are the polysaccharides total, right? Monosaccharides, oligosaccharides and polysaccharides. Next one, some other important point or the important point, observe clearly. Based on the reducing nature, carbohydrates are classified into 2 types, that is called reducing sugars, other one is non-reducing sugars. What is reducing, other what is non-reducing, very, very important. Reducing sugars means the sugars which can reduces, otherwise the carbohydrates which can reduces Tollens reagent and Fehling's reagent. Tollens reagent and Fehling reagent. Therefore, already I discussed on the Tollens and Fehling reagent in carbonyl compound chapter. So, the carbohydrates which can reduces Tollens reagent and Fehling reagent is called as reducing sugars. What are the reducing sugars we are having in the syllabus? All monosaccharide, very very important. All monosaccharides and all disaccharides. All disaccharides I am saying now, not all oligosaccharides, all disaccharides, this only now. All disaccharides except, very very important, except sucrose. Sucrose is a not reducing sugar, that is non-reducing sugar. Next one, non-reducing sugars. The carbohydrates are the sugars which cannot reduces the Tollens reagent, which cannot reduces Tollens reagent and Fehling's reagent is called as non-reducing sugars. What are the non-reducing sugars are they? One is sucrose, that is sucrose is disaccharide. Disaccharide is, I said all disaccharide except sucrose, that means sucrose is, it is not a reducing sugar, means that is it is a non-reducing sugar, sucrose, and all polysaccharides. That's what you should know. What are the monosaccharides examples are there, what are the disaccharide examples are there, what are the polysaccharide examples are there, that you should know. Yes, already I given. Sucrose and all polysaccharide means what is that? Starch, cellulose, glucagon. These all are what you call non-reducing sugars. Right. Simple logic and simple point I will tell you. The carbohydrate which one want to can say means reducing sugar want to say means it can reduces Tollens and Fehling reagent means whatever the carbohydrates are there, that carbohydrate must containing the free aldehyde group, free carbonyl group simply, that means free aldehyde group, already I told you. So Tollens and Fehling reagent use is what now? Distinguish between aldehydes and ketone. So which functional group means which carbohydrate is having the aldehyde, which carbohydrate having the ketone. Carbohydrate having the aldehyde means it will reduce, carbohydrate which is not having the aldehyde, that is will not reduce. Like that we can identify. So which carbohydrate is having the free aldehyde group is the hint. Which carbohydrate is having the free aldehyde group? Free aldehyde group is there, that carbohydrate can reduces Tollens reagent and Fehling's reagent. That means those are called reducing sugars. And that what are those free aldehyde groups? What is the present? One is compulsory glucose, very very important. Second one is fructose. Actually sir, this glucose aldehyde sir, fructose is ketone is there sir, then how can you reduce? Some other way is there. So that is later explanation. Fructose also will reduces, that is because this glucose and fructose both are monosaccharides, but this is containing aldehyde group, this is also containing ketone group. Ketone group is also there, then how it will reduce, then some other way is there, then later I will explain. Glucose and fructose, next one all monosaccharides and disaccharides. What are the disaccharides? Sucrose, maltose, lactose, except sucrose, that means what? Maltose, and next one is lactose. These are the, in most of our syllabus is there now. These are called what? Glucose, fructose, maltose, lactose. These are called reducing sugars. Reducing sugars. Except these four, remaining any one is there, those are called non-reducing sugars. That is only way of identification. So explanation is there. Explanation is based on the structure. Right? Now observe here, next one of the point here. Now I am going to say the structure of glucose first. If you know the structure of glucose and structure of fructose, you will get the all disaccharide structures, you will get it now. If you know the disaccharide structures, what they are asking here, glycosidic bonds they are asking now, one of the time, not one of the every time they are asking now. So glucose, fructose, next one is all what you call disaccharides. What are the disaccharides? Sucrose, maltose, lactose, cellulose and starch they will give you one side. Other side they are giving what they are giving? Other side they are giving what you call glycosidic bonds or glycoside linkage they are giving now. So match the following they are asking now. You should know the match the following means we should know the structure. First which structure you have to know? Glucose, fructose. First glucose. Right, some of the questions I am giving to you know. one or two times they are asked the questions. Observe this one. This is the structure of glucose. That means glucose is C6H6O6 is the glucose structure. This is called what do you call Fischer-Ring projection formula. Then what I am doing now, I am heating with HI. Glucose treated with the HI and followed by heating. Then what I can get the product? What I can get the product means total how many carbons are there? 6 carbons are there. You will get the like this. 6 carbon straight chain. 1, 2, 3, 4, 5. So 6 carbon straight chain. That means what I can get? What is the name? That name is called as N-hexane. This is called N-hexane. N-hexane is a straight chain. That means this indicates what? What are indication? This indicates what? Glucose contains the 6 carbons in a straight chain. That is the meaning of that one. So when glucose is treated with HI, I am getting what? N-hexane. That indicates what? Glucose containing what? How many carbon? 6 carbons with straight chain. Same glucose treated with other one is hydroxylamine. Hydroxylamine. Hydroxylamine means here what is there now? C11OH, that means aldehyde here. This hydroxylamine means yesterday I told that is called ammonia and ammonia derivatives. Ammonia and ammonia derivative is there. What you have to remove? Carbonyl group is all, that is what keto, that is oxygen here H2. Water you have to eliminate, remaining you have to add. So remaining group as it is CHOH4, CH2OH. Then what I can get? C double bond N OH. Here already H is there. This is called oxime. This oxime indicates glucose containing the carbonyl group. In the presence of carbonyl group. This is indicate presence of carbonyl group. Why I am saying carbonyl group? Because hydroxylamine, where is it adding now? There is attacked, where is reacted? Where the carbonyl group is there only reacted. That's why this meaning, this indicates glucose containing carbonyl group. That carbonyl group may be either aldehyde or ketone. We don't know. That we can't decide now. This using this carbonyl means glucose contain the carbonyl group. Not only this one, you can reacting with HCN also, hydrogen cyanide. Hydrogen cyanide means this how it dissociate H plus and Cn minus. There also your bond is breaking like this, bond is moving like this. Why? Carbon and oxygen, oxygen the more electronegative than carbon. Electrons are moving towards oxygen side. So oxygen getting which charge? Negative charge. Negative charge means hydrogen will be added. Carbon getting which charge? Positive charge. That means nucleophile will be added. So answer is, I am writing here C, Cn, OH, H, remaining as it is. C, Cn, OH, this is called cyanohydrine. Cyano with OH, that is called, OH is called cyanohydrine. This is called oxime, this is called cyanohydrine. When cyanohydrine, HCN, when treated with HCN, when oxime, when treated with hydroxylamine. This indicates glucose containing the carbonyl group. Glucose may containing carbonyl group. Carbonyl compound or carbonyl group may be aldehyde or ketone. So that how can you decide? Next step, same glucose treated with bromine water. Bromine water is called mild oxidizing agent. Mild oxidizing agent. Then what I can get? Oxidizing agent means directly here what is the functional group is there? What are the functional group is there? That final functional group is converted into one step. Means reaction will take place to one step. For example, there alcohol is there. Alcohol is converted to aldehyde. Then aldehyde is there. Aldehyde is converted to what? Carboxylic acid. Then what I can get here? Aldehyde group. Like this. When treated with the bromine water to form this group is converted, this group, what are the group is? This group is converted into carboxylic acid. This group is converted to carboxylic acid means from here to here is how many steps? One step. One step means this group containing, this group already I told carbonyl group. The carbonyl group must be aldehyde. Aldehyde because aldehyde is converted to what? Carboxylic acid. This is called as gluconic acid. When you are getting gluconic acid, when glucose is treated with the bromine water, This is mild oxidizing agent to form a gluconic acid. This indicates glucose contained in the functional group is aldehyde. Next one, when glucose or glucanoic acid, is treated with the dilute HNO3, dilute to concentrate, already I told you, dilute HNO3, concentrate HNO3 both are strong oxidizing agent. When glucose is treated with HNO3 to form what? COOH 4 times. This alcohol also converted into COOH. That is called, that means what? This aldehyde group is converted to carboxylic acid. Yes. Again alcohol also converted to carboxylic acid. That means this is strong oxidizing agent. That means what? Alcohol also will oxidize. Alcohol to first aldehyde, aldehyde to again acid. That means multi steps. That is it is acting as a strong oxidizing agent. This is called what? Saccharic acid. When glucose is treated with HNO3, dilute HNO3 to form a saccharic acid. This is called saccharic acid. Saccharic acid. Otherwise, gluconic acid also treated with HNO3 to form this one only. That is called saccharic acid. That is the meaning. What happened here? It is converted to saccharic acid means then which one is converted to acid? Aldehyde is converted to acid. Already glucose contains aldehyde already we decided. Now which group is converted again? Converted to carboxylic acid. This is the last one. Last one is what? Alcohol. Alcohol is converted to what? Carboxylic acid. That means that which alcohol? Primary alcohol. So that means primary alcohol undergo further oxidation and getting what? Carboxylic acid. That means glucose containing how many primary alcohols? One primary alcohol. One primary alcohol. Later, this is treated with the acetic anhydride, last step. Acetic anhydride, how many times? How many moles? 5 moles. Here 4 OH, here 1 OH, total 5 OH. 5 moles of acetic anhydride to form glucose pentaacetate. CHO as it is, CH. Here anywhere you can break down bond, your choice. Here this side or this side, carbon oxygen bond. Here carbon oxygen, this side, this side. So this is the byproduct. CH3, C double bond O with H. How many H is there? Here 4, here H1, 5, total 5 H. This acetic acid eliminate. Now this group will be attached. So CH, what is there? O, H eliminated. What group? Which group attached now? Acetyl group. COCH3. Here how many times? 4. Here down 1. CH2O CH3. O COCH3. This is called ester group. This is called glucose pentaacetate. This indicates what? Glucose pentaacetate is 4 plus 1, total 5. Pentaacetate. That's why this is treated with the 5 moles of acetic anhydride. Glucose pentaacetate. This indicates glucose pentaacetate, how it is changed? So 5 OH groups are changed to acetate. That means this is containing 5 alcoholic groups. How many alcohol groups? 5 alcohol groups. That 5 alcohol groups, what are those? That may be primary, that may be secondary, that may be tertiary. Possibility is there. That possibility is what happened here. Already we decided one primary alcohol is there. Total 5 alcohol. On that 5 alcohol, one primary alcohol is there. Remaining 4 are what now? In middle is there. Now middle means that is called secondary alcohol. That means one primary alcohol, remaining 4 are secondary alcohol. This is the structure of glucose. Based on this structure, I am going to write the Fischer projection formula or complete structure of glucose. Observe here. So based on that, first point, glucose containing the straight chain. How many carbon? 6 carbons. Right. 1, 2, 3, 4, 5. Fifth one is CH2OH. Sixth one is aldehyde. Okay, wait. 6 carbon straight chain. Next one is what? That carbonyl compound. Next one, glucose contain the carbonyl, the functional group. There you go, carbonyl. Carbonyl may be next point aldehyde. Next one. Glucose contains the 5 alcohol groups. 5 alcohol. 1, 2, 3, 4, 5. These 5 alcohol groups. 5 alkyl groups, one is primary, yes, one is primary terminal. Remaining 4 are what? Middle, that is called secondary. This is the structure. Remaining you have to fill the hydrogen. This is called what? What do you call this one? Structure of glucose. This is called open chain structure, that means straight chain. Open chain structure of glucose, right? This is the glucose structure. So this open chain structure of glucose, it is not exist, it is not exhibit, or it does not explain the some properties, very very important. Some of the time there are other statements. Which of the following statements are wrong or correct for the structure of glucose, or open chain structure or cyclic structure of glucose? So 2 points. Actually, open chain structure of glucose, it explains many properties, but it does not explain some properties. What are those? First property is glucose containing which group? Aldehyde, pre-aldehyde. Pre-aldehyde is there. This aldehyde is reacting with what? Primary amine. Which amine? Primary amine. Aldehyde with primary amine. You will get substituted imine. Substituted imine is called what? Skips base. Already we know. Skips base. When aldehyde is there, aldehyde is the pre-aldehyde is there. That means that is not involving in the any cyclic formation. That time pre-aldehyde group is there. That pre-aldehyde group is reacting with the primary amine. Primary amine means this is also called ammonia and ammonia derivative. Then what you have to remove? H2 and O, water eliminate. Then you will get C double bond N R. That is called substituted imine. Yesterday I told you. Substituted imine is called what? Skips base. Now pre-aldehyde is there, compulsory you want to form skips base. But in case of glucose, it is not forming, it is reacting with primary amine to form a skips base. It is not form a skips base. That means it does not form. That is the first point. That means what? Glucose does not form the skips base when reacting with the primary amine. Why? Because here the glucose containing pre-aldehyde group is not present. Pre-aldehyde group is not present, it is involving in the cyclic formation. Second point. It does not reacting with, or it is not form addition product. Addition of glucose addition product, that is called glucose sodium hydrogen sulfide when reacting with what? NaHSO3. Glucose does not reacting with NaHSO3, that is called sodium hydrogen sulfide. Sodium hydrogen sulfide. The sodium hydrogen sulfide, not sulfite IT. The sulfate will not adding to the, will not reacting with glucose. That means if you add, then you will get the addition product. You are not getting the addition product. Why you are not getting addition product? That means this glucose group, that means here pre-aldehyde group is not present. Pre-aldehyde group. So that means absence of aldehyde group. Here also absence of aldehyde group. Third point. Glucose pentaestate already formed. Glucose pentaestate already. Glucose reacting with what you call acetic anhydride to form a glucose pentaestate. Glucose pentaestate further reaction with what? Hydroxylamine. What is that? It does not reacting with further hydroxylamine. That means glucose pentaestate is not reacting with further NH2OH. So these three indication, glucose is not having the pre-aldehyde group. Pre-aldehyde group means compulsory, that is straight chain. It is not having the pre-aldehyde group means it is not a straight chain, it is like a cyclic structure. Cyclic structure means that is called cyclic structure of glucose. That means it is not existing as a open chain structure, it is existing as a what? Cyclic structure of glucose. Cyclic structure of glucose means it is existing as two forms. One is alpha form, second one is beta form. That is called alpha D glucose. One is, other one is beta D glucose. 1 minute. So it is not existing as a open chain, it is existing as a cyclic form. Cyclic form means it will exist as a two forms, one is called alpha and other one is beta. That is called alpha D, other one is beta D. D means this is called configuration. configuration means OH is right side is present, that is called D. Left side is present, that is called L. D and L. Okay. What is the meaning of plus plus? Plus indicates what you call rotation, dextro-rotatory and levo-rotatory. Positive means plus means that is called clockwise direction, that is called dextro. Minus means negative, minus means what you call levo-rotatory. Now that means it is exist as a normal, glucose is exist as a dextro-rotatory. Dextro means this one positive, this can be done by only experiment. D and L we can say by seeing the structure you can say D and L. This positive sign rotations we can't say by using only experiment, right. So alpha D glucose and beta D glucose, right. Cyclic structure observe now. Here OH is there. Here 1, 2, 3, 4, 5. 5 carbon with oxygen is involved in the ring formation. And what happened? This carbonyl compound, this H will be added to here. This carbonyl oxygen converted to OH. Remaining what is there now? Hydrogen. Remaining you have to fill the hydrogen. This is only now. That means here carbonyl group is converted to what? Alcohol. Then what is there now? This is called ether. Then what happened? This is called as. So this is called cyclic structure. Why you call cyclic structure? This is cyclic ring, chelation, ring is formation. How many membered ring? 1, 2, 3, 4, 5 with oxygen. 5 carbon with 1 oxygen to form a cyclic ring. That is called 6 membered ring, total 6 membered ring, but carbons are 5, that is called 1 oxygen, that is called hetero, that is called pyron. Pyron, right? 6 membered ring is formed. In this one, so this glucose containing the ring formation at first carbon, this is called what? Cyclic hemiacetal. This is called cyclic hemiacetal. So cyclic hemiacetal. Why you call cyclic hemiacetal? Observe here. This carbon having the what how many functional groups are there? 2 functional groups are there. One is alcohol, other one is ether. ROR, that is called ether. That means one carbon having the 2 functional group, that is called, one is alcohol and other one is ether, is called as hemi. This is coming from aldehyde, that is why hemiacetal. For again one carbon having the alcohol, other one ether, that is also called hemi. This hemi is coming from ketone, that is called hemiketal. It is coming from ketone means ketol. It is coming from aldehyde means acetal. Now this is coming from what? Aldehyde. That's why it is called hemiacetal. Hemiacetal with what? Which one? Cyclic formation. That is why this is called cyclic hemiacetal. So at and that this is cyclic hemiacetal at which carbon? First carbon. This is called which form? Alpha. This is called alpha D glucose. Next one beta. Observe here. Same CH2OH, OH, C, but here OH in left side, but again cyclic ring is formed. Cyclic ring is with how many carbon? Again same 5 carbon with 1 oxygen, that is called pyron ring. This is that, but here OH is which side is there? Left side is there. Here OH is there, which side is there? Right side is there. But which carbon? First carbon. The configuration is different at first carbon. In cyclic hemiacetal, that means 2 cyclic hemiacetal. This is called 1 cyclic hemiacetal, this is called other cyclic hemiacetal. 2 cyclic hemiacetal configuration is different at first carbon. 2 cyclic hemiacetals configuration differ at first carbon. Why? Configuration OH is right side, here OH is left side. Configuration different at first carbon is called as anomers. This is one of the point. Anomers. 2 cyclic hemiacetal configuration is differ at first carbon. Configuration differ at hydroxyl configuration differ at first carbon is called as anomer. This is called beta D glucose. That means finally alpha D glucose and beta D glucose are called C1 anomers. Alpha D glucose and beta D glucose are called C1 anomers. Right? Next, as it is same as this is glucose, again that is as the next one is fructose. Fructose also same explanation, but fructose structure observe here. CH2OH, OH, but here C double bond O, this is not, already this is ketone. This is alcohol, this is also alcohol, this is ketone. This is the structure of what? Fructose. Means fructose contains what is the functional group? Ketone functional group. Ketone is not a non-terminal, it is not a terminal, it is a non-terminal. Middle will be there now. Which carbon? Second carbon. Now here also it is also not exist this form cyclic structure, that means open structure like this. So it is also exist as a cyclic structure, but cyclic structure ring is formed at second carbon and fifth carbon. Observe now, that means ring is formed at this one. Observe clearly. This one move to here. This is converted to OH. Here carbon OH, CH2OH is there now. Observe here 1, 2, 3, 4, 5, 6 carbon ring and 6 carbon ring. But here OH is which side is there now? Right side. Again OH is left side. Two forms again. This is called alpha. OH is left side, that is called beta. Now this is called what? Hemiestala, hemiketala. So this carbon having OH group, that means alcohol, and again ether. This carbon having the alcohol and ether, that is called hemi. This is coming from ketone because this ketone group, that is called hemiketal. The configuration, that means two cyclic hemiketal. This is called alpha form, second one is beta, like that. One is this is called alpha, next one is called beta. Right side OH, left side OH. Right side OH is called alpha, left side OH is called beta. Already we know. Observe here. So the cyclic hemiketal, two cyclic hemiketal configuration is differ at second carbon, not first carbon. So how we know, sir? The number start from here. 1, 2, 3, 4, 5, 6. Configuration different at which carbon? Second carbon. That's why this is called as C2 anomers. Which one is called C2 anomers? Alpha D fructose and beta D fructose both are called C2 anomers. Alpha D glucose and beta D glucose are called C1 anomers. Observe here. This is how many membered ring? 1, 2, 3, 4. Here on the ring. 1, 2, 3, 4 with oxygen. That means 4 carbons with 1 oxygen. That means 5 membered ring. There 5 carbon with 1 oxygen, that is 6 membered ring. 6 membered ring is called pyron. 4 membered ring is called, 4 plus 1, 5 membered ring is called puron. Puron. Like this. This is called puron. Right? This is puron, this is called pyron. That is alpha D, this is called beta D. But this exists as a dextrorotatory, means glucose exists as a natural occurring alpha, what you call dextrorotatory, but this one is exists as a levorotatory. What do you call representation? Alpha D minus fructose. D means configuration. OH group right side, OH group left side. OH group right side is called D, left side is called L. This is called rotation. Rotation be the experimentally. But fructose exists as a which rotatory? Levorotatory. Glucose exists as a which rotatory? Dextrorotatory. Right? That's the representation minus D. Minus here plus. These are called alpha D glucose, beta D glucose, that is called alpha D fructose, that is called beta D fructose. Two are there now. If you know these structures, you will get it you. What you will get it you? Then what you call? what do you call, oligosaccharide. Oligosaccharide means disaccharides. Now disaccharide structures I will tell you, wait. Very, very important. That is called, first one is sucrose. Sucrose on hydrolysis. Sucrose on hydrolysis will get alpha D glucose plus beta D fructose. So alpha D glucose and beta D fructose you will get it now. When sucrose and hydrolysis, alpha D glucose, beta D fructose you will get it now. So here what they are asking question, glycosidic linkage. What is the meaning of glycosidic linkage? What is the meaning of glycosidic glycosidic linkage means one monosaccharide, other monosaccharide, both are will combine. Then what happened? We have to remove the water molecule. You will get the bond O bond, that is called glycosidic bond. Bond O bond, that is called glycosidic bond. Like this, bond O means O bond O, that is called peroxy bond. This is called glycosidic bond. Our requirement glycosidic bond. So carbohydrate will get the glycosidic bond. Here what type of glycosidic bonds are formed? Alpha D glucose and beta D fructose, both are will be joined. Both alpha D, beta D, both are both monosaccharide. Two monosaccharides will be joined by the loss of water molecule to form a bond O. Bond O bond is called glycosidic bond. Which type of glycosidic bond? C1 and C2. C1 of alpha D glucose, C2 of beta D fructose. This is only now glycosidic bond, very, very important. C1 C2 glycosidic bond. So how we know that, sir? Then already we know that, so directly we have to draw the structure. Based on the structure we have to know that. That means C1 and C1 of alpha D glucose, that means first carbon. 1 to 2 means what? First carbon. C2 of beta D fructose, both will be joined to form a glycosidic bond. That means sucrose having the what type of glycosidic bond? C1 and C2. C1 C2 glycosidic bonds are present. So now here first mole of C1, that means in glucose first carbon, what is the functional group is there? Aldehyde. Yes, aldehyde here. This is C2 beta D fructose, that means here what is the functional group is there? Ketone. Ketone at which functional group? Which carbon? Second carbon. Aldehyde at first carbon. These both aldehyde and ketone both are involving in the formation of which bond? Glycosidic bond. Both are involving in the formation of glycosidic bond means then here pre-aldehyde and pre-ketone group is not present. Both are involving in the glycosidic bond. Listen carefully what I am saying. Here aldehyde and ketone groups both are involving in the formation of glycosidic bond. C1 of first one, C2 of ketone. That means ketone is present at C2 carbon, aldehyde is present at C1 carbon. That both are involving in the glycosidic bond. That means here pre-aldehyde group is not present. That means absence of pre-aldehyde group. Absence of pre-aldehyde group means which cannot reduces Tollens reagent and Paling reagent. That's why this is called what? Non-reducing sugar. That already I told you. List also I told you. Non-reducing sugar. That means sucrose is a non-reducing sugar. Next one, some other point. Actually sucrose is naturally occurring is dextrorotatory. Dextro. Naturally, like this glucose and fructose. Glucose is dextro, fructose is levo. Now, before hydrolysis, sucrose is dextrorotatory. After hydrolysis, you are getting glucose plus fructose. Glucose means which rotatory? Dextro. That means I can write D, small d, dextro. This one is levo, small l, that is minus, this is plus. Right? This levo rotatory value is minus 92.5 degree. This dextrorotatory value is rotation value. How much degree? That degree is experimental. This is how much here? 52.5 plus 52.5 degree. Which one? Alpha D. This is minus 92.5. Average how much? Minus 92.5 plus 52.5 by 2, because average means 2 are involving now. How much here? Average 40, around actual 92.4 exact value. So our understanding from given 92.5, okay. 40 by 2 how much here? 20. 20 degree, okay. 20 degree, which one is highest? Minus or plus? That means minus. Minus means what? Levo or dextrona? Levo. Levo is the dominating. In this, before hydrolysis dextro rotated, that is positive. Plus, after hydrolysis, levo is the more than the dextro. That means final overall resultant is levo. That means what happened? Sucrose hydrolysis, dextro rotatory changes to levo rotatory. Dextro rotatory changes to levo rotatory. This is called as inversion. What do you call? Inversion. Inversion of sucrose, also called inversion of cane sugar. Sucrose other name is called cane sugar. What is mean by inversion of cane sugar? Before hydrolysis, like this we have to say, before hydrolysis this dextro rotatory, this is dextro and levo. Before, after hydrolysis you will get the alpha D glucose and beta D fructose. Beta D fructose is levo rotatory. Alpha D glucose is dextro rotatory. Levo rotatory is more than the dextro rotatory. That's why overall resultant is levo is the more than the dextro. Then finally what happened? Configuration change from where to where? Dextro to levo. Dextro to levo. The changing of the configuration from dextro to levo is called inversion. That's why this is called inversion of cane sugar. Inversion of cane sugar is called what? Sucrose. This is the information, clear information about sucrose. Next one. After sucrose, next one is what? Maltose. Maltose on hydrolysis will get the 2 moles of alpha D glucose units. 2 moles of alpha D glucose units. 2 moles of alpha D glucose, 1 mole of alpha D glucose, other mole of alpha D glucose. This both, this is the alpha D, this is the alpha D. This alpha D, again this alpha D, both will be joined. Joined to form a what? Glycosidic bond. What type of glycosidic bond? C1 of alpha D glucose, first mole. Other one is C4. C1, C4, alpha D glycosidic bonds will form. That means observe here. First mole of aldehyde. First mole of glucose C1 is A. C1 is means these are both are aldehydes A. So means both are glucose. Both are glucose means these two glucose units are aldehyde groups. This aldehyde group is where it is present? First carbon. So in this first mole C1 is aldehyde group is involved. Second mole which carbon is involved? Fourth carbon. That means here first carbon is not involving the glycosidic bond. First carbon is not involving means second mole having what? Aldehyde group, pre-aldehyde group is there. First mole there is no pre-aldehyde group. That means first mole aldehyde group is involving in the glycosidic bond. Second mole aldehyde is free. That means aldehyde group is free. Aldehyde group is free means it can reduce a Stolens and Fehling reagent. That's why this is called as what do you call? Reducing sugar. So what type of glycosidic bond? C1, C4, alpha D glucose units. Last one, lactose. Lactose on hydrolysis, you will get the beta D galactose. It is similar to glucose. Beta D galactose. Next one, beta D glucose. Observe now. Galactose, glucose both are dextrorotatory. Dextrorotatory because both are same sign. Galactose, glucose both are same, but configuration is different at fourth carbon. Only fourth carbon is changed. In case of difference between the glucose and galactose, what is the difference? Configuration is different at which carbon? Fourth carbon. Remaining is as it is. So beta D galactose and beta D glucose both are involving in the glycosidic bond. Both will be combined to form a glycosidic bond. What type of glycosidic bond? Same as it is. What is the same as it is? C1 and C4. C1 of beta D galactose, C4 of beta D glucose. This is only sequence. First one, which one you have to draw? Galactose. Next one, glucose. C1 of galactose, C4 of glucose. That means what? Here also aldehyde group is present, here also aldehyde group. We both are having aldehyde, but confer is different at 4th carbon. Here in this galactose, aldehyde group is involving in the glycosidic bond formation. Glucose, 4th carbon is involving. That means first carbon is not involving in the formation of glycoside. That means in the beta D glucose, what is present? Free aldehyde group is present. Free aldehyde group is present means it will reduce or not? As it will reduce. That's why it is called as what you call reducing sugar. That's why I told you clearly before a. So sucrose is what I told, non-reducing sugar. Maltose and lactose both are what? Reducing sugars. This is the information. Right? These are called what? What do you call? Oligosaccharides, also called disaccharides. Next one, polysaccharides. Polysaccharides is what is called, first one is starch. Starch is contain the two components. This is called polysaccharide. This polysaccharide means no need to check that directly. It is a what you call non-reducing sugar. One is amylose. Other one is amylopectin. Amylose and amylopectin, right? This amylose and amylopectin difference main important, very very important. It is soluble in water. It is insoluble in water. It is amylose containing 15 to 20% of starch. This one 80 to 85% of starch, right? It is a unbranched chain. Unbranched means that is called linear straight chain. How much units? 200 to 1000 alpha D glucose units. That means starch on hydrolysis you will get the alpha D glucose units. Alpha D. Starch on hydrolysis what I can get? Alpha D glucose units. Alpha D glucose units. The starch is compound two types, amylose and amylopectin. Here also alpha D glucose, here also alpha D glucose. But here 200 to 1000 alpha units we have to join, not 1 or 2. Up to here only two what you call two monosaccharides will be joined. Here 200 to 1000 monosaccharides we have to join to form a straight chain, long chain. That is called unbranched. This is called branched. Branching. This is branched chain. This is also the same. Branching of alpha D glucose units. Right? This is branching here. Glycosidic bond. Here also glycosidic bonds are formed. Very very important. Here glycosidic bond. Which one is involving alpha D glucose? Alpha D glucose, alpha D glucose, alpha D glucose you have to join up to 1000 units. Then also glycosidic bond form. What is glycosidic bond? C1 and C4 of alpha D glucose. C1 and C4 of first mole of glucose C1, second mole of C4, again like that. C1 to C4, C1, C4 like that to form a long chain. That's unbranched, that is called linear chain. Right? C1, C4. Here branching means first two types of glycosidic bonds are present. C1, C4 of alpha D glucose unit, that is called straight chain. C1 and C6 of again alpha D glucose. This is straight chain. The C1 and 6 it is from branching. That means two type of linkages are present here. C1, C4 and C1, 6. C1 C1C4 and C1C6. C1C4 of alpha D glucose to form a straight chain, C1C6 to form a branching. This total combination you will get the branch, overall branching. The two type of linkages are present. In case of what? Amylopectin. In case of amylose, this one C1C4. Right? So many times they ask the question, this is only now. But finally, starch is having what? Alpha D glucose. In starch is on hydrolysis will get the alpha D glucose. Last one, next one, cellulose. Cellulose also on hydrolysis you will get, this is also like a branching. It is like a polymer. Cellulose is one of the polymer. Long chain of what? Polymer of what? Beta D glucose units. Here alpha D, here beta D. Alpha D or beta D. Beta D glucose like a straight chain. So many monomers will be joined. That means here also you will get the glycosidic bond. What type of glycosidic bond? Same. C1 and C4 of what? Beta D glucose. Yes, C1 and C4. First mole C1, second mole is C4. Like that will be joined to form a long chain. This is called cellulose. This is the information about what you call carbohydrates. Next one, amino acids. Here amino acids, general formula of amino acid means one compound contain the both carboxylic acid and amino group. At a time both are present. COOH, NH2, this R group we have to substitute, different groups we have to substitute, you will get the different types of amino acid. This is called general formula of amino acid, right? Both amino group and carboxylic group. Now, this amino acid, very important, observe one point. This amino acids is having the chiral carbon, like that one I arranged. Chiral carbon. Chiral carbon means what? 4 different groups, carbon containing 4 different groups, COOH, H, NH2, R. Chiral carbon means that is called asymmetric carbon. Asymmetric carbon is present, means amino acids having the asymmetric carbon. Actually total amino acid in our syllabus, how many amino acids are there? 20 amino acids are there. How many amino acids? 20 amino acids are there. On the 20 amino acids, observe, amino acid represented this one. That means amino acids having the asymmetric carbon. Asymmetric means chiral carbon. Chiral carbon is there, compulsory. It is optically what? Optically active, very important. That means all amino acids are optically active except glycine, very important. Why all amino acids are optically active? Because these are all having the asymmetric center or asymmetric carbon, chiral carbon. So chiral carbon, this is the representation. Compound containing or amino acid containing only one chiral carbon is there. It is optically active, compulsory. Chiral compounds containing more than one chiral carbon, more than one chiral carbon is there, may or may not be optically active. So that is explanation, that is different. So here one chiral carbon is there, our 20 amino acids also, most of the maximum. That is, it is optically active except glycine. Glycine structure, observe, you have to know, observe, you will get it now. This is called glycine. CH2, COOH, NH2. That representation, observe. The top COOH, yes. Middle carbon is there. Carbon containing how many hydrogens? H. What is there now? NH2. So COOH, NH2, H. This R is equal to here, how much here? R equal to H. R is equal to H is substituted. What I can get? H I can get means this is not a chiral carbon. This is called achiral carbon. Achiral. Why? 2 groups are same. Actually 4 groups are one to different. 2 groups are same. That's why this is called achiral carbon. That means it is not a asymmetric carbon, it is a symmetric carbon. Symmetric carbon, that's what happened, optically inactive. That's why finally glycine is a optically inactive, remaining all are optically active. Next one, all alpha amino acids, all natural occurring amino acids are L configuration. L configuration. Before I told carbohydrates, D capital D configuration, D configuration. These are called L configuration. Highest priority group present on left side. Their highest carbohydrates highest priority group is OH. OH group is right side is there now. Here hydroxyl, here OH is not there. Highest priority group is nitrogen. That means NH2 amine. Which side is present? Left side. That's it is called what? L configuration. Very very important. All natural occurring amino acids are L configuration. Some other points observe now. All alpha amino acids are, means all amino acids are crystalline solids. And crystalline solids and colorless. Why I am saying these points actually, colorless. It is soluble, these are not these are soluble in, these means all amino acids are soluble in water. Next one, these all amino acids are like a salt type. It is exist as a salt. How you know? Observe one of the compound. I will take one of the compound is like this. This one, CH, SCH, NH2, COOH is R plus what is there now? CH3. R is equal to CH3 means that is called what? This is called glycine. This is called alanine. This is called what? Alanine. This glycine I am keeping on what? Or glycine or alanine or any amino acid I am keeping on aqueous solution. I am keeping on aqueous solution means whatever the ionic compound is there, that ionic compound will be breakdown. That means amino acid is ionic compound. How to know? Here carboxylic acid is there. In the carboxylic acid there means compulsory. In aqueous solution I am keeping, this will lose a proton. That means carboxylic acid loss of proton. This is called acid. NH2 is called base. Base means what happened? Accept the proton from the carboxylic acid. That means this proton is coming from acid to base. Then what I can get? CH3, CH, NH2 become NH3 plus, COH becomes COO minus. You will get the two charges. One is cation, other one is anion. This is anion, this is cation. Anion because loss of proton. Cation because gain of proton, means accept the proton. Proton is accepting from acid. Why it is dissociated? Because we are keeping in water. Means this is polar nature. Water is polar, this is also polar. Polar compounds are soluble in polar solvent. You will get the two charges, that is called dipolar ion. Dipolar ion is called one of the salt. This is called ammonium. This carboxylate, these are called charges are there, these are called salt. That means it exists as a salt. Exists as salt means it is stable or unstable? Stable. Why? Because equimolar charges are there. Here one negative charge is 1, positive charge is also 1. Equal charges are there. Equal charges are there means we will get neutral. That means finally what you can say, dipolar ion is a neutral. It exists as a salt. Dipolar ion, that is also called a Zwitter ion. What I am saying, every point is so many times they ask the question, match the following or statement based question. These all are statements only now. What I am saying, L configuration, optical activa, inactiva, which natures, properties they are given, how many of the following statements are correct, incorrect they are asked. That's what I am giving every point. It exists as a what? Dipolar ion, also called Zwitter ion. So this is neutral. Why I am calling neutral? Equal charges are there. This is called neutral. And again what? It is exists as a salt form. It will exist as salt form. Right? Next point. It is exists as a dipolar ion, or this one is exists as a amphoteric in nature. Which one? Dipolar ion, jet ion is exists as a amphoteric in nature. Amphoteric means it will react with acid as well as base. It is there. Salts of acid is there. This reacting with acid. It is reacting with base. Then what happened? It is reacting with acid. It is reacting with base. So at a time reacting with acid base means that is called what? Amphoteric. Which one is amphoteric in nature? Zwitter ion. Right. Next one. Essential amino acids. And non-essential amino acids. Essential amino acid means the amino acid which cannot be synthesized in our body. So we can supply it through the diet. Those are called essential amino acids are there. Amino acids. Total we are having the 20 amino acids are there in our syllabus. Still more so many there. We don't want remaining. And the 20 amino acid, 10 are the essential amino acids. Very, very important. How many of the following are essential amino acids? Which of the following is essential amino acid? They are asking the question. 10 essential amino acids are there. Total 20. On the 10 remaining 20 are non-essential. How to remember? Just I will give the trick or hint. This one. MTV high-tech pilla. MTV high-tech pilla. M stands for methionine. T stands for threonine. V stands for valine. HA stands for histidine. Tech stands for tryptophan. P stands for phenylalanine. I stands for isoleucine. Other L stands for lysine. Next L stands for lysine leucine. A stands for arginine. These are the total 10 essential amino acids. One check it now. MTV high-tech pilla. Methionine. M stands for methionine. T stands for threonine. V stands for valine. HA stands for histidine. Tech stands for tryptophan. P stands for phenylalanine. I stands for isoleucine. L stands for lysine or leucine. Other one is leucine. A stands for arginine. These are called total 10. Count once. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total 10. Those are called essential. Other than these 10, remaining is called non-essential amino acids. Remaining non-essential means what now here? Valine is there. So glycine, alanine, remaining glycine, alanine, cysteine, okay, threonine, right, proline, like that. Remaining are called what? Non-essential amino acids, right? Based on this, some other question, essential amino acids. Some of the questions they are asking related to amino acids. Neutral amino acids. Acidic amino acids. Basic amino acids. That means what? Neutral amino acid means amino acid contain the both equal number of carboxylic and amino groups are there, that is called neutral amino acids. One is glycine, alanine, phenylalanine, leucine, right, isoleucine. So these are the what you call neutral amino acids. Acidic amino acid, only acidic amino acid means carboxylic acids are more than the amino groups, means carboxylic group is more than the amino group, that is called acidic amino acid. Only two, aspartic acid, glutamic acid. Aspartic acid, glutamic acid, these two are what? Acidic amino acid. Basic amino acid, lysine, arginine, these two are the basic amino acids. Lysine, arginine. Aspartic acid, glutamic acid, those are called what you call acidic amino acid. Next one, amide, very very important, amide functional group, that means C double bond to NH2. Amide functional group containing the carboxylic acid, aspargine, glutamine, these two are the amide. Sulfur containing amino acids, methionine, cysteine, right, heterocyclic amino acid, heterocyclic means heterocyclic ring, and heterocyclic containing which amine? Secondary amine, that is what? Tryptophan, histidine and proline. These are the heterocyclic amino acids. Alcohol containing amino acid, what is there now? Threonine, and serine, Next, last one, para-hydroxy benzoyl, tyrosine. These are the functional groups, very very important, so many times they ask. You see how to know, total 20 amino acids are there here only now, 20 will be there, I think, yes. Neutral amino acid, acidic amino acid means aspartic acid, glutamic acid, just I am reminding you. Basic amino acids called lysine, arginine. Amide contain the functional groups are called aspargine, glutamine. Sulfur contain amino acids methionine and cysteine. Heterocyclic amino acids called tryptophan, histidine and proline. Alcohol contain amino acid called threonine and serine. Para-hydroxy benzyl group contain the amino acids called tyrosine. These are the total 20 amino acids, essential and non-essential. Okay, Amma. Thank you. Remaining I will continue next.
Welcome back, my dear students. In previous class, we have learnt about appendicular skeleton, major and essential components. So I think today is the last working day to justify first PUC syllabus. From tomorrow onwards, you are going to write grand tests. They have allotted only one day to teach chemical coordination and integration. Basically, in case of chemical coordination and integration chapter, students are usually facing fluctuations only in case of hormonal action, types of hormones and types of receptors. Types of hormones, types of receptors and mechanism of hormonal action. Mechanism of hormonal action. Now I will justify those concepts right now. First, types of hormones. Dear students, hormones are distinctly divided into 4 categories. Hormones are distinctly divided into 4 categories. Namely, number 1, protein or peptide or polypeptide hormones. Number 1, protein or peptide or polypeptide hormones. The category number 1. Examples of protein or peptide or polypeptide hormones. Number 1, all pituitary gland hormones. All pituitary gland hormones like growth hormone, thyroid stimulating hormone, adrenocorticotropic hormone, growth hormone, thyroid stimulating hormone, adrenocorticotropic hormone, prolactin, follicular stimulating hormone, follicular stimulating hormone, luteinizing hormone, and MSH. MSH stands for melanocyte stimulating hormone. All these hormones will be secreted exclusively from pituitary gland. Here, growth hormone, thyroid stimulating hormone, adrenocorticotropic hormone, prolactin, follicular stimulating hormone and luteinizing hormone. These hormones are secreted from adenohypophysis. Melanocyte stimulating hormone is secreted from pars intermedia or middle pituitary. All these hormones come under protein, peptide, polypeptide category. And example number 2, all hypothalamic hormones. All hypothalamic hormones like growth hormone releasing hormone, GHRH, growth hormone releasing hormone. Growth hormone releasing hormone is otherwise known as somatocrinin. Growth hormone releasing hormone is otherwise known as somatocrinin. And next one, GHIH, growth hormone inhibiting hormone. GHIH stands for growth hormone inhibiting hormone. Growth hormone inhibiting hormone is otherwise known as somatostatin. Growth hormone releasing hormone or somatocrinin. Growth hormone inhibiting hormone are somatostatin, and GnRH stands for gonadotropin releasing hormone. Gonadotropin releasing hormone. And next one, GnIH. GnIH stands for gonadotropin inhibiting hormone. Gonadotropin inhibiting hormone. And next one, oxytocin. Oxytocin hormone is secreted from hypothalamus, not pituitary gland. Hypothalamus secretes oxytocin hormone. But from hypothalamus, oxytocin hormone migrates into posterior pituitary. Posterior pituitary stores and releases oxytocin hormone. Please keep it in your mind. And next hormone, vasopressin. Vasopressin is otherwise known as ADH. ADH stands for antidiuretic hormone. Dear students, hypothalamus secretes oxytocin and vasopressin are ADH hormones. But from hypothalamus, oxytocin and vasopressin are antidiuretic hormones migrate into posterior pituitary or neurohypophysis. Here, posterior pituitary or neurohypophysis stores and releases both oxytocin and vasopressin or ADH hormones. All these hormones come under protein, peptide, polypeptide category. Understood, right? And some more examples. Insulin. Next, glucagon. Insulin and glucagon hormones both are secreted from pancreas. Insulin and glucagon hormones are secreted from pancreas. Insulin, glucagon, basically these two are peptide hormones. Peptide hormones. And some more examples. Thyrocalcitonin hormone. Thyrocalcitonin hormone. Next, PTH, parathyroid hormone. Thyrocalcitonin hormone and PTH stands for parathyroid hormone. And next example, erythropoietin hormone. Basically, erythropoietin hormone is secreted from juxtaglomerular cells of kidney. Erythropoietin hormone stimulates RBC production or erythropoiesis. Keep it in your mind. And next one, atrial natriuretic peptide or atrial natriuretic factor. Atrial natriuretic peptide or atrial natriuretic factor. Basically, atrial natriuretic factor or atrial natriuretic peptide hormone is secreted from right atrium of heart. Atrial natriuretic peptide or atrial natriuretic factor hormone is responsible for vasodilation. Due to this, blood pressure will be decreased. Blood pressure will be decreased. And some other hormones like gastrin, secretin, gastrin, secretin, cholecystokinin, gastrin, secretin, cholecystokinin, and gastric inhibitory peptide. Gastrin, secretin, cholecystokinin and gastric inhibitory peptide. All these hormones come under protein, peptide, polypeptide category. Understood? Don't confuse Hormones are basically classified into 4 categories. Category number 1, protein, peptide, polypeptide hormones. Best examples, number 1, all pituitary gland hormones like growth hormone, thyroid stimulating hormone, adrenocorticotropic hormone, prolactin, follicular stimulating hormone, luteinizing hormone, and melanocyte stimulating hormone. And next one, all hypothalamic hormones like GHRH stands for growth hormone releasing hormone or somatocrine. Next one, GHIH stands for growth hormone inhibiting hormone or somatostatin. Next, GnRH stands for gonadotropin releasing hormone. Next, GnIH stands for gonadotropin inhibiting hormone. Next one, oxytocin. Next, vasopressin or antidiuretic hormone. Next, insulin, glucagon, thyrocalcitonin, parathyroid hormone, erythropoietin, atrial natriuretic peptide or atrial natriuretic factor, gastrin, secretin, cholecystokinin, gastric inhibitory peptide. I forgot to give one more hormone, amma, that is thymosin. Thymosin hormone is secreted from thymus gland. Basically, thymosin hormone plays a role in differentiation of T lymphocytes to perform cell-mediated immune response. All these hormones come under protein, peptide, polypeptide category. Just you have 1 minute time to analyze all these hormones right now. Right? So all these hormones come under protein, peptide, polypeptide category. Okay na? Insulin, along with pituitary and hypothalamic hormones, insulin, glucagon, thyrocalcitonin, parathyroid hormone, erythropoietin, atrial natriuretic peptide or atrial natriuretic factor, gastrin, secretin, cholecystokinin, gastric inhibitory peptide, thymosin hormone. All these hormones come under protein, peptide, polypeptide category. Okay na? Now second category. Second category, steroid hormones. Steroid hormones. Dear students, examples of steroid hormones. Number 1, all adrenal cortex hormones. All adrenal cortex hormones like glucocorticoid or cortisol, glucocorticoid or cortisol. Next one, mineralocorticoid, mineralocorticoid or aldosterone, glucocorticoid or cortisol, and second one is a mineralocorticoid or aldosterone, and next one testosterone or androgens or male sex hormone or testicular hormone, and next one estrogen or estradiol, estrogen or estradiol, And the next one, progesterone or progestogen. Progesterone or progestogen. All these hormones come under steroid category. Come again. All adrenal cortex hormones like glucocorticoid or cortisol, mineralocorticoid or aldosterone. Next, testosterone or androgen or male sex hormone or testicular hormone. Estrogen or estradiol. Estrogen or estradiol. Progesterone or progestogen. All these hormones come under steroid category. And third one, iodothyronin hormones. Iodothyronin hormones. Examples of iodothyronin hormones. Number 1, T3. Number 1, T3. T3 stands for triiodothyronin. T3 stands for triiodothyronin. And next one, T4. T4 stands for tetraiodothyronin. T3 stands for triiodothyronin and T4 stands for tetraiodothyronin. Tetraiodothyronin is otherwise known as thyroxine. We can consider T4 as thyroxine, not T3. Keep it in your mind. T3 are triiodothyronin. Next one, T4 are tetraiodothyronin or thyroxine. My dear students, basically iodine is responsible for the synthesis of both T3 and T4. Iodine is responsible for the synthesis of both T3 and T4. But due to the deficiency of iodine or deficiency of iodine leads to poor secretion of T3 and T4. Iodine is responsible for the synthesis of T3 and T4. Deficiency of iodine results in poor secretion of T3 and T4. This condition is said to be hypothyroidism. Hypothyroidism causes 3 abnormalities like number 1, simple goiter, cretinism, myxoedema. Understood? Once go through that concept, everyone. And fourth category, amino acid derivative hormones. Amino acid derivative hormones. Amino acid derivative hormones like number 1, epinephrine or adrenaline. Epinephrine or adrenaline. Second one, norepinephrine. Norepinephrine or noradrenaline. Basically, epinephrine and norepinephrine or adrenaline and noradrenaline both are secreted in response to stress or during emergency conditions. Epinephrine or adrenaline and norepinephrine or noradrenaline, these 2 hormones are secreted in response to stress or during emergency conditions. Due to this reason, epinephrine or adrenaline and norepinephrine or noradrenaline both are collectively called fight or flight hormones or emergency hormones or catecholamines. And one more amino acid derivative hormone, melatonin. Melatonin is also a kind of amino acid derivative hormone, my dear students. Why? Because melatonin hormone will be synthesized from tryptophan amino acid. Melatonin hormone will be synthesized from tryptophan amino acid. Hence it comes under amino acid derivative hormone. Understood? So types of hormones concept is successfully completed. I hope you people have understood this concept in detail. See, steroid hormones are all adrenal cortex hormones like glucocorticoid or cortisol, mineralocorticoid or aldosterone, testosterone or androgen, estrogen or estradiol, progesterone or progestogen. Next, iodothyronine hormones like number 1 T3 or triiodothyronine, second one T4 or tetraiodothyronine or thyroxine. Next, amino acid derivative hormones like epinephrine or adrenaline, norepinephrine or noradrenaline, and the melatonin hormone. Clear? Once analyze that, everyone. Okay? And the next concept is types of receptors. Types of receptors. My dear students, basically hormones show their effects on target cells. Basically, hormones show their effects on target cells. So, this is target cell ra. Basically, target cell is externally covered by, target cell is externally covered by cell membrane. Target cell is externally covered by cell membrane. Dear students, on the cell membrane of target cell, one special receptor is present. On the cell membrane of target cell, one special receptor is present called cell membrane receptor. Cell membrane receptor. Cell membrane receptor is otherwise known as membrane bound receptor. Cell membrane receptor is also known as membrane bound receptor. Basically, target cell is externally covered by cell membrane. On the cell membrane of target cell, one special receptor is present called cell membrane receptor. Cell membrane receptor is also known as membrane bound receptor. And in general, inside the target cell, cytoplasm is present. Inside the target cell, cytoplasm is present. Inside the target cell, cytoplasm is present. Sometimes cytoplasm contains receptor. If receptor present inside the cytoplasm is called cytoplasmic receptor. If receptor present inside the cytoplasm is called cytoplasmic receptor. But if receptor present inside the nucleus, is called nuclear receptor. If receptor present inside the cytoplasm is called cytoplasmic receptor. But if receptor present inside the nucleus is said to be nuclear receptor. Here both cytoplasmic receptor and nuclear receptor. Cytoplasmic receptor and nuclear receptor both are collectively called intracellular receptors. Cytoplasmic receptor and nuclear receptor both are collectively called intracellular receptors. Simply we can say intracellular receptors are of two types. Intracellular receptors are of two types. Namely, number one, cytoplasmic receptor, and second one is a nuclear receptor. But my dear students, intracellular receptors are mostly nuclear receptors. Intracellular receptors are mostly nuclear receptors. Keep it in your mind. See, if receptor present on the cell membrane of target cell called cell membrane receptor or membrane bound receptor. If receptor present inside the cytoplasm called cytoplasmic receptor. If receptor present inside the nucleus called nuclear receptor. Cytoplasmic receptor and nuclear receptor both are collectively called intracellular receptors. Intracellular receptors are mostly nuclear receptors. Now we will discuss individually mechanism of membrane bound receptor or mechanism of cell membrane receptor. Later we should go through mechanism of intracellular receptors or mechanism of nuclear or cytoplasmic receptors. Okay na? Right? So if receptor present on the cell membrane of target cell called cell membrane receptor or membrane bound receptor. If receptor present inside the cytoplasm called cytoplasmic receptor. If receptor present inside the nucleus called nuclear receptor. Cytoplasmic and nuclear receptors both are collectively called intracellular receptors. Here intracellular receptors are mostly nuclear receptors. Next concept, mechanism of membrane bound receptors. Mechanism of membrane bound receptor. Just now we have learnt about membrane bound receptor. Membrane bound receptor is present on the cell membrane of target cell. Understood? And membrane bound receptor is also known as cell membrane receptor. Understood? My dear students, basically all protein hormones can bind with membrane bound receptors. All protein hormones can bind with membrane bound receptors. Just now we have learnt about protein peptide polypeptide category, like all pituitary gland hormones like growth hormone, TSH, ACTH, prolactin, FSH, LH, MSH, all hypothalamic hormones like GHRH or somatokinin, GHIH or somatostatin, oxytocin, vasopressin or ADH, insulin, glucagon, and next one thymosin, TCT, thyrocalcitonin, PTH, parathyroid hormone, gastrin, secretin, cholecystokinin, gastric inhibitory peptide, erythropoietin, atrial natriuretic factor or atrial natriuretic peptide, all come under protein, peptide, polypeptide category. Please once go through the concept. All protein hormones can bind with membrane bound receptor. Understood? Choose any one of protein hormone. Here I am selecting FSH, follicular stimulating hormone. Follicular stimulating hormone is basically protein hormone. Understood? See what I am saying? All types of protein hormones can bind with membrane bound receptor. Choose any one of the protein hormone, but here I have selected FSH. Your wish. Instead of FSH, better to choose growth hormone or choose LH or choose prolactin. Choose MSH, your wish. But here I have selected FSH. FSH is a kind of protein hormone. Understood? And one more important statement, basically hormones show their effects on target cell. In this case, target cell is ovarian cell. Ovarian cell andre cell of ovary. Cell of ovary. Understood? So these are the basic fundamental characteristic features. Once recapitulate what we have learnt. My dear students, membrane bound receptor is present on the cell membrane of target cell. All protein hormones can bind with membrane bound receptor. All protein hormones can bind with membrane bound receptor. Best example, FSH or follicular stimulating hormone. FSH is a kind of protein hormone. In this case, target cell is ovarian cell or cell of ovary. Andre, FSH hormone shows its effects on ovarian cell. FSH hormone shows its effects on ovarian cell. Here ovarian cell is target cell, FSH is a protein hormone. Okay, coming to the point. See, all protein hormones can bind with membrane bound receptor. Best example FSH. FSH is a kind of protein hormone. In case of mechanism of membrane bound receptor, target cell is ovarian cell and a cell of ovary. See? See, this is ovarian cell, means cell of ovary. Ovarian cell or cell of ovary. Basically, ovarian cell is surrounded by ovarian cell membrane. Ovarian cell is surrounded by ovarian cell membrane. Basically target cell is lined by cell membrane. Here target cell is ovarian cell. Ovarian cell is enveloped by ovarian cell membrane. Don't confuse. Target cell is ovarian cell. Ovarian cell is covered by ovarian cell membrane. And my dear students, on ovarian cell membrane, one special receptor is present. On ovarian cell membrane, receptor is present, is called membrane bound receptor. Got it? On ovarian cell membrane bound receptor is present. Membrane bound receptor is also known as cell membrane receptor. Target cell is ovarian cell. Ovarian cell is covered by ovarian cell membrane. On ovarian cell membrane, special receptor is present called membrane bound receptor. Just now we have discussed all protein hormones. All protein hormones can bind with membrane bound receptor. Here we have selected FSH. FSH. FSH is a kind of protein hormone. FSH is a kind of protein hormone. And basically, FSH is primary messenger. FSH is a kind of protein hormone. And FSH is primary messenger. Not only FSH, basically, initially, all hormones act like primary messengers. Basically, all hormones act like primary messengers. Here, FSH is a kind of protein hormone, and moreover, FSH is a kind of primary messenger. See, target cell is ovarian cell. Ovarian cell is covered by ovarian cell membrane. On ovarian cell membrane, membrane bound receptor or cell membrane receptor is present. All protein hormones can bind with membrane bound receptor. Here selected hormone is FSH, stands for follicular stimulating hormone. FSH is a kind of protein hormone, and moreover FSH is primary messenger. Got it? Here analysis amma. My dear students, here FSH hormone is primary messenger, and FSH hormone comes into contact with membrane bound receptor. FSH is primary messenger. FSH hormone comes into contact with membrane bound receptor, or FSH hormone binds with membrane bound receptor which is located on ovarian cell membrane. Which is located on ovarian cell membrane. FSH hormone is protein hormone, and FSH is a kind of primary messenger. FSH hormone binds with membrane bound receptor which is located on ovarian cell membrane. As a result, FSH receptor complex is formed. As a result, FSH receptor complex is formed. Don't confuse amma. FSH is a protein hormone, and FSH is a kind of primary messenger. FSH hormone comes into contact with membrane bound receptor which is located on ovarian cell membrane. As a result, FSH receptor complex is formed. Dear students, here FSH receptor complex is formed on ovarian cell membrane. FSH receptor complex is formed on ovarian cell membrane, but FSH receptor complex does not enter the inner portion of ovarian cell. Did you catch my point? FSH receptor complex is formed on ovarian cell membrane, but FSH receptor complex does not enter the inner portion of ovarian cell. Please keep it in your mind. FSH is a kind of protein hormone. FSH is primary messenger. FSH hormone comes into contact with membrane bound receptor which is located on ovarian cell membrane. It leads to the formation of FSH receptor complex. FSH receptor complex is formed on ovarian cell membrane, but FSH receptor complex does not enter the inner portion of ovarian cell. But here FSH receptor complex does not enter the inner portion of ovarian cell, but FSH receptor complex shows few responses on ovarian cell membrane. FSH receptor complex shows few responses on ovarian cell membrane. But here on ovarian cell membrane space is very less. It is impossible to justify those responses on ovarian cell membrane. That is why, due to that reason, I want to justify those responses here. It means those responses will occur exclusively on ovarian cell membrane but not inside the ovarian cell. Okay na? Listen again. FSH is a kind of protein hormone. FSH is primary messenger. FSH comes into contact with membrane bound receptor which is located on ovarian cell membrane. As a result, FSH receptor complex is formed. FSH receptor complex is formed on ovarian cell membrane, but FSH receptor complex does not enter the inner portion of ovarian cell. But instead of that, FSH receptor complex shows appropriate responses on ovarian cell membrane. We will discuss those responses right now. Okay? See, initially FSH receptor complex shows one appropriate response. We can consider that particular response as response 1. Here response 1 will be generated on ovarian cell membrane but not inside the ovarian cell. Keep it in your mind. FSH is primary messenger. It binds with membrane bound receptor located on ovarian cell membrane. It leads to the formation of FSH receptor complex. FSH receptor complex shows one appropriate response. We can consider that particular appropriate response as response 1. Response 1 will be generated on ovarian cell membrane. Response 1 leads to the formation of secondary messengers. Response 1 leads to the formation of secondary messengers. Initially, FSH is primary messenger. It means primary messenger FSH plays a vital role in the formation of secondary messenger. Examples of secondary messengers: calcium ions, cyclic AMP. AMP stands for adenosine monophosphate, and IP3. IP3 stands for inositol triphosphate. Inositol triphosphate. All these are secondary messengers. Calcium ions, cyclic adenosine monophosphate, and inositol triphosphate. All these are secondary messengers. FSH receptor complex shows one appropriate response on ovarian cell membrane called response 1. This response 1 leads to the formation of secondary messengers like calcium ions, cyclic adenosine monophosphate, and inositol triphosphate. Along with response 1, secondary messengers will also be generated only on ovarian cell membrane. Later, secondary messengers generate two types of responses. Secondary messengers show two types of responses, namely, number 1, biochemical responses. Biochemical responses. Second one, physiological responses. Biochemical responses and physiological responses. Here we can consider biochemical response as response number 2. Physiological response as response number 3. Total number of responses which will be generated in this mechanism are 3. Response 1, response 2, response 3. Response 2 is biochemical, response 3 is physiological. Here biochemical and physiological responses both will be generated by secondary messengers, and response 1 will be generated by FSH receptor complex, right? Biochemical responses regulate biochemical functions of ovarian cell or target cell. Biochemical responses regulate biochemical functions of target cell or biochemical functions of ovarian cell. Then next one, physiological responses. Physiological responses regulate physiological functions of ovarian cell. Or physiological functions of target cell, like physiological responses regulate ovarian cell growth. Ovarian cell growth. Clear? See, once recapitulate what we have learnt. FSH is a primary messenger. All protein hormones can bind with membrane bound receptors, like all pituitary gland hormones like growth hormone, thyroid stimulating hormone, adrenocorticotropic hormone, prolactin, follicular stimulating hormone, luteinizing hormone, melanocyte stimulating hormone. And next one, all hypothalamic hormones like growth hormone releasing hormone or somatokinin, growth hormone inhibiting hormone or somatostatin, oxytocin, vasopressin or antidiuretic hormone, insulin, glucagon, thyrocalcitonin, parathyroid hormone, thymosin, gastrin, secretin, cholecystokinin, gastric inhibitory peptide, erythropoietin, atrial natriuretic factor or atrial natriuretic peptide. All these hormones come under protein peptide polypeptide category. Exclusively, all protein hormones can bind with membrane bound receptor. Here, in case of this target cell is ovarian cell. Ovarian cell is covered by ovarian cell membrane. On ovarian cell membrane, membrane bound receptor is present. All protein hormones can bind with membrane bound receptor. Here selected hormone is FSH. FSH is a kind of protein hormone. Moreover, FSH is primary messenger. FSH comes into contact with membrane bound receptor which is located on ovarian cell membrane. As a result, FSH receptor complex is formed. Here FSH receptor complex is formed on ovarian cell membrane, but FSH receptor complex does not enter the inner portion of or cytoplasm of ovarian cell. So initially FSH receptor complex shows one appropriate response on ovarian cell membrane called response 1. Response 1 leads to the formation of secondary messengers like calcium ions, cyclic adenosine monophosphate and inositol triphosphate. Secondary messengers generate biochemical responses and physiological responses. Biochemical responses regulate biochemical functions of target cell or ovarian cell. Physiological responses regulate physiological functions of ovarian cell or ovarian cell growth and differentiation. Understood? See, Amma, just now we have discussed posterior pituitary or neurohypophysis does not secrete any hormone. Posterior pituitary or neurohypophysis does not secrete any hormone. But posterior pituitary or neurohypophysis stores and releases oxytocin and vasopressin or ADH hormone. Due to this reason, we can consider posterior pituitary or neurohypophysis as pseudoendocrine gland or false endocrine gland. Hypothalamus secretes oxytocin and vasopressin hormone. From hypothalamus, oxytocin and vasopressin hormones travel through axon of hypothalamo-hypophyseal tract into posterior pituitary or neurohypophysis. It stores and releases oxytocin and vasopressin hormone. Moreover, posterior pituitary or neurohypophysis is under the direct neural regulation of hypothalamus. Posterior pituitary or neurohypophysis is under the direct neural regulation of hypothalamus. Okay, na? FSH and LH both are collectively called gonadotropins. Gonadotropin releasing hormone stimulates pituitary gland to secrete gonadotropins like FSH and LH. We have learnt about basic fundamental characteristic features of gonadotropin releasing hormone in previous human reproduction chapter. Spermatogenesis begins at the age of puberty. Spermatogenesis begins at the age of puberty by the action of gonadotropin releasing hormone. Gonadotropin releasing hormone acts on anterior pituitary. Gonadotropin releasing hormone acts on anterior pituitary or adenohypophysis to secrete gonadotropins like FSH and LH. Individually, FSH acts on Sertoli cells. FSH acts on Sertoli cells to secrete some factors. FSH acts on Sertoli cells to secrete some factors. Those factors are responsible for spermiogenesis. Got it? FSH acts on Sertoli cells to secrete some factors. Those factors are responsible for spermiogenesis. But LH, luteinizing hormone, acts on Leydig cells. LH acts on Leydig cells to secrete androgen or testosterone or male sex hormone or testicular hormone. Androgens are responsible for entire spermatogenesis. Androgens are responsible for entire spermatogenesis. Okay, thank you for your kind cooperation. Prepare well for tomorrow's examination. Thank you.
So, good morning students. Yesterday we have started the fresh chapter Cell the Unit of Life. In this Cell the Unit of Life concept, the discussion was going on. So, yesterday we have done the discussion, a brief idea about the prokaryotic cell. In very shortcut way, let me discuss. Suppose this is a prokaryotic cell. So, what do we know about the prokaryotic cell? Already I told you. So, outermost layer is a 3-layered protection. Outermost layer is going to be the glycocalyx. Below to that cell wall is there. Below to that cell membrane is there. These 3 units works as a single protective unit. This glycocalyx, we can consider it as a capsule when it is thick and tough. It is a loose sheath when it is going to be called as a slime layer. Now, this cell wall and cell membrane, among these 3, who interacts with the outside world, that is going to be the cell membrane. Inside that cytoplasm is there, it is a main arena for all the cellular activities. And in this membrane bound structures are absent. There are 3 surface structures are there. One is the lengthier structure, we can consider it as a flagella, which is having some basal body, hook and the filament. Lengthier part is going to be the filament, and then tubular structures are there. These are called as a pili, and bristle-like structures are there. Those are going to be considered as a fimbriae. The function of the fimbriae is to attachment in the rocks and streams, and useful for attachment to the host tissues also. And this pili function is for sexual reproduction. Flagella is for the movement. Now, inside the cell, what are the structures present? There are some infoldings of the plasma membrane is there. Those are called as mesosomes. Those are going to be called as mesosomes. But these mesosomes present in 3 forms. Sometimes they are vesicles, sometimes they are tubules, sometimes they are flagella. The mesosomes are infoldings of the plasma membrane into the cell. These are involved in different kinds of functions. My first thing, they are involved in replication, DNA replication and respiration. In case of the eukaryotes, mitochondria is there for respiration, but here the mesosomes are the respiratory structures, and it is going to increase the enzymatic content and the distribution of DNA between 2 cells. Even it secretes enzyme that is useful for the formation of the cell wall. So, these are the things about the mesosomes. Then along with that, there are another infolding of the plasma membrane is there in some photosynthetic bacteria. We can call them as chromatophores. Chromatophores. So, chromatophores are the structures which are going to store the pigments in them. Especially cyanobacteria or photosynthetic bacteria, blue-green algae. In them, these chromatophores are there which are going to store the pigments in it. Pigments are present. In cyanobacteria, biological classification concept, they are mentioning that these are having the cyanobacteria having pigments similar to the higher plants. So, cyanobacteria like organisms, the chromatophores are present. Along with that, inside ribosomes are there. There is a particular point about the ribosomes. Ribosomes present in this prokaryotes are of 70S type of ribosomes are there. In this 70S type of ribosomes, larger subunit will be 50S, smaller subunit will be 70S. And the S indicates the Swedberg unit, which is going to be called as a sedimentation coefficient. Now, these ribosomes, many ribosomes, when they attach onto the single mRNA, we can consider this structure as a polysome or polyribosome. Polysome or polyribosome. So, what is this polyribosome or polysome? Many ribosomes attached onto the single mRNA. We can consider it as a polysome. Now, there is no 80S type of ribosomes present in this, only 70S type of ribosomes are present. Along with that, there are some non-membrane bound structures are also present, like gas vacuoles, which is useful for buoyancy, and along with that synophysin granules, glycogen granules. These are all going to be inclusion bodies. So, suppose the synophysin granules are there, they are not associated with the plasma membrane, they are not surrounded by any membrane at all because non-membrane bound structures, they are going to be useful for the storage of the food. Glycogen granules are like that, synophysin granules are like that, phosphate granules are also there. So, in brief, it is going to be the prokaryotic cell structure. And another thing which we are already discussed in molecular basis of inheritance and also biotechnology chapter, this is having the naked DNA. And the kind of DNA present in the bacteria is a circular DNA. Circular DNA is present in this. What is the length of the DNA in E. coli bacteria? We know it right already, 4.6 into 10 power 6 base pairs of DNA is there. And the DNA replication time in this is going to be 20 minutes, cell division time is DNA replication time is 18 minutes, cell division time here is going to be the 20 minutes. Next, along with that extra chromosomal DNA is there, we can call it as a plasmid. So plasmid is a circular extra chromosomal DNA, it is having autonomously replicating feature. Because of this we can do the transformation process in case of biotechnology concept. So this plasmid having ORI, origin of replication, where because of this it undergo multiplication without depending on the chromosomal DNA. So this is the thing. When it comes to the differences between prokaryotic and eukaryotic cell, prokaryotic cells do not have membrane bound structures, eukaryotic cells have them. Prokaryotic cells are having these non-membrane bound, what do you say, with locomotory organs in a simple way. Eukaryotic structures are having complex locomotory structures are present. Prokaryotic structures, examples are monomer organisms like bacteria, cyanobacteria, mycoplasma and PPLO. Now we are entering slowly into the eukaryotic cell structures. So there is a huge discussion to be continued related to this cell unit of life, eukaryotic structures. As a time being, we are going through some important concepts. So eukaryotic cell. So first, if you have to discuss about the cell membrane. So what are the details related to the cell membrane? After 1950s, with the advantages of electron microscope, scientists have done the research about different cells. For example, in our story of discussion, we are taking the plasma membrane of the RBC. This plasma membrane of the RBC made up of mainly mainly two chemicals and one is additional one. So the main one is going to be the proteins, along with that lipids are there, along with that carbohydrates are there. If the question comes, plasma membrane is mainly made up of proteins and lipids. Minor contribution is done by the carbohydrates. How much percentage of proteins are there? 51% is there. Sorry, 52% is there. Lipids is around 40% is there. Carbohydrates is negligible concentration. So majority of the complex is made up of proteins and second place is going to be the lipids. And remember, these are the numbers or percentages applicable to plasma membrane of the RBC cell. Cell to cell, this percentage of lipids and the proteins is going to get changed. See, these lipids which are present here is of three types of lipids are there. Among them, main lipid is going to be the Hello, వస్తుందా? చూడు. So, okay, a small technical glitch. Let me revise it, ma'am. Cell membrane is made up of proteins, lipids and the carbohydrates. Mainly we are discussing about the proteins and lipids here. The kind of lipids present in the cell membrane are of three types: phospholipids, glycolipids and also cholesterols. This cholesterol is a structure present in case of the animal cells. In the plants, these cholesterols are not going to be seen. See, this phospholipid is a main component of the cell membrane. Phospholipid having two kinds of structures. It is having a polar head and a non-polar tail. So, it is a polar head which is hydrophilic in nature, and it is going to be non-polar tail which is hydrophobic in nature. So, this non-polar tail is having saturated hydrocarbons in this, which are very sensitive to the aqueous environment. I mean by water. So, this non-polar tail which is very sensitive to the water, it should be protected from the aqueous environment, so that the lipids are arranged in the bilayer. Phospholipids in the plasma membrane, they are arranged in bilayers. While they are arranged in the bilayers, the polar head is towards outer side, non-polar tail is towards inner side. Polar head towards outer, non-polar tail towards inner. So, this is the structure. So, these are why the arrangement is like this, because to protect the non-polar tail from the aqueous environment. Next. So, these phospholipids are having quasi-fluid nature. What is mean by quasi-fluid nature? These are semi-solids. Semi-solids, not liquid, not completely solid. This allows the movement of protein within the plasma membrane. How? Let me explain first proteins. But these proteins are of two types. One is integral membrane proteins, we can call them as intrinsic proteins. These are embedded in the plasma membrane, intrinsic proteins. And some are extrinsic proteins which are present on the surface of the plasma membrane. The proteins which are buried partially or totally, which are buried means present inside the plasma membrane, either partially or totally, we can call them as integral proteins or also intrinsic proteins. So, intrinsic proteins. Some proteins are there which are present on the surface, these are going to be called as extrinsic proteins. So, on what basis they have divided this? Based on ease of extraction. How easily we can extract them, based on that intrinsic proteins and extrinsic proteins are there. Extrinsic proteins are easy to extract, these are not easy to extract. See, these structure, these proteins are able to show lateral movement. They can show the lateral movement because the phospholipids are having quasi-fluid nature. So, this is a semi-solid in nature, so that these proteins can move laterally. Lateral movement of the protein is possible because of quasi-fluid nature of the lipids. So, this was explained by particular model in the year 1972. Singer and Nicholson are the scientists. They have proposed fluid mosaic model. Fluid mosaic model. There are many details are there related to this fluid mosaic model. As per our NCERT is concerned, the phospholipid is having quasi-fluid nature. This allows the lateral movement of the protein, which is measured by a term called as a fluidity. Measured by a term called as fluidity. But this fluidity of the plasma membrane is important for many functions of the plasma membrane. What is that? First one is going to be cell division, cell growth, cell division, cell growth, and also endocytosis. Endocytosis means anything cell taking into it, eating a component by the cell, we can consider it as endocytosis, absorbing the solid substances into the cell. So, cell division, cell growth, endocytosis, formation of intracellular junctions, many other functions are there. All these functions of the plasma membrane is because of fluidity which is arised by lateral movement of the proteins. And then another main function of the plasma membrane, that is a permeability. The plasma membrane is selectively permeable. Selectively permeable means it is going to select the molecules which can pass across through it. So, there is two kinds of transport is there. One is going to be the passive transport. Another one is going to be the active transport. Passive transport and active transport, two types are there. So, first in this passive transport, In this passive transport, the movement of molecules from high concentration to low concentration. From high concentration to low concentration, the movement of molecules is going to be called as a passive transport. So, this passive transport, first high to low concentration, we can call it as a along the concentration gradient. If it is moving from low concentration to high concentration, this is going to be called as against the concentration gradient. So, this is high to low along the gradient, this is against the gradient from low to high. So, as per passive transport, no energy is required. There is no energy required because it is a passive process, high to low. Active transports requires the utilization of ATP energy. ATP is the energy currency of the cell. Now, in this passive transport, three terms are there. One is going to be the simple diffusion. Simple diffusion, it will be possible because of neutral solutes. The neutral solutes are going to pass the plasma membrane from high to low concentration with the process of simple diffusion. Next, second thing, low to high to low concentration, another one is there, that is going to be called as osmosis. So, what is this osmosis? Transport of materials from high to low in the form of water. So, transport of water molecules from high to low concentration, we can call it as a osmosis. Same way, there are some polar solutes are there. There are some polar solutes. These polar solutes can come up to the head of the plasma membrane but cannot pass through the hydrophobic non-polar tail. So that their movement should be facilitated by some proteins. Those are called as a carrier proteins. Who can act as carrier proteins? These integral membrane proteins are act as a carrier proteins. For example, I can say you in chemiosmotic hypothesis, photosynthesis, even in the respiration, H plus ions are passing through the membrane of the thylakoid, membrane of the mitochondria, inner membrane of the mitochondria is occur because of this integral membrane proteins. There we have said F naught. So, this is an integral membrane protein or intrinsic protein that allow the movement of the polar solutes across the plasma membrane from high concentration to low concentration. So, this process is going to be called as a facilitated diffusion. So, this passive transport is of three types. One is diffusion, another one is osmosis, another one is a facilitated diffusion. Diffusion means transport of materials from high to low concentration, which is the neutral molecules. High to low concentration transport of water is going to be called as osmosis. Polar solutes transport from high to low with the help of a integral membrane protein or carrier proteins is going to be called as a facilitated diffusion. Whereas active transports requires the utilization of ATP energy because it is moving from low to high concentration reverse, it requires the energy. Example for this is Na plus and K plus pump. Na plus and K plus pump. Because of this, there is a movement of molecules from low concentration to high concentration. That is the logic here. Next, after saying this plasma membrane, let me move ahead. Related to this, let me have a brief discussion about the cell wall. We know cell wall is a non-living rigid structure present in the organisms like plants, fungi, and even monerans, even in case of some kind of protists. Cell wall containing protisma, chrysophytes are there. Example, soap box like arrangement made up of silica. Plants, the cell wall is majorly made up of cellulose. Many other details are there, it is mainly involved in protecting the cell and it determines the shape of the cell. So, composition of the cell wall, in case of fungi, the cell wall composition is made up of chitin and cellulose. Already I told you about the chitin. Chitin is a structure which is a homopolymer of N-acetyl galactosamine. N-acetyl galactosamine, and even it is present in exoskeleton of arthropods. And the same chitin related decomposition concept, there is another point, if the detritus is rich in chitin, process of decomposition will be slow, which is a hard material to break. Next, cell wall composition of the algae. So, in the algae, what is the cell wall composition? Here, one is cellulose, galactans, mannans are there, and minerals like calcium carbonate. So, observe here, in the algae, what is the composition of the cell? Cellulose, galactans, mannans, and minerals like calcium carbonates. And plant cell wall. In the plant cell wall main component, star component is cellulose here, along with that hemicellulose here, along with that pectin is there, along with that proteins are there. Proteins are there. I have seen an interesting statement, ma'am, somewhere in other question paper. Protein is a common substance present between plasma membrane and the cell membrane and the cell wall. Do you agree? Yes. Proteins are present both in the cell membrane and also the cell wall, common structures. So, in the plants, the composition of the cell wall includes cellulose, hemicellulose, pectin and the protein. That is the logic. Next, there are two kinds of cell wall is there. One is going to be the primary cell wall, another one is going to be the secondary cell wall. Primary cell wall is found in the earlier stage of the cell. Meristematic cell are having primary cell walls, if you remember. They are having thin layer capable of growth, this primary cell wall. It is flexible and it is made up of cellulose mainly. And this cell wall gradually diminishes when the cell starts growing. When the cell entering from meristematic to elongation phase, if you remember, new cell wall deposition started. So that the secondary cell wall formation starts. But the point everyone has to remember, the secondary cell wall formation, suppose this is a primary cell wall, below is going to be the plasma membrane. The secondary cell wall formation occurs from the plasma membrane. From the plasma membrane, there is a formation of the secondary cell wall. It is towards the plasma membrane it will be formed, not towards the cell wall. Remember it. Next, this secondary cell wall is very rigid structure, incapable of growth, because it is formed at the matured stage. So, primary cell wall will be present in the meristematic phase, secondary cell wall will be present in the matured stage. And between two cells, suppose this is one cell, this is another cell, in between them there is a cementing material is present. Cementing material is present between two cell walls, that is called as middle lamella. If you remember, during the cell division, cytokinesis, I have mentioned that cell plate is formed by Golgi apparatus, vesicles of Golgi apparatus. This cell plate is a precursor of the cell wall and it represents the middle lamella between two cells. That is the logic here. Next, after saying about cell membrane and the cell wall, let me move ahead related to endomembrane system. So, endomembrane system contains the cell organelles whose functions are coordinated. Those structures are going to be part of the endomembrane system, remember it. See, these endomembrane system, what are the cell organelles included? First one is ER, endoplasmic reticulum. Next one is going to be the Golgi bodies. Next one is going to be the lysosomes. And the last one is going to be the vacuoles. So, ER, Golgi, lysosomes and vacuoles, these functions are coordinated. That is why they are kept under the endomembrane system. Whereas, this chloroplast and the mitochondria, those are not included in this endomembrane system because their functions are not coordinated. And even suppose ER, Golgi, lysosomes and vacuoles structures are coordinated, that is why they are placed in the endomembrane system, it is absolutely wrong. So, their functions are coordinated, structures are not coordinated. So, let me observe the details of this endomembrane system. First, suppose the nucleus is there, which is the control center of the cell or brain of the cell, nuclear envelope. From the nuclear envelope, there are some membranous extensions are there. Those membranous extensions into the cytoplasm are going to be the endoplasmic reticulum. So, reticulum means network. These are present inside the cell. The network present inside the cell, we can call it as a endoplasmic reticulum. This endoplasmic reticulum, based on the presence and absence of this ribosomes, it is of two types. One is going to be the smooth endoplasmic reticulum, another one is a rough endoplasmic reticulum. This rough endoplasmic reticulum contains the ribosomes on its surface. Ribosomes on its surface. Because of this surface is rough, we call it as a rough endoplasmic reticulum. This rough endoplasmic reticulum functions in the production and secretion of the proteins. It involves in the production and secretion of the proteins. And SCR involved in the synthesis of lipids. Lipid synthesis going to happen within the smooth endoplasmic reticulum. And also in case of animal cells, it is going to produce lipid-like steroidal compounds. Lipid-like steroidal compounds within the animal cells are going to get produced within the smooth endoplasmic reticulum. And this endoplasmic reticulum divides the entire structure of the cell into two parts. Entire volume of the cell will be divided into two parts because of endoplasmic reticulum. One is inside the ER, that is going to be called as luminal compartment. Luminal compartment. Another one is outside the ER, that is going to be called as extraluminal compartment. So luminal and extraluminal two are there. Luminal compartment means within the ER, outside of the ER we can call it as an extraluminal compartment. That is the thing. Next, from this ER, whatever proteins and lipids are synthesized, they will slowly enter into the Golgi apparatus. So Golgi apparatus was discovered by a scientist called Camillo Golgi. Camillo Golgi observed that near to the nucleus and near to the endoplasmic reticulum, there are some vesicular structures are there, network-like vesicular structures are there. Those are going to be called as Golgi bodies or Golgi apparatus. These Golgi apparatus having the characteristic shape. These Golgi apparatus, they are interconnected. See, this Golgi apparatus having two phases, one is going to be the cis phase, another one is going to be the trans phase. This cis phase is also called forming phase, and this is going to be called as a maturing phase. This is having the shape called as a convex phase, it is going to be concave shape. Convex and concave. This is entry, this is exit. The main function of this Golgi apparatus, this is involved in packaging of the materials. And the structures present in this is called as a cisternae. Cisternae. Generally students confuse us here. In the mitochondria, there are infoldings of the membrane is there. Those are called as a cristae. Cristae is the structures present within the mitochondria. Cisternae are the structures present in the Golgi apparatus. In the Golgi apparatus, there are parallel structures, disc-shaped structures are there called cisternae. In the textbook, they have used the word concentrically arranged and parallel to each other. Concentrically means one surrounding the other. One surrounding the other. This is called as a concentric arrangement and they are parallel to each other. This cis phase and trans phase are completely different, but they are interconnected to one another. The materials which are entering into this Golgi, they will enter through cis phase and they will exit to the trans phase. In the middle of the cisternae, what is going to happen? Processing is going to happen. What is that processing? Packaging of the materials. The main function of the Golgi apparatus, packaging. That's why we consider, generally I say to the students, Golgi apparatus is called as Amazon factory or Flipkart of the cell. Why it is called as Amazon or Flipkart? These Amazon and Flipkart fellows are not going to produce anything. Just they will acquire from the manufacturers and sell it to the customers. Same way, this Golgi apparatus going to absorb the materials produced in ER and Golgi. In the ER and Golgi, whatever materials produced like proteins and lipids, they will be entered into Golgi apparatus through the cis phase and exit to trans phase after packaging. The packed materials will be transported into the cell or outside the cell also. Whatever the delivery location, they will deliver it. So Golgi is not involved in synthesis of anything, but it is involved in the packaging of everything. That is the logic. Now here, the proteins which are produced from the ER and the lipids which are produced from the SCR, it is from the RER. The proteins and the lipids are entering into Golgi apparatus through cis phase. And they will undergo processing in the middle, we call it as a cisternae, and they are exiting in the form of two structures. One is going to be the glycoproteins. Proteins will become glycoproteins Another one is going to be the glycolipids. Lipids will form glycolipids, proteins will form glycoproteins. In the textbook they are given a contradictory statement. Main site for the synthesis of glycoproteins and glycolipids is going to be the Golgi. It is not going to, actually the statement seems like synthesis, but it is not synthesizing it. Lipids and proteins are just modified inside the Golgi apparatus. That is the logic here. So, the proteins from the RER, lipids from the SCR entering through cis phase, packaged in the cisternae and exit to transphase in the form of glycoproteins and glycolipids. These glycoproteins and glycolipids are released in the form of a circular membrane bound structures. We can call them as vesicles. What do you call them? Vesicles. So, from the Golgi apparatus, a round membrane bound structures are released, vesicular structures. They contains glycolipids and the glycoproteins. And I told you during the cytokinesis in the plants, the cell plate is formed by vesicles of the Golgi apparatus. That is a logic. Even the same Golgi apparatus we have seen in the acrosome or head of this sperm. So, this Golgi apparatus involves in the packaging function. And remember, entry phase is a cis phase, convex phase, forming phase. Exit phase is going to be the trans phase, maturing phase and convex, concave shape. Remember it. In the middle, the structures are going to be the cisternae. But these vesicles which are formed, some of the vesicles form a membrane bound structures called as lysosomes. So, textbook if you observe, lysosome is a membrane bound vesicular structure. Membrane bound, it is a membrane bound vesicular structure formed as a result of packaging in Golgi. Membrane bound vesicular structure formed as a result of packaging in the Golgi. This lysosome is considered as the suicidal bag of the cell. Why it is considered as suicidal bag? Because it contains very dangerous enzymes, terrorist enzymes are there, those are called as hydrolytic enzymes. Hydrolytic enzymes, where we have seen this same biomolecules chapter. Hydrolases, they are going to involve in the breakdown of ether, ester, peptide, carbon to carbon, carbon to halide, phosphorus to nitrogen bonds will be broken by these enzymes, and these enzymes are active at the acidic pH. They will become activated at acidic pH. Idu contradiction, just for connection I am saying, in the BT cotton concept, the protoxin which is produced by Bacillus thuringiensis will become activated toxin in the presence of alkaline pH. Here the inactive hydrolytic enzymes of the lysosome will become activated in the presence of acidic pH. Remember it. And these hydrolytic enzymes are many examples are there. One is proteases which are going to involve in the breakdown of proteins. Next one is the carbohydrases, they are involved in the breakdown of carbohydrates like our amylase enzyme, and there are some nucleases which are going to break the nucleic acids. Nucleases are two types, exonuclease and the endonuclease, restriction enzymes, and along with that lipases are there which are going to break the lipids. Because of presence of this many hydrolytic enzymes which are involved in breakdown of the components of the cell, we can consider the lysosome as a suicidal bags of the cell. So, manufacture factory, packaging process, whatever package that will form the lysosome, in the lysosome whatever extra material is that will be broken down. The waste materials which are produced by breakdown of the lysosome will be stored in a storehouse of the cell, that is going to be the vacuoles. See, these vacuoles, what they are doing, vacuole is occupying 90% of space of the cell in case of the plants. Occupy 90% volume of cell in plants. And this vacuole having a single membrane surrounding, that single membrane is going to be called as a tonoplast. And inside this tonoplast there is a large amount of cytoplasmic material is there, we can call it as a tonoplasm. But this tonoplast having one peculiar function, it is involved in active transport. It transports the material from low concentration to high concentration. Low to high. Shall I consider it as active transport now? Yes, we told low to high concentration transport is going to be called as against the gradient. So the membrane which is present in the vacuole is a tonoplast. The tonoplast is having this membrane. The tonoplast having one peculiar feature called transport of materials from low concentration to high concentration against the gradient. So that what we have to assume, the concentration of materials will be high inside the vacuole than in the cytoplasm which is surrounding. So concentration of materials will be low in the cytoplasm and concentration of materials will be high within the vacuole. And what are the functions of the vacuole? It is going to store excretory materials, water, sap or any other materials which are not useful for the cell. All of those are going to stored in the vacuoles. Especially large vacuoles we can see in the plants. In animal cells also there are very small vacuoles and they are temporary structures. Majorly vacuole andre plant cell nenpetkobeku. Next, after that what we can say here, there are types of vacuoles are there. Sap vacuoles are found in the plants. Sap vacuoles are found in the plants, and there are some other vacuoles present in amoeba. The vacuoles which are present in the amoeba is going to be called as a contractile vacuoles. Contractile vacuoles. And other kind of material vacuoles are there, those are present in the protozoans. The vacuoles present in the protozoans are going to be called as a food vacuoles. So amoeba is having the contractile vacuoles which are useful for osmoregulation and also excretion. Protozoans are having the food vacuoles which are useful for storage of the food. So entire these structures we can keep under the endomembrane system. So in the endomembrane system whatever structures are there, all those functions are coordinated. So first one is ER, involved in the production of proteins and the lipids by the RER and SCR. These proteins and lipids are entering into Golgi apparatus through the cis phase and packed during the process in the cisternae and exit through the trans phase of the Golgi. The main functions of the Golgi is involved in the packaging of materials. The proteins after entry they will be released in the form of glycoproteins and the lipids will be released in the form of glycolipids. Some of these vesicles which are formed here which form the structure called as the lysosomes. Lysosomes are membrane bound vesicular structures. They are having hydrolytic enzymes which will be activated in the acidic pH. They involve different kinds of structures. They are going to break proteases, break the proteins, carbohydrates, break the carbohydrates, and these nucleases which are going to break the nucleic acids, and lipase is going to break the lipids. Next, whatever after breakdown the excretory material will be stored in a structure called as vacuole. Vacuole is having a single membrane called as a tonoplast and the cytoplasm is called, plasm present inside the vacuole is called tonoplasm. This tonoplast transport the materials from the low concentration to high concentration against the gradient, so that high concentration of materials within the vacuole than in the cytoplasm. Along with that there are other kinds of vacuoles. Here what we have discussed is sap vacuoles, we can observe it in the plants. Amoeba having contractile vacuole and protozoans are having the food vacuoles. So these are the detailed discussion related to the endomembrane system. After that another discussion is going to be related to mitochondria. Mitochondria is a double membrane bound structure and this structure is not easily visible under the microscope unless it is specifically stained. So there is a textbook statement, mitochondria is not easily visible unless specifically stained. Means what? If you have to observe the mitochondria under the microscope, first we have to add a specific stains to it. The stain which is used to observe the mitochondria is a Janus green. When you add the Janus green, then only mitochondria is visible for you. That is the structural logic behind the observation of mitochondria. And these mitochondria, what we have to assume, this mitochondria is number of mitochondria based on physiological activity of the cell. Physiological activity of the cell. What is meant by this physiological activity here? If a cell having more function, more work, the number of mitochondria will be more. Suppose the heart cells which are always involved in the functioning, the cardiac muscles, the cells of the cardiac muscles are having high amount of mitochondria than the normal cells. Wherever the work is less, the number of mitochondria will be less. Why? Because these mitochondria are considered as a powerhouse of the cell. powerhouse of the cell. That's why where they require more, they will be present, more mitochondria will be present when there is a more work. And this mitochondria double membrane bound structure, shape is going to be sausage or cylindrical shape. Shape is going to be sausage or cylindrical. So sausage shape, what you can draw here, it is a double membrane bound. One is going to be the outer membrane, another one is going to be the inner membrane. Inner membrane. So outer membrane and inner membrane, two are there. So these outer and inner membrane divides the mitochondria into two different compartments. What are those? The compartment, the space between outer and inner membrane, this space is going to be called as intermembrane space. Intermembrane space. The space between these two is going to be called as intermembrane space. And this intermembrane space we can also consider it as a outer compartment. This is called as intermembrane space or outer compartment. The space inside the inner membrane, this is going to be called as inner compartment. The inner compartment is having the matrix. Matrix is present inside the inner compartment. So the outer membrane is a continuous structure which is not going to have any infoldings. Whereas inner membrane having so many infoldings, these infoldings are going to be called as a cristae. Cristae. Just now I told you, the structures which are present in the Golgi apparatus are going to be considered as a cisternae. The infoldings of the mitochondrial inner membrane is going to be called as a cristae. But these cristae involved in increasing the surface area of the membrane, and the inner membrane having another function, respiratory oxidative phosphorylation process. Complex 1, 2, 3, 4, 5, all these complexes are present in the inner membrane of the mitochondria. And do you remember, one particular enzyme belongs to Krebs cycle, not present in the matrix of mitochondria but present in the inner membrane. That is a succinic dehydrogenase. That is also present in the inner membrane of mitochondria. Next, outer membrane does not have any infoldings like this, but the inner membrane having these infoldings, we can call them as a cristae. And the matrix which is present here, matrix present in this, having machinery for the protein synthesis. Protein synthesizing machinery is there. First, for that, double stranded DNA is there into one copy, only one copy. Generally students confuse this. What they said, single double stranded DNA is present. Single means one copy of double stranded DNA. One copy of the double stranded DNA is present in this matrix. So that is double stranded DNA. Next one is going to be few molecules of RNA is there, and few molecules of ribosomes are also there. Very carefully you have to understand here, ribosomes are of two types, 70S and the 80S. 70S type of ribosomes are generally found in the prokaryotic structures. 80S ribosomes are found in the eukaryotic structures. 80S type of ribosomes are found in eukaryotes, that too in the cytoplasm. And also they can be present in the membrane of the ER. On the ER, in the cytoplasm, the kind of ribosomes found in eukaryotes is 80S. Whereas in case of the mitochondria, it looks like a prokaryotic structure because it having 70S type of ribosomes. 70S type of ribosomes are present. So outer membrane, inner membrane, below to that matrix is there. This matrix is having single copy of double stranded DNA, few RNA molecules and the ribosomes. All these are involved in synthesis of the proteins. As it is able to synthesize the proteins on its own, we can consider it as a semi-autonomous organelle. Semi-autonomous organelle. Why? Because it is able to synthesize its own proteins. Next, outer membrane and inner membrane, are they structurally similar? That is a question here. Outer and inner membrane are not structurally similar because outer membrane is a continuous, inner membrane having so many infoldings. Whereas functionally outer and inner membrane here also they are different. How can we say? In the textbook itself they are saying a statement, outer and inner membranes having their own particular enzymes. Their functionality is different and their structure is different. What we can assume it here. So these are semi-autonomous organelles, double membrane bound organelles, and what is the function of this mitochondria? It is a site for aerobic respiration. Aerobic respiration. Already we have completed this concept. In the glycolysis which is occurring in the cytoplasm, product is pyruvic acid. The pyruvic acid from the cytoplasm, it is transported into the mitochondria. Pyruvic acid from the cytoplasm transported into the mitochondria. After entering into the mitochondria, pyruvic acid undergo link reaction. Firstly, it will converted into acetyl coenzyme A. After that, it is entering into a cyclic process that is going to be called as Krebs cycle. So, because of this link reaction and Krebs cycle, subsequently electron transport system, all the majority of the ATP synthesis happens in the mitochondria. It is a site for aerobic respiration. As it is going to synthesize large number of mitochondria, we can consider the mitochondria as a powerhouse of the cell. That is why I told you, wherever high energy requirement is there more number of mitochondria will be possible. It is based on physiological activity of the cell. After that, the next structures to be discussed are the plastids. Plastids are the structures generally found in all cells of plants and euglenoids. So, euglenoids belongs to the kingdom Protista. In the euglenoids and also all cells of the plants, we are having the plastids. Now, what is the function of the plastids? These are the structures which are going to store the pigments and impart the colors to the plants. I am repeating, plastids are the storage structures of the pigments and impart colors to the plant body. Same function of the plastids done by a structure in the prokaryotes. Do you remember? Chromatophores. Chromatophores are the structures which are going to store the pigments. Same like mitochondria, there is a structure functioning in the prokaryotes, that is mesosomes, which are enfolding some of the plasma membrane. Now, these plastids are of different types. We can basically divide them into colorful plastids and colorless plastids. Colorful and colorless. Colorless plastids are there. What is mean by this colorful plastids, which are handling the pigments, which are not going to have the pigments, those are called as colorless plastids. Colorful plastids, first one is a chromoplast, and second one is going to be the chloroplast. Second one is going to be the chloroplast. Now, these colorless plastids here is going to be leucoplast. So, these leucoplasts are not going to store any pigments. Instead of storing the pigments, these are going to store the food materials of the body, food materials of the plants. See, this chromoplast, it is going to store fat soluble pigments like carotenoids and xanthophylls. Fat soluble pigments like carotenoids and xanthophylls will be stored in the chromoplast. Chloroplast is going to store the same thing, chlorophyll pigments like chlorophyll A, chlorophyll B, and also xanthophylls and the carotenoids. All this will be stored within the chloroplast. And leucoplast, there are different kinds of structures are there. What we can assume here, this leucoplast is going to store proteins. When they store the proteins, these are called as alluroplast. When they are storing the proteins, those are going to be called as alluroplast. How can we remember this one? Do you remember alluron layer? Alluron layer in the monocot seeds, the endosperm is surrounded by a proteinaceous layer called as alluron layer. So, alluron layer is made up of proteins. So, alluro means protein, you can remember it like that. After that, there are some structures which are going to store the carbohydrates. Those are going to be called as amyloplast. See, these amyloplasts are the structures storing the carbohydrates, especially in the form of starch. Next is we can observe this in the potato. After that, another kind of leucoplast is going to be the elaioplast. Elaioplasts are the structures going to store oils and the fats. Oils and fats will be stored in the elaioplast. And the structure of the chloroplast we have to discuss. The structure of the chloroplast already we have discussed in the photosynthesis concept. It is a double membrane bound structure. One point everyone has to remember, inner membrane of the chloroplast is more permeable than outer membrane. Less permeable than outer membrane. Inner membrane is relatively less permeable than outer membrane. The space inside the inner membrane is going to be called as a stroma. In that stroma, there are membrane bound structures are there called thylakoids. Many thylakoids are combined together to form a piles of coins called as grana. There are connections between one grana to another grana. This is going to be called as a stroma lamella. Thylakoids are the places for the non-cyclic photophosphorylation, and these stroma lamella are the places for cyclic photophosphorylation. And in the stroma, there are enzymes for synthesis of carbohydrates and the proteins. Synthesis of carbohydrate, what is the enzyme involved? Rubisco, most abundant enzyme in the whole biosphere. Rubisco is there. So, the stroma is a site where dark reactions are going to happen. I mean by C3 cycle, even the C4 cycle. So, this chloroplast, majority of the chloroplasts are found in the mesophyll cells. 20 to 40 chloroplasts will be there in the mesophyll cells. And finally, what is the protein synthesizing machinery we can found in the mitochondria? Same structures we can found also found in the chloroplast. Single, double stranded DNA, RNA molecules, and 70S type of ribosomes. And the main function of the chloroplast is involved in the photosynthesis. And one more point I forgot to mention here, mitochondria divides by a process called as binary fission. Binary fission. So, there we wind up the process. We are going to end here. If any possibility is there during this paper discussions time, I will discuss the centriole and the centrosome structures in the middle somewhere. Tomorrow we will have the examination as usual. I told you the syllabus, cell the unit of life, cell cycle, cell division, and the biomolecules. This is all for today. Meet you in the next session in the tomorrow paper discussion. Thank you.
Okay, good afternoon all of you students. So today topic thermal properties of matter. In thermal properties of matter, on the previous year majority of the questions are given on heat transfer chapter. So the today topic is heat transfer. Heat transfer. Right. So generally heat transfer are the three types: conduction, convection, and radiation. But majority important concepts are conduction and radiation. Okay, first we can discuss some important points on conduction. On conduction. Now listen. So this is the conductor. This is the conductor. Here one side temperature theta 1, another side temperature theta 2. L is the length. A is the area of the cross section of the conductor. Here heat is enter from one end and heat is leaving to another end. What is the heat? Q amount of the heat. In how much time? T time. That's why what is the rate of heat flowing through the conductor? The rate of heat flow through the conductor is equal to K A delta theta by L. The rate of heat flow is Q by T is equal to Ka delta theta by L, where K is known as coefficient of thermal conductivity. K is known as a coefficient of thermal conductivity. Like rate of heat flow is known as power. K A theta 1 minus theta 2 delta theta by L. So the important formula, power is equal to rate of heat flow is equal to Ka delta theta by L. Like power means rate of heat. Right. Now another point. That power is equal to delta theta by this Ka value, take them in denominator side. L by Ka. Now that is delta theta by R. Delta theta by R, where R is nothing but thermal resistance. R is nothing but a thermal resistance. Therefore, power is equal to delta theta by R. Important formula. So, the main important points are like this one. Like what is that first one? The rate of heat flow is equal to Ka delta theta by L. Next, thermal rate of heat flow is equal to delta theta by R, where R is nothing but L by Ka. That is known as thermal resistance. That is known as thermal resistance. These all are the important formulas. Like. And last, previous NEET question. What is the SI unit of the coefficient of the thermal conductivity? Is asking what is the SI unit of the coefficient of the thermal conductivity? SI unit of K. How to find that one? Power K. Watt is equal to K. Area meter square. Temperature Kelvin. Temperature Kelvin. This is the Kelvin. This is the coefficient of the thermal conductivity. Like L, length meters. This meter value square is cancelled. Therefore, what is the SI unit of the coefficient of thermal conductivity? Watt. Value take them in this side. Meter power minus 1, K power minus 1. Watt, meter power minus 1, no, K power minus 1 is the SI unit, like previous NEET question. So, simple formula summa. Now, another important concept. Now listen, like two conductors or two rods are connected in series. This one conductivity is K1, this is the conductivity is K2. Here temperature theta 1, here temperature theta 2. So heat is starting one end, heat is leaving to another end. So on that first point, the length and area, here length area, this one length area. Like lengths are L1, the length are L2, but areas are same. Right. These two are connected in a series. What is the effective thermal conductivity? Now, how to find the effective thermal conductivity? L1 plus L2 by effective thermal conductivity. L1 by K1 L1 by K1 plus L2 by K2. So, the effective thermal conductivity is nothing but L1 plus L2 by K is equal to L1 by K1 plus L2 by K2. Important formula. For example, if L1 is equal to L2, what happens? Both are same, like 2 L. This L cancel. What is the value? So, 2 by K is equal to 1 by K1 plus 1 by K2, effective thermal conductivity when lengths are equal. If lengths are different, L1 plus L2 by K is equal to L1 by K1 plus L2 by K2. Now, another point. This end, what is the temperature? Theta 1. This end, another temperature is theta 2. What is the junction temperature? This is the previous NEET question. What is the junction temperature? Now, in series, the rate of heat flow is the same. The rate of heat flow is the same. the rate of heat flow on the first one is equal to rate of heat flow on the second one. P1 is equal to P2. That's why what is the rate of heat flow formula? Ka delta theta by LA ga. Ka delta theta. High temperature minus low temperature. Theta 1 minus theta by length L1. Next, second one. Ka delta theta. Theta minus theta 2 by length L2. Okay, that's why by this formula we can finding the theta value. So just we can equating the power values, we get the answer. That is enough. So here theta value, take them separate, we get the lengthy answer. So that lengthy answer, that is nothing but the lengthy formula. So cannot remind that formula. That concept is nothing but P1 is equal to P2. So in case of the two rods are connected in a series, what is the junction temperature? The rate of heat flow on the first one is equal to rate of heat flow on the second one. Like P1 is equal to P2. Rate of heat formula, rate of heat formula. Here A value cancel. K1, K2 values are substituting. Lengths are substituting. Theta 1, theta 2 values are is given. That's where we get the junction temperature. That is another important formula. Very, very important. This point is given the PYQ, previous year question. Previous year question. Like previous one SI unit is given. So simple formulas are important one. Now another one is, two rods are connected in parallel. This is the first rod, conductivity K1, conductivity K2, whose area is A1, whose area is A2, but the both are same length. Now heat is entering, here the heat is enters. Now the heat is enters is divided the two parts. The total heat here combined again go to that same heat. So what is the formula here? The amount of heat here divide the two parts. Like Q1 is equal to Q2 nega. Like power is equal to P1 plus P2 nega. So that is the important formula. In parallel, the rate of heat flow is equal to sum of the individual rate of heat flows, like P1 plus P2. Now another point. Effective thermal conductivity. In parallel, effective thermal conductivity is K1A1 plus K2A2 by A1 plus A2. The effective thermal conductivity K1A1 plus K2A2 by A1 plus A2. If A1 is equal to A2, what is the effective thermal conductivity? So A value common. Here 2A. What is the value? K1 plus K2 by 2. K1 plus K2 by 2. In parallel, this is the important formula. This one is also given on the previous NEET. The effective thermal conductivity is K1 plus K2 by 2. In case of the areas are different, K1A1 plus K2A2 by A1 plus A2. The two are the important formulas. Now another point. Another point is growth of ice in a lake. Growth of ice in a lake. Now listen. Now in cold countries, the weather temperature is reaches to negative minus 10, minus 20 in cold countries. That's why in lakes and ponds, that water is can be freezes. For X thickness of the water is freezes, how much time is taken? That is the important point. Now this is the ice. In the below one is nothing but water. In cold countries, the upper layer of the water, the like upper one is nothing but totally ice. How much thickness? X. What is the thermal conductivity? K. What is the rho? Density. Rho is the density. Upper one minus theta degree centigrade, because of weather temperature is reaches to negative. Exactly below the ice, we get the 0 degree centigrade. That's why how much time is it taken to grow the x thickness of the ice layer? That time is equal to rho L by 2k theta into x square. Rho density, L latent heat of ice, Li latent heat of ice, rho L by 2k. K is the thermal conductivity, theta is the surrounding temperature. Actually change in temperature, 0 minus of minus theta plus theta nega, like where x is the thickness. So that is the formula important one, T is equal to rho L by 2k theta into x square. So one of the previous question is there in this concept. Growth of ice in a lake, like this is the another formula. Sometimes what is the time taken by the ice layer to grow of the thickness from T1 from x1 to x2, and initially they having some thickness finally reaches to x2 thickness what is the time taken? That time is equal to rho L by 2k theta x2 square minus x1 square. Final thickness minus initial thickness. This is the another important formulas. Only I am revise the formulas. So already we know that in our notebook now we can check them, all the derivations are there. But only you can remind the formulas. This is the another point. Next one total 3 process conduction concept the important formulas are like this. Convection, but convection the only statement, there is no numericals are there just only statement. What is the meaning of convection? The amount of heat is transferred from one place to another place by the movement of the molecules. By the movement of the molecules, that heat is transferred. That phenomenon is known as convection. What are the best example? Heating of water. In case of the water can be heated, what happened? On the bowl lower side water molecules can be heated, that molecules is reaches to upper one. Above one is cold molecules are there, cold molecules move to lower one. So hot molecules are moving upward, cold molecules are moving downwards. That phenomenon is nothing but convection. And already we know that land breeze, sea breeze, trade winds, these all are the examples of the convection. Okay, just a theory point, like leave it. Now third one is the radiation. Third one is the radiation. In these 3 processes, the fastest process of the heat transfer is radiation. Because of conduction and convection, compulsory medium is required. But radiation, heat is transferred from one place to another place without necessity of the medium. That is nothing but radiation. For example, sun radiations. Sun radiations are reaches to the earth, in between them totally vacuum, so here medium is not required. That is known as radiation. Now listen, another point. One of the important points, Wien's displacement law. What is the meaning of the Wien's displacement law? Lambda is inversely proportional to T. Lambda is inversely proportional to T. What is the meaning of this one? For example, high temperature of the body emit the lower wavelength of the radiations. Lambda is inversely proportional to T means high temperature of the body. Generally body high temperature and low temperature are there. For example, very high temperature of the body it emit the radiations. That radiations are nothing but having some wavelength is there. That wavelength is nothing but lowest. High wavelength of the body emit lower wavelength of the radiations. Again, lower temperature of the bodies and low temperature of the body emits high temperature of the high wavelength of the radiations. Low temperature of the body emit high wavelength of the radiations. High temperature of the body emit lower wavelength of the radiations. Inversely important point. This one is the given previous NEET question. This one having the one of the previous question, I will explain later. Next, another one is Stephen's law. What is the meaning of Stephen's law? Right. The emissive power of the body, is directly proportional to the fourth power of the absolute temperature of the body. That constant emo T power 4. Sorry. The E is equal to sigma T power 4, where sigma is known as Stephen's constant. What is the value of Stephen's constant? 5.67 into 10 power 8 watt per meter square Kelvin power 4. So this is the one of the important formula, and also it can be written as P is equal to sigma AE T power 4. What is the meaning of P, amma? Rate of loss of heat. That rate of loss of heat, amma, that is equal to sigma AE T power 4, where A is nothing but area of the body, T is the temperature of the body, sigma is the Stephen's constant, to E emissivity of the body. E is nothing but emissivity. For perfect black body, amma, E value 1. For other bodies, amma, E values lies between 0 to 1. Amma. So simply, what is the rate of heat flow, amma? Or rate of heat flow or rate of loss of heat? Because of when body, amma, radiation can be emitted, means the heat is lost. That is nothing but a rate of loss of heat is equal to sigma AE T power 4. That is known as Stephen's law. Another one is Stephen's Boltzmann law. The rate of loss of heat sigma AE T power 4 minus T naught to the power of 4. Right. Now, the Stephen's Boltzmann law, what is the rate of loss of heat, amma? Sigma AE T power 4 minus T naught to the power of 4, where T naught is nothing but surrounding temperature of the body. Here, amma, there is no surrounding temperature, amma, like outer one is nothing but vacuum. In case of the medium is there, amma, Stephen's Boltzmann law. Outer region vacuum law, Stephen's law. Outer region is medium is there, like Stephen's Boltzmann law. Power is equal to sigma AE T power 4 minus T naught to the power of 4. Power, rate of loss of heat. That is another important formula. Next one is Newton's law of cooling. Newton's law of cooling, amma, continuous 2-3 years this model is given, amma, on Newton's law of cooling. What is the formula for Newton's law of cooling? The rate of loss of cooling, the rate of loss of the heat is directly proportional to the what is that? The rate of loss of heat is directly proportional to the difference of the temperature between the body and the surroundings. Body temperature theta, amma, surrounding temperature, amma, theta naught. That is known as Newton's law of cooling. Right. What is that meaning? The rate of loss of heat, negative sign shows that heat is lost. The rate of loss of heat is directly proportional to difference of the temperature difference between the body and surrounding. Body and surrounding, that is known as Newton's law of cooling. Now another important point, amma, same one. Initial body temperature theta 1, amma, is cool to theta 2 in time t seconds. In time t seconds. Okay, again is that body is cool to another temperature gara. That's why what is the relation between them by that Newton's law of cooling? Theta 1 minus theta 2 by t is equal to what is that? Body is cooled from theta 1 to theta 2 in time t seconds. Body is cooling from theta 1 to theta 2 in t seconds. That's why by the Newton's law of cooling, what is the expression? Theta 1 minus theta 2 by t. Generally dq like theta 1 minus theta 2 by t. Here temperature summa. This value dq rate of loss of heat. Here theta 1 minus theta 2 by t is equal to k into here body average theta 1 plus theta 2 by 2 minus theta naught. This is the Newton's law of cooling important formula summa. So these all are the important formulas just in heat transfer chapter. Now another one. Now listen carefully. Power is equal to sigma AE T power 4. Power is equal to sigma AE T power 4. Now by the Boltzmann law, by the Wien's displacement law, lambda is inversely proportional to T and T is inversely proportional to lambda nega. Proportional to T value means 1 by lambda whole power 4 ega. That is also the given the previous NEET question. Here some proportionality constant lambda is equal to bt ga. B by t ga. And time is nothing but b by lambda whole power 4. B by lambda whole power 4. This is the one of the important previous question. So on the previous year low, these all are the important points only in heat transfer topic. Okay, right. Now we can discuss the some important models in heat transfer. Okay, now listen in a 2022 question in a 2022 question, there are the two rods, one is a copper, other one is a steel of the same length and same area are joined together like this one. One is a copper, other one is a steel, same length and area. The thermal conductivity of the copper and steel are, the conductivity is 385 SI units. Here K value 50 SI units. The free ends of the copper and steel are 100 and 0. Copper side 100. Here steel side 0. That's why what is the temperature at the junction? Like is asking the temperature at the junction like this one. What is the temperature at the junction? Now two rods are connected in a series ka. That's why which one is the same rate of heat flow is the same. Rate of heat flow is the same. Therefore, what is the formula of rate of heat flow? K A delta theta 100 minus theta by L. Here K A delta theta minus 0 by length L. Both having the same area, same length. Okay, next 385 into 100 minus theta, this value 50 theta. So 385 into 100 minus 385 theta. Minus 385 theta, take them another side plus 385. How much value we get? 435 theta. Therefore, that theta value is equal to 385 into 100 by 435. That's why we get the answer approximately 88.5. 88.5 degrees centigrade. This is the previous question, the 2022 important model. Now another question. In a 2020 question, in a 2020 question, there are the three stars A, B, C having the temperatures, TA, TB and TC. Respectively, three stars that three stars are temperatures are TA, TB and TC. But star A emits the bluish color. Star A emits the blue color. Star B emits the reddish. And star C emits the yellow. That's why what is the relation between TA, TB and TC? TA, TB and TC, which one having the more temperature? Now listen amma, in this one actually VIBGR colors, like this one VIBGR. Go violet to red amma, wavelength value increases. Which one having the highest wavelength? Red color kada. Like red color is more, and the wavelength of the B means the B star having the red color wavelength is more. Next one amma, next yellow, next yellow, like this one yellow, wavelength of the C. Next lowest wavelength blue, like A. Already we know that relation. But according to the Wien's displacement law, high temperature of the body emit the lower wavelength of the radiation ga, and like inversely proportional to T ga, lambda is inversely proportional to T ga. Now here TB, this one emo TC, this one emo corresponding temperatures inversely. This values emo greater relation, take them lesser relation, inversely proportionality. That is the 2020 question. Now another question. In a 2019 question, already we know that this is the in cold countries water can be freezes ga. This is the water can be freezes. What is the surrounding temperature? Like minus 26 theta degree centigrade amma. Already we know that this one emo 0. K, thermal conductivity, rho, density of the ice, where X is thickness of the ice layer. How much time is it taken? T time is taken. That's why is asking the rate of thickness of ice layer pond. Is asking rate of thickness of ice at a certain thickness X. At a certain thickness X is asking the rate of thickness of the ice. Now listen, already we know that for T time is taken for X thickness. What is the formula? Rho L by 2K theta into X square. Like T is equal to rho L, rho value constant to L, latent heat of fission of the ice value is constant to 2K theta. Change in temperature, 0 high temperature, 0 minus of minus 26 plus 26 into X square. Okay, but is asking the rate of increase of thickness of ice, rate of thickness. And like dx by dt is asking, what is the meaning of rate of thickness? Dx by dt is asking. But here only x square gamma taking the differentiation with respect to time. Here d by dt value 1 no. Rho L by 2k theta value 26. What is the value of d by dt of x square amma? D by dt of x square 2x into dx by dt. This two value cancel. Therefore, dx by dt is equal to this value cross multiplying 26k by rho L x over. What is the rate of thickness of the ice layer is formed dx by dt. That dx by dt value 26k by rho L x. So this is the 2019 question. So direct formula is nothing but like this one. But is asking rate of thickness. Rate of thickness is nothing but dx by dt. And compulsory dx by dt means compulsory differentiation with respect to time with respect to time ante like this value name 1. Rho L by 2k theta value name 0 minus of minus 26 plus 26. d by dx of x square 2x into dx by dt. 2 value cancel. Therefore dx by dt amma 26k by rho lx. That is the 2019 question amma. Now another question. In a 2019 question amma. Again the 2019 question. An object amma in a larger room having the temperature at 25 degrees centigrade, take the 12 minutes amma to cool from 80 to 70 degrees centigrade. 80 degrees centigrade to 70 degrees centigrade in 12 minutes. And again 70 to 60 degrees centigrade, what is the time? But room temperature 25 degrees centigrade. A room temperature 25 degrees centigrade. This is the question amma. 80 degrees centigrade value is cooling from 80 to 70 in 12 minutes. 70 to 60 ki how much time? But room temperature value 25 is given. What is that? How to find that one? By the Newton's law of cooling. What is the formula of Newton's law of cooling? Theta 1 minus theta 2 by T is equal to K into theta 1 plus theta 2 by 2 minus theta naught. Right amma? What is the value of theta 1 and like this one? 80 minus 70 by time 12. Theta 1 plus theta 2 by 2 minus 25. We can apply the first rule, this one. Same rule amma, we can apply the for second one. No? What is that? Initial value 70 amma reaches to 60 ga. 70 minus 60 by time t. We don't know about the time. K 70 plus 60 by 2 minus 25. That is the equation 2. Now 1 by 2. 80 minus 70 like 10 by 12. By value gamma reverse. T by 70 minus 60 10. K value cancel. 80 plus 70 150 by 2 75. 75 minus 25 50. By 70 plus 60 130. 130 by 2 65. 65 minus 25 40. 10 cancel amma. This 0 0 and cancel. Therefore T is equal to 12 into 5. 12 5s are 60. By already 4 is there. Like how much amma? Sorry amma, time ga 15 minutes. Actual ga 80 to 70 ra 12 minutes ga. But 70 to 60 ra 15 minutes time is there amma. So this is the question on 2019 amma, not only in 2019. Now another question is also there. And the previous question amma, another one is also model is there. In 2016 also. In 2016 also same model. Same model is given amma on 2016. And the same model amma in 2015 AAPMT. In 2015 AIPMT. So number of the models are given amma, number of the previous years number of the times is given. This model is the very very important. Again we can try them amma, important concept. Now next another one. 2018. In a 2018 model. The power radiated by the black body amma P, it emits the wavelength of the radiation is lambda naught. Now the wavelength of the radiation is 3 lambda naught by 4. What is the power of the radiation of the body? Now listen, when your body having the rate of loss of heat like power, radiation power P, that body emit the how much wavelength of the radiation, sir? Lambda naught. For example, that body 3 lambda naught by 4 wavelength of the radiation, sir, is emitted. What is the power? This is the formula. This is the question. Right. What is the formula? What is the Boltzmann law? Stephen's law? Sigma AE T power 4. And also, directly proportional to T power 4. But already we know that by the V's displacement, lambda is inversely proportional to T nega and 1 by lambda whole power 4 ega. T value is nothing but 1 by lambda whole power 4 ega. That B value all are the constant, leave it. Now problem is over. Initial power emo P final power emo P1. Initial emo lambda naught. So inversely proportional ga P is inversely proportional to lambda naught. This power value is inversely proportional to 3 lambda naught by 4 whole power 4. Lambda naught cancel. 3 power 4. 3 3s are 9. 9 3s are 27. 27 4s are 27 4s are. What is that value? 3 lambda by 4 enega. Sorry, first you can write the one step. 3 power 4, 3 3s are 9, 9 3s are 27, 27 4s are, 27 3s are 81. 4 power 4, 4 4s are 16, 16 4s are 64, 64 4s are 256. That's why what is the value of P1 cross multiply them. Cross multiply them 256 by 81 of power. So is asking the 2018 model power is inversely proportional to lambda power 4. Just a simple model Now, next one. In a 2017 question, a spherical body of radius 12 centimeter and radiating the power 450 watts of power at a temperature of 500 Kelvin. 500 Kelvin. If the radius is half and the temperature is doubled, that's why what is the power radiation? What is the power of the radiation emitted by that body? Here this is the radius. Now again Stephen's law. Sigma AE T power 4. In that one, any body is not given means that is the perfect block body. E value leave it. Sigma value constant. Spherical body ka area value 4 pi r square E T power 4. Therefore, power value is directly proportional to r square T power 4 All the remaining values are constant. Now problem over. Initial power 450. Final power don't know. Initial radius r next time r by 2 whole square. Initial temperature T after that time 2T whole power 4. This r value cancel 2 value reverse. 2 square means 4. T value cancel 2 power 4. 2 2s are 4, 2s are 8, 2s are 16. Here this value 4. Cross multiply them. That final power is nothing but 450 into 4. 1800. 1800 power ga watts. 1800 watts. So that is the another model amma. 1 minute amma. Now next one. In 2017 question amma. And 2017 amma 2 questions are given ra. One is nothing but a radiation, another one is there are the two conducting rods like this one whose conductivities are K1 comma K2 and D is nothing but the length. Right. Here one side temperature theta 1, another side temperature theta 2. What is the effective thermal conductivity? But these two rods one in temperature, other in temperature, both are same gara, like temperature difference is the same. That's why these two are connected in parallel. In parallel, what is the effective thermal conductivity? K1 plus K2 by 2. Direct formula. Because of areas are not given and simply they are nothing but same. K1 A1 plus K2 A2 by A1 plus K2. If areas are same, K1 plus K2 by 2. This is the 2017 question. Next, in 2025 question, you can check them. That one is also the. Now 1 minute 2025 question right. In 2025 question. So there are the three conducting rods. 1, 2, 3 whose thermal conductivities are 2K and K and 2K. Here the one side temperature at 3T, another side temperature T. Here T1 this value T2. So that's why what is the find the value of T1 by T2? T1 by T2. So right how to find them? Now listen. Already we know that all the conducting rods are in series. Which one is the same rate of heat flow and like power values are same. Power values are same. What is the power formula? Ka delta theta by L kada. K area A delta theta 3T minus T1 by length L. So here length and area there is no relation that's why they all are equal. Second one ki K A delta theta T1 T2 T1 minus T2. Next here K A delta theta K A delta theta by L. Next K A by L K A by L K A by L cancel. And here 2 is a multiple 2 into 3T 2 into T1. Here only T1 minus T2. Here 2T2 minus 2T minus 2T. Okay. Here we can calculating the we can find the relation between the T1 and the T2 right. First all are equal values and this value first equating this two after that equating this two right. First equating this two what happened 6T. Minus value take them another side minus 2T1 take them another side plus kada already T1 gara plus 3T1 minus T2. Okay, that's why what is the value of T value? 3t1 minus t2 by 6 ega, right? That is the first expression. Again equating these two amma, right amma, minus here amma t1 okay ra, one step amma, t1 minus t2 2t2 minus 2t. Minus 2t take them on left side amma plus 2t. Minus t2 take them another side amma plus 3t2 minus t1. Like 2 into, what is the value of t amma? Like this one ega, 3t1 minus t2 by like 6 is equal to 3t2 minus t1. Error. Just here amma, this is the t value. This is the t value gara, substituting here amma. How much value amma? This 2 value ra here 3 times. So 3t1 minus t2 cross multiply them. 3 3s are 9t2 minus 3t1. This minus value take them here left side amma 6t1. This minus value take them another side amma 10t2. Therefore t1 by t2 amma 10 by 6 like 5 by 3. The answer is 5 by 3. Now again, 3 conducting rods are connected in series. Here are 3t and t, whose conductivities are 2k and k and 2k, having the temperatures T1 and T2. That's why what is the relation between, what is the ratio of T1 by T2? So first, all the conducting rods are in a series, powers are equal. K A delta theta by L, K A delta theta by L, K A delta theta T2 minus T2 by L, K A by L, K A by L, K A by L cancel. 2 can be multiple. Here only direct value, 2 multiple. First, all are 3 are equal. First equating these 2. 6t minus value take them another side 3t1 minus t2. Therefore t value like this. These 2 are equating minus 2t take them on left side. These values are taken another side like this. This t value substituting this value. And 3 times cancel and cross multiplying, finally we get the ratio T1 by T2. So this is the 2025 question amma. Next question amma. In 2021 question amma, another question 2021 question. A cup of coffee is cooling from 90 to 80 degrees centigrade. 90 to 80 degrees centigrade in T minutes amma. And the room temperature value is 20 degrees centigrade. Now another one. The time taken by the similar cup of the coffee to cooling from 80 to 60 degrees centigrade amma. How much time is there? How much time is taken? That is the previous question. This is the third question. Actually in Newton's law of cooling amma, third important model. All of you start this one. Theta 1 minus theta 2 by t is equal to k theta 1 plus theta 2 by 2 minus theta naught. Okay, first one 90 minus 80 by t, k 90 plus 80 by 2 minus 20. That is the equation 1. Next one 80 minus 60 by time t2, we don't know that time, k 80 plus 60 by 2 minus 20. That is the equation 2. Compulsory divide by these 2. 90 minus 80, 10 by t. This value reverse gamma. T2 by 80 minus 60 like 20. K value cancel. 90 plus 80 170. 170 by 2 170 by 2 85. 85 minus 20 65. 80 plus 60 140 by 2 70. 70 minus 20 50. Okay, Rama. Next, this value how many times, Amma? 2 times. Therefore, T2 is equal to, this one, Amma, 5 table we can cancel them, 5 10s are 5, 11, 12, 13 times. This 2t value cross multiplying, Amma. 2t value cross multiplying. This 2 value here 5 times, 13 by 5t minutes. Is the option given, Amma? 13 by 5t. 13 by 5t minutes. Important model, Amma. So already given, Amma, number of times, Amma, that model. Right. Now, next point, Amma. Now listen, some another important simple points, Amma, 2 points, I will explain them. Now listen, just we can remind some important points, Amma. Right, on the previous year questions, Amma. Calorimetry, in calorimetry, what is the meaning of specific heat? The amount of heat is required. The amount of heat is required to rise the 1 gram of the substance through 1 degree centigrade is known as specific heat. The amount of the heat is required to rise the temperature of 1 gram of the substance through 1 degree centigrade is known as specific heat. That's why what is the formula of Q, ms delta theta? Q is equal to ms delta theta. For spherical bodies, for spherical bodies, Q, mass value, volume into density. Volume into density, specific heat to delta theta. So that's why, for example, for 2 bodies having the same density and the same material means density and specific heat same mega. That's why Q value is directly proportional to R cube. The amount of the heat Q value is directly proportional to R cube. That is the question is given on the previous year. That question is given on the previous year, Q directly proportional to R cube. I will explain that model. Now another model. 2 bodies, like 2 liquids. One is the hot liquid, other one is cold liquid. One is the high temperature liquid and another one is the low temperature liquid, whose masses are M1, M2. Specific heats are S1, S2. Temperatures are theta 1, theta 2. Now they are mixed. What is the common temperature? These 2 are mixed, we get the common temperature is theta. So what is the principle of the calorimetry, Heat loss by the hot body is equal to heat gain by the cold body. That is known as the principle of calorimetry. Okay, like what is this one? Heat. What is the expression of the heat, ms delta theta? M, yes, delta theta, high temperature, theta 1 minus theta. Here, M, yes, delta theta, theta minus theta 2. This is the very, very important formula. So, in this one, theta value, we can find them. That is the lengthy formula is there, that formula is no need, but equating the heat loss by the cold body, heat gain by the cold body. One high temperature and one low temperature, both are mixed together, we get the temperature value, high temperature comparison with high low value. Comparison with low value high. So, hot body slightly heat is loss, cold body slightly heat is gain. How much heat is loss, This body, the how much heat is gain, amma, that one is loss. So heat loss is equal to heat gain. That is known as a principle of calorimetry. Amma, in calorimetry, only given on the previous year direct models. These two are the direct points, amma. Now we can explain that examples, amma, just. Now, what is that question, amma? Now listen carefully. In 2020, the quantities of the heat required to rise the temperature of two solid copper spheres. Both are two solid copper spheres. Two solid copper spheres. That means both are copper spheres ga, and density value, specific heat value both are same ga, right? But whose radius values are relation is given. R1 is equal to 1.5, R2 values are given. By the rise of the temperature 1 Kelvin, what is the heat required? By the rise of the temperature, Q1 by Q2 value is how much? For the both are raised by 1 Kelvin. What is that? Already we know that the amount of the heat required to rise the temperature of 1 gram of the substance through 1 degree centigrade or 1 Kelvin, both are same. That is the amount of the heat is known as specific heat. So Q is equal to ms delta theta. Mass value 4/3 pi r cube into density s delta theta. Both are copper spheres, both are same. Both are raised by 1 Kelvin, delta theta value same, 4/3 pi value same, and like Q is directly proportional to R cube. Like Q1 by Q2 is equal to R1 by R2 whole cube. What is the value of R1 by R2? 1.5 and 15 by 10, like 3 by 2 whole cube, 27 by 8. 27 by 8. That is the given on the previous year question. Now one more question is there, amma. On 2016 question. On 2016 question. Two identical bodies are made of the material for specific heat values increases with the temperature. Now listen given amma. Heat capacity is increases with the temperature. Generally heat capacity value is increases with the temperature, amma. But one body is at 100 degrees centigrade, another body is at 0. This one is the hot body, this one is the cold body. This one at 100 degrees centigrade, this one 0 degrees centigrade. They are brought in contact. There is no heat loss by the surroundings. What is the common temperature? What is the common temperature? First option, 50 degrees centigrade to greater than 50. This one less than 50. And the fourth one is the given the 0. This type of the options is given, amma. Important model. How to solve that one, amma? Heat capacity is increases with the temperature, amma. Now listen, amma. This one hot body ga, that one cold body ga. Heat loss is equal to heat gain ga. Heat loss is equal to heat gain. What is the heat loss? Ms delta theta ne gada. This one ms. This is the hot body, and like H means hot body. Delta theta 100 minus theta. That is equal to heat loss ms cold body, and like C. This one theta minus 0. Okay, like ms of hot body by ms of cold body is how much, amma? This one the only theta minus 0 like theta nega. This value name 100 minus theta. Cross multiply them. ms of h 100 minus theta. ms of into theta. But in the question one of the important point is heat capacity is increases with the temperature ga. And which one is the high temperature like this one ga? This one name low ga, cold body kada. Which one having the more heat capacity ra? High temperature of the body. And this value is more ga. This value is more than that of this one. And the compulsory ga ms of h value is greater than ms of cold ga. Like ms of h by ms of cold value greater than 1 ga. Like greater than 1. Cross multiply them theta value 100 minus theta. This minus theta value take them here 2 theta. Therefore theta value how much greater than 50. So that theta value is greater than 50. Now answer is nothing but greater than 50. Okay, simple model but given the one logic point is nothing but heat capacity is increases with the temperature. So heat capacity is increases with the temperature. So high temperature of this heat capacity is more than that of cold. So this value is more gamma, take them this denominator value greater than 1 ga. But here msh by ms of cold body is greater than 1 ga. Like this value both are same ga. Denominator value take them this side. That's why 2 theta value greater than 100. Therefore theta value greater than 50 degrees centigrade. So this is the another important model. So these all are the previous questions like. Okay namma. As final gara thermal properties of the matter concept completed amma. Only thermal properties of matter only one concept I am explaining amma. So many concepts are there. So that's why a simple topic amma. So our next class is nothing but on tomorrow paper discussion we can continue. Thank you.
Hello all. Today is the second day for coordination compounds. So I'm going to discuss the rest of the models based on coordination compounds today. Also today is the last day of these lectures, and tomorrow onwards there will be only paper explanation for each grand test that is going to be conducted. The first grand test commences on Monday, and tomorrow is like just a revision test on all the chapters. Those have been taught this week. So it's going to be, the paper explanation will be also held tomorrow, but from the day after tomorrow grand tests will be conducted, and all the grand test papers have been very carefully done with questions which actually set appropriately the NEET criteria. Therefore, I want everybody to take these tests very seriously, download the paper and then solve questions from 8:40 to 11:40 every day, and following which there will be paper explanation. Attend the class and get your doubts clarified. Use this program to the utmost extent possible for the best scores that you can secure in the upcoming test. Anyway, here it is. The first question that I am going to talk about is, which of the following is a correct order of field strength of ligands? It's from the spectrochemical series. We are given the set of ligands here. We have a thiocyanate ligand, a fluoride ligand, oxalate ligand, fluoride, and then we are also given cyanide. So among all of these, if you consider, the cyanide ligand is actually the strongest, you all know, followed by the oxalate ligand you have, followed by the fluoride ligand, and then thiocyanate. Learning the spectrochemical series, the entire series, is very, very important, because the questions keep coming very frequently in all kinds of competitive examinations on spectrochemical series. If you learn the series by heart, and this is what we have this. Let's go ahead with the next important thing. The next question is, we have to write the electronic configuration in the crystal field splitting for the complex K4 FeCN 6 times. So we are given a complex called K4 FeCN 6 times. We'll start with the oxidation state of the metal, the central metal. The central metal has an oxidation state +2, where we have configuration 3d6. And then when we consider this term 3d6 configuration, what we are supposed to understand is, the cyanide ligands here would actually rearrange the unpaired electrons present. As a result, the T2G and EG sets are to be arranged this way, because it's an octahedral complex. T2G falls down and EG comes up, whereas the 6 electrons have to be accommodated in T2G orbitals completely according to the Hund's rule, and therefore we have 1, 2, 3, 4, 5, 6. So this is what we get. So this is also according to Hund's rule, Pauli's exclusion principle, Aufbau principle. What goes against Aufbau principle is, in case of a weak field, the electrons, after singly occupying each orbital, the next electron, the electron that has to be paired up, will be actually accommodated here. As a result, we can say in weak field cases, this principle called Aufbau principle is violated, where instead of completing the lower energy orbitals, we are also simultaneously accommodating electrons in higher energy orbitals. So this one principle is violated, but rest of the principles called Hund's rule and Pauli's exclusion principle are definitely
followed in arranging electrons in this particular T2G kind of octahedral crystal field splitting arrangement. Let's go ahead with the next part. So, the correct answer for this question is T2G6 EG0. Moving on to the next question. Here the question is given as wavelengths of absorption. The correct order of wavelengths of absorption in cobalt +3 complexes. CO H2O 6 times +3, CO En thrice +3, CO NH3 6 times +3. These are the 3 complexes given to us. We have to arrange them in the increasing order of absorption of wavelength. First, we will arrange them in the increasing order of crystal field stabilization energy. Higher is the field strength, higher is the crystal field stabilization energy. The highest field strength is offered by the En ligand here. As a result, we will go with En first. So, CO En thrice +3 greater than, next falls CO NH3 6 times +3 followed by CO H2O 6 times +3 is what we have here. In this order, we only find a proper order of CFSE. But we all know energy is inversely proportional to the wavelength. So, the order of wavelength absorption, when we consider increasing order of wavelength absorption, we have to reverse this and understand, which means when we consider the wavelength order, CO En thrice +3, CO NH3 6 times +3, CO H2O 6 times +3 is what we get. Let's move to the next question. The next question speaks about identifying the longest CO bond length, which has the longest CO bond length. When we consider this part, we have these complexes given. FeCO4 -2, MnCO 6 times plus, NiCO4, CO4 minus. These are the 4 things that we have here. What we are trying to understand next is, we have FeCO4 -2, MnCO plus, NiCO4 times, CO 4 times. Nanen helta idini illi, we first understand the characteristics of metal carbonyl bond. ಈ ಮೆಟಲ್ ಕಾರ್ಬನಿಲ್ ಬಾಂಡ್ನಲ್ಲಿ ಇನಿಷಿಯಲಿ ಕಾರ್ಬನ್ ಯಾವಾಗ ಮೆಟಲ್ಗೆ ಡೊನೇಟ್ ಮಾಡುತ್ತೆ ಅದು ಸಿಗ್ಮಾ ಬಾಂಡ್. ಬಟ್ ಯಾವಾಗ ಮೆಟಲ್ ತನ್ನ ಎಲೆಕ್ಟ್ರಾನ್ಸನ್ನು ಕಾರ್ಬನ್ಗೆ ಡೊನೇಟ್ ಮಾಡುತ್ತೆ ಅದು ಆವಾಗ ಪೈ ಬಾಂಡ್. ಸೊ ಈ ಬಾಂಡ್ ಎಷ್ಟು ಸ್ಟ್ರಾಂಗ್ ಆಗಿರುತ್ತೆ ಮೆಟಲ್ ಕಾರ್ಬನ್ ಬಾಂಡ್ ಅಷ್ಟು ವೀಕ್ ಬಾಂಡ್ ಇದಾಗುತ್ತೆ. ದೇರ್ಫೋರ್ ಹೈಯರ್ ಇಸ್ ದ strength of higher is the strength of MC bond, lower is the strength of CO bond. This is what we need to consider. So when I consider this thing, ಇದು ಎಲ್ಲಿ ಯಾವಾಗ ಇದು ಸ್ಟ್ರಾಂಗರ್ ಆಗುತ್ತೆ ಅಂತಂದರೆ ಇದು ಯಾವಾಗ ಜಾಸ್ತಿ ಬೇಗ ಅಥವಾ ಹೈಯೆಸ್ಟ್ ಅಟೆನ್ಷನ್ದಿಂದ ಎಲೆಕ್ಟ್ರಾನ್ಸನ್ನು ಕಾರ್ಬನ್ಗೆ ಡೊನೇಟ್ ಮಾಡುತ್ತೆ, ಆವಾಗ ಎಮ್ ಸಿ ಬಾಂಡ್ ಅನ್ನೋದು ತುಂಬ ಸ್ಟ್ರಾಂಗ್ ಆಗುತ್ತೆ. ಸೊ ಐ ನೀಡ್ ಟು ಸೇ ದ ಸ್ಟ್ರೆಂಗ್ತ್ ಆಫ್ ಎಮ್ ಸಿ ಬಾಂಡ್ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆಫ್ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ on the metal is directly proportional to strength of MC bond. ಎಷ್ಟು ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಇದ್ದರೆ ಅಷ್ಟು ಚೆನ್ನಾಗಿ ಎಲೆಕ್ಟ್ರಾನ್ಸನ್ನು ಡೊನೇಟ್ ಮಾಡಲಿಕ್ಕೆ ಆಗುತ್ತೆ, ಬಿಕಾಸ್ ಮೆಟಲ್ ಇಸ್ ಅ ಡೋನಾರ್ ಹಿಯರ್. ಇಲ್ಲಿ ಮೆಟಲಿನ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಐರನ್ -2, ಇಲ್ಲಿ ಮೆಟಲಿನ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ Mn+, ನಿಕೆಲಿನ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ 0, ಕೊಬಾಲ್ಟಿನ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ -1. ಇದರಲ್ಲಿ ಹೈಯೆಸ್ಟ್ ಡೋನಾರ್ ಆಗುವಂತಹ ಕ್ಯಾರೆಕ್ಟರ್ ಯಾರಿಗಿದೆ ಅಂತ ಅಂದರೆ ಬೆಸ್ಟ್ ಡೋನಾರ್ ಐರನ್ +2, ಬಿಕಾಸ್ ಇಟ್ ಬ್ಯಾರ್ಸ್ ಅ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್. ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಎಷ್ಟು ಜಾಸ್ತಿ ಇದ್ದರೆ ಅಷ್ಟು ಸ್ಟ್ರೆಂಗ್ತ್ ಆಫ್ ಎಮ್ ಸಿ ಬಾಂಡ್ ಬರುತ್ತೆ. ಅದು ಎಮ್ ಸಿ ಬಾಂಡ್ ಎಷ್ಟು ಸ್ಟ್ರಾಂಗ್ ಇದ್ದರೆ ಅಷ್ಟು ಕಮ್ಮಿ ಸ್ಟ್ರೆಂಗ್ತ್ ಸಿ ಒ ಬಾಂಡ್ಗಿರುತ್ತೆ. ಸ್ಟ್ರೆಂಗ್ತ್ ಕಮ್ಮಿ ಅಂದರೆ ಬಾಂಡ್ ಲೆಂಗ್ತ್ ಜಾಸ್ತಿ. ಹಾಗಾಗಿ ಆನ್ಸರ್ ಇಸ್ ಆಪ್ಷನ್ ನಂಬರ್ 1. ಈ ತರಹ ನಾವು ಇದನ್ನು ಸಾಲ್ವ್ ಮಾಡಬೇಕು. ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್. Which of the following sequences of hybridization, geometry, magnetic nature are correct? So here we have certain options given, certain set of complexes given. A, nickel tetrachloride, sp3 tetrahedral paramagnetic when we consider this, what we need to understand is in nickel tetrachloride sp3 nalli ನಿಕೆಲ್ ಟೆಟ್ರಾಕ್ಲೋರೈಡ್ನಲ್ಲಿ ನಿಕೆಲಿಂದು ಪಾಸಿಟಿವ್ +2 ಚಾರ್ಜ್, ಕಾನ್ಫಿಗರೇಷನ್ 3D8. ಈ 3D8 ಕಾನ್ಫಿಗರೇಷನ್ನಲ್ಲಿ ಇದು ರಿಅರೇಂಜ್ಮೆಂಟ್ ಮಾಡಲ್ಲ. ಇದು ರಿಅರೇಂಜ್ಮೆಂಟ್ ಮಾಡಲ್ಲ ಅಂತ ಅಂದರೆ ಇಲ್ಲಿ ರಿಅರೇಂಜ್ಮೆಂಟ್ ಆಗಲಿಕ್ಕೆ ಅವಕಾಶ ಇಲ್ಲ. ದೇರ್ಫೋರ್ ಇದು ಖಾಲಿ ಇಲ್ಲ, ಡಿ ಖಾಲಿ ಇಲ್ಲ. ಸೊ sp3 ಯೂಸ್ ಮಾಡ್ಕೋಬೇಕು. ಸೊ ಹೈಬ್ರಿಡೈಸೇಷನ್ ಇಸ್ sp3 tetrahedral paramagnetic because unpaired electrons are there. So everything is correct. B, NiNH3 6 times +2 sp3d2 octahedral paramagnetic. ಇದನ್ನು ಅಬ್ಸರ್ವ್ ಮಾಡಿದಾಗ ಈ ಕಾಂಪ್ಲೆಕ್ಸ್ಗೆ ನಿಕೆಲ್ಗೆ +2 ಚಾರ್ಜ್ ಇದೆ, 3D8 ಕಾನ್ಫಿಗರೇಷನ್. ಅಮೋನಿಯಾ ಇನ್ ಕೇಸ್ ಆಫ್ ನಿಕೆಲ್ +2 ಆಕ್ಟ್ಸ್ ಆಸ್ ಅ ವೀಕ್ ಫೀಲ್ಡ್ ಲಿಗ್ಯಾಂಡ್. ಅಮೋನಿಯಾ ನಿಕೆಲ್ +2 ಕೇಸ್ನಲ್ಲಿ ಇದು ವೀಕ್ ಫೀಲ್ಡ್ ಲಿಗ್ಯಾಂಡ್ ಆಗಿ ಆ್ಯಕ್ಟ್ ಆಗುತ್ತೆ. ಇದು ನೀವು ತಿಳ್ಕೋಬೇಕು. ಏನದು? ನಮಗೆ I- Br- SCN- ಈ ತರಹ ಈ ಲಿಗ್ಯಾಂಡ್ಸ್ ಎಲ್ಲ ತಗೊಂಡು ವಿ ರೀಚ್ ಅಪ್ ಟು ವಾಟರ್. ವಾಟರ್, ಆಕ್ಸಲೇಟ್, ಆಮೇಲೆ ಅಮೋನಿಯಾ, ಇಲ್ಲಿವರೆಗೂ ಕೂಡ ಈ 3 ಲಿಗ್ಯಾಂಡ್ಸ್. ಆಮೇಲೆ ಮತ್ತೆ ನಮಗೆ ಬರೋದು EN, ಅನಂತರ CN ಮೈನಸ್ CO ಇವೆಲ್ಲ ಬರ್ತವೆ. ಅಂದರೆ ನಾನು ಸ್ಪೆಕ್ಟ್ರೋಕೆಮಿಕಲ್ ಸೀರೀಸ್ನಲ್ಲಿ ಇವು ಲೋವರ್ ರೇಂಜ್ ಲಿಗ್ಯಾಂಡ್ಸ್, ಅವು ಹೈಯರ್ ರೇಂಜ್ ಲಿಗ್ಯಾಂಡ್ಸ್, ಅವು ಹೈಯರ್ CFS ಇವು ಲೋವರ್ CFS ಇವು ಯಾವಾಗಲೂ ವೀಕೆ, ಅವು ಯಾವಾಗಲೂ ಸ್ಟ್ರಾಂಗೆ. ಬಟ್ ಮಧ್ಯದಲ್ಲಿರುವ ಲಿಗ್ಯಾಂಡ್ಸ್ ಏನದಾವೆ, ಅಮೋನಿಯಾ ಮತ್ತು ಆಕ್ಸಲೇಟ್ ಮತ್ತು ವಾಟರ್, ಈ 3 ಲಿಗ್ಯಾಂಡ್ಸ್, ಎಸ್ಪೆಷಲಿ ಈ 3 ಲಿಗ್ಯಾಂಡ್ಸ್, ದೇ ಆರ್ ಇನ್ ದ ಮಿಡಲ್ ಝೋನ್. ದೇ ಆರ್ ನೀದರ್ ಟು ಸ್ಟ್ರಾಂಗ್ ಟು ನಾಟ್ ಟು ವೀಕ್. ಇವೇನು ಮಾಡ್ತವೆ, ಕೆಲವು ಸ್ಪೀಷೀಸ್ನಲ್ಲಿ, ಕೆಲವು ಚಾರ್ಜಸ್ನಲ್ಲಿ, ಎಸ್ಪೆಷಲಿ ಲೋವರ್ ಚಾರ್ಜಸ್ನಲ್ಲಿ, sometimes they act as weak field ligands. And when it is actually a higher charge, they start acting as a strong field ligand. ಅದಕ್ಕೆ CO+3 ಕೇಸ್ನಲ್ಲಿ ಆಕ್ಸಲೇಟನ್ನು ಸ್ಟ್ರಾಂಗ್ ಫೀಲ್ಡ್ ಲಿಗ್ಯಾಂಡ್ ಅಂತೀವಿ. ನಿಕೆಲ್ +2 ಕೇಸ್ನಲ್ಲಿ ಅಮೋನಿಯಾ ಅನ್ನು ವೀಕ್ ಫೀಲ್ಡ್ ಲಿಗ್ಯಾಂಡ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಇದಿಷ್ಟು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಸೊ ನಾನೇನು ಹೇಳ್ತಾ ಇದ್ದೀನಿ ಇಲ್ಲಿ, ನಿಕೆಲ್ +2 3D8 ಅಮೋನಿಯಾ, ಇಟ್ಸ್ ಅ ವೀಕ್ ಫೀಲ್ಡ್ ಲಿಗ್ಯಾಂಡ್. ವೀಕ್ ಫೀಲ್ಡ್ ಲಿಗ್ಯಾಂಡ್ ಇದ್ದರೆ ನಮಗೆ 3D8 ಕಾನ್ಫಿಗರೇಷನ್ ಇಷ್ಟು ಬರುತ್ತೆ, ರಿಅರೇಂಜ್ ಮಾಡಲಿಕ್ಕೆ ಅವಕಾಶ ಇರಲ್ಲ. ಸೊ sp3d2ಗೆ ಹೋಗಬೇಕಾಗತ್ತೆ. ಅಂದರೆ ಹೈಬ್ರಿಡೈಸೇಷನ್ sp3d2, ಆಕ್ಟಾಹೈಡ್ರಲ್ ಕರೆಕ್ಟ್, ಅನ್ಪೇಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಹಾಗೆ ಇರ್ತವೆ, ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್, ಇದು ಕರೆಕ್ಟ್. ನೆಕ್ಸ್ಟ್ ತಗೊಳ್ಳೋಣ, ನಿಕೆಲ್ ಟೆಟ್ರಾ ಕಾರ್ಬೋನಿಲ್. sp3 ಟೆಟ್ರಾಹೈಡ್ರಲ್ ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್. ನಿಕೆಲ್ನಲ್ಲಿ ಚಾರ್ಜ್ 0, ಈ ಕಾಂಪ್ಲೆಕ್ಸ್ನಲ್ಲಿ ನಿಕೆಲ್ಗೆ 0, 4s2 3d8. ಇದು ಸ್ಟ್ರಾಂಗ್ ಫೀಲ್ಡ್ ಲಿಗ್ಯಾಂಡ್, ರಿಅರೇಂಜ್ಮೆಂಟ್ ಖಂಡಿತ ಆಗತ್ತೆ. 3d10 ಅಂದರೆ S ಖಾಲಿ ಆಯಿತು, 4p ಕೂಡ ಖಾಲಿ, 4 ಬೇಕು, sp3 ಹೈಬ್ರಿಡೈಸೇಷನ್ ಆಗುತ್ತೆ. sp3 ಹೈಬ್ರಿಡೈಸೇಷನ್ ಆಗಿದೆ, ಟೆಟ್ರಾಹೈಡ್ರಲ್ ಶೇಪನ್ನು ಹೊಂದಿದೆ. ಇದು ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಅಲ್ಲ, ಇಟ್ ಈಸ್ ಡಯಾಮ್ಯಾಗ್ನೆಟಿಕ್. ಯಾಕಂದರೆ ರಿಅರೇಂಜ್ಮೆಂಟ್ ಆಯಿತು, 10 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅದಾವೆ, ಅಂದರೆ ಎಲ್ಲ ತುಂಬಿದಾವೆ. ಸೊ ಇಟ್ ಈಸ್ ಡಯಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಇನ್ ನೇಚರ್. ಡಿ, ನಿಕೆಲ್ ಟೆಟ್ರಾಸಯನೈಡ್. DsP2 ಸ್ಕ್ವೇರ್ ಪ್ಲೇನಾರ್ ಡಯಾಮ್ಯಾಗ್ನೆಟಿಕ್. ಇದರಲ್ಲಿ ನಿಕೆಲ್ +2 ಚಾರ್ಜನ್ನು ಹೊಂದಿದೆ. ನಿಕೆಲ್ +2 ಚಾರ್ಜನ್ನು ಹೊಂದಿದರೆ 4s0 3d8 ಕಾನ್ಫಿಗರೇಷನ್. ಇದು ಖಂಡಿತ ಇಟ್ ಈಸ್ ಅ ಸ್ಟ್ರಾಂಗ್ ಫೀಲ್ಡ್ ಲಿಗ್ಯಾಂಡ್. ಸೊ ರಿಅರೇಂಜ್ಮೆಂಟ್ ಆಗೇ ಆಗುತ್ತೆ. 8 ಹಿಂಗಿದ್ವಾ, 8 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಈ ಥರ ಇದ್ವಾ, ಈ ಒಂದು ಇಲ್ಲಿಗೆ ಹೋಗಿ ರಿಅರೇಂಜ್ ಆಗುತ್ತೆ. ಸೊ ಡಿ ಖಾಲಿ. ಸೊ DsP2 ಹೈಬ್ರಿಡೈಸೇಷನ್ ಅನ್ನು ಪಡೆಯುತ್ತೆ. ಇದು ಅರ್ಥ ಮಾಡಿಕೋಬೇಕು. ಲೆಟ್ಸ್ ಗೋ ಟು ದ ನೆಕ್ಸ್ಟ್ ಪಾರ್ಟ್. ಇದು ಡಿ. ಓಕೆ, ಈಗ ಡಯಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಅಂದರೆ ಡಯಾಮ್ಯಾಗ್ನೆಟಿಕ್. ಸೊ ಈ 4ರಲ್ಲಿ ಯಾವುದು ಕರೆಕ್ಟ್? ಎ, ಬಿ, ಡಿ ಕರೆಕ್ಟ್, ಸಿ ತಪ್ಪು. ಸಿ ಕೂಡ 2 ಕರೆಕ್ಟ್, ಅದು ತಪ್ಪು. ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್ಗೆ ಹೋಗೋಣ. Electronic configuration of tetrahedral metal ion. D2, D4, D6, D8. Crystal field splitting energy. Tetrahedral. Minus 0.6, minus 0.8, minus 1.2, minus 0.4. ಇವು ನಮಗೆ ಕಾಂಪ್ಲೆಕ್ಸಸ್. ಈ ಸಿ ಎಫ್ ಎಸ್ ಸಿ ವ್ಯಾಲ್ಯೂಸ್ ಇವು ಮ್ಯಾಚ್ ಮಾಡಬೇಕು. ಮ್ಯಾಚ್ ಮಾಡಬೇಕಂದ್ರೆ ಇದು T2. T2ನಲ್ಲಿ ಕೆಳಗೆ 2, ಮೇಲೆ 3. ಈ ಮೇಲಕ್ಕೆ ಹೋಗಿದ್ದು ಮೈನಸ್ 2/5 ಡೆಲ್ಟಾ ಟಿ. ಈ ಕೆಳಗೆ ಬಂದಿದ್ದು ಇದು ಪ್ಲಸ್, ಇದು ಮೈನಸ್ 3/5 ಡೆಲ್ಟಾ ಟಿ. ಇದು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಸೊ ಇದರಿಗೋಸ್ಕರ ಫಸ್ಟ್ D2 ಕಾನ್ಫಿಗರೇಷನ್ ತಗೊಳ್ಳೋಣ. D2 ಕಾನ್ಫಿಗರೇಷನ್ ಅಂದರೆ ಇಲ್ಲಿ. ಸೊ ಇದು ಮೈನಸ್ 3/5 ಅಂದರೆ ಮೈನಸ್ 0.6 ಇಂಟು 2 ಅಂದರೆ ಮೈನಸ್ 1.2. D4 ತಗೊಳ್ಳೋಣ. D4 ತಗೊಂಡ್ರೆ ಟೆಟ್ರಾಹೈಡ್ರಲ್ನಲ್ಲಿ ಪೈರಿಂಗ್ಗೆ ಅವಕಾಶ ಬಹಳ ಕಮ್ಮಿ. ಟೆಟ್ರಾಹೈಡ್ರಲ್ನಲ್ಲಿ ಮೋಸ್ಟ್ ಆಫ್ ದ ಕಾಂಪ್ಲೆಕ್ಸಸ್ ಆರ್ ಹೈ ಸ್ಪಿನ್. ಯಾಕೆಂದರೆ 4 ಲಿಗ್ಯಾಂಡ್ಸ್ ಇರ್ತವೆ, ಪೈರಿಂಗ್ ಅಪ್ ಕಷ್ಟ ಆಗುತ್ತೆ. ಸೊ 6 ಲಿಗ್ಯಾಂಡ್ಸ್ ಇದ್ದಾಗ ರಿಪಲ್ಷನ್ಸ್ ಜಾಸ್ತಿ, ಪೈರಿಂಗ್ ಅಪ್ ಫಾಸ್ಟ್ ಆಗುತ್ತೆ. 4 ಲಿಗ್ಯಾಂಡ್ಸ್ ಇದ್ದಾಗ ಅದು ಕಷ್ಟ ಆಗುತ್ತೆ. ಸೊ ಅದಕ್ಕೆ ಇವಾಗ 1 2 ಬರೆದು 3 4 ಇಲ್ಲಿ ಬರೀಬೇಕು. ಸೊ ಇದರಿಂದ ಬಂದಿದ್ದ ಎರಡದ್ದು ಕೂಡ ಮೈನಸ್ 0.6 ಇಂಟು 2 ಪ್ಲಸ್ 2 ಇಂಟು ಮೈನಸ್ ಇದು ಪ್ಲಸ್ 0.4 ಡೆಲ್ಟಾ ಟಿ. ಸೊ ಪ್ಲಸ್ 0.4 ಅಂದರೆ ಮೈನಸ್ 1.2, 0.8 ವಿಚ್ ಇಸ್ ಮೈನಸ್ 0.4. ಸೊ D2ದು ಇದು, D4ದು ಇದು. D6ಗೆ ಹೋಗೋಣ. D6 ಅಂದರೆ 1 2 3 4 5 6 ಈ ಥರ ತುಂಬಬೇಕು. 1 2 3 4 5 6 ತುಂಬಿದ್ದಾಗ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಯಾವ ಥರ? 3 ಇಂಟು ಮೈನಸ್ 0.6 ಪ್ಲಸ್ 3 ಇಂಟು 0.4 minus 1.2 plus 1.2, 8, this is 8, that is 0.6. So we get this D8. D8 ಯಾವ ಥರ ತುಂಬಬೇಕು? ಮತ್ತೆ ಅಗೇನ್ ಸೇಮ್ 1 2 3 4 5 ಸಾರಿ 1 2 3 4 5 6 7 8 ಈ ಥರ ತುಂಬಿದಾಗ 4 ಇಂಟು ಮೈನಸ್ 0.6 ಪ್ಲಸ್ ಇದು ಒಂದು 4 ಇಂಟು ಪ್ಲಸ್ 0.4 minus 2.4 plus 1.6. So that results out to be minus 0.8, which is this one. This is how we match the two in delta T tetrahedral complexes. Filling ಇನ್ನೊಂದ್ಸಲ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. ಡೆಲ್ಟಾ ಟಿನಲ್ಲಿ ಲೋವರ್ ಆಗಿದ್ದು ಮೈನಸ್ 3/5 ಯೂನಿಟ್ಸ್, ಹೈಯರ್ ಆಗಿದ್ದು 2/5 ಯೂನಿಟ್ಸ್. ಮೈನಸ್ 3/5 ಅಂದರೆ ಮೈನಸ್ 0.6, ಹೈಯರ್ ಆಗಿದ್ದು 2/5 ಯೂನಿಟ್ಸ್ ಅಂದರೆ 0.4 ಯೂನಿಟ್ಸ್. ಇದು ಫಸ್ಟ್ ನೆನಪಿಟ್ಕೋಬೇಕು. ಆಮೇಲೆ ಈ ಹೈ ಸ್ಪಿನ್ ಲೋ ಸ್ಪಿನ್ ಅಂತ ಎರಡು ತಗೋಬಾರ್ದು, ಯಾವಾಗಲೂ ಹೈ ಸ್ಪಿನ್ನೇ ತಗೋಬೇಕು. ಯಾಕಂದರೆ 6 ಲಿಗ್ಯಾಂಡ್ಸ್ ಇದ್ದಾಗ ರಿಪಲ್ಷನ್ಸ್ ಬಂದು ರಿಅರೇಂಜ್ ಆಗ್ಬೋದು, 4 ಲಿಗ್ಯಾಂಡ್ಸ್ ಇದ್ದಾಗ ರಿಅರೇಂಜ್ಮೆಂಟ್ ಅನ್ನೋದು ಕಮ್ಮಿ. ದೇರ್ ಫೋರ್ ಆಲ್ಮೋಸ್ಟ್ ಮೆನಿ ಕಾಂಪ್ಲೆಕ್ಸಸ್ ಇನ್ tetrahedral complexes become actually high spin complexes because the value of delta T is very low when compared to delta O. In case of delta O, there is always a chance for pairing if the ligand is a strong field ligand. ಸೊ ಹೈ ಸ್ಪಿನ್ ತುಂಬೋದಾಗ 2 ತುಂಬಬೇಕಂದ್ರೆ ಇಲ್ಲಿ ಬರೀಬೇಕು ಫಸ್ಟ್, 4 ಬರೀಬೇಕಂದ್ರೆ 2 ಇಲ್ಲಿ ಮೇಲೆ 2, ಯಾಕಂದರೆ ಇಲ್ಲಿ ಪೇರಿಂಗ್ ಅಪ್ ಮಾಡೋಂಗಿಲ್ಲ. ಹೈ ಸ್ಪಿನ್ ಆದ್ರೇ ಲೋ ಸ್ಪಿನ್ ಆದ್ರೇ ಪೇರಿಂಗ್ ಅಪ್, ಅಂದರೆ ಸ್ಟ್ರಾಂಗ್ ಫೀಲ್ಡ್ ಇದ್ರೆ ಮಾತ್ರ. ಬಟ್ ಈಗ ಸದ್ಯಕ್ಕೆ ಅದು ಸ್ಟ್ರಾಂಗ್ ಫೀಲ್ಡ್ ವೀಕ್ ಫೀಲ್ಡ್ ಅದು ಏನೇ ಆದರೂ ಕೂಡ ಟೆಟ್ರಾಹೈಡ್ರಲ್ನಲ್ಲಿ ಫಸ್ಟ್ ಸಿಂಗಲ್ ಆಗಿ ಎಲ್ಲ ತುಂಬಿದ ಮೇಲೆ ಪೇರಿಂಗ್ ಅಪ್ ಮಾಡ್ಕೋಬೇಕು. ಅದರ ಪ್ರಕಾರನೇ ಉಳಿದಿದ್ದು ಕೂಡ ಮಾಡಿದರೆ ಈ ಥರ ಬರುತ್ತೆ. ಇದು ಇಂಪಾರ್ಟೆಂಟ್ ಥಿಂಗ್. ಲೆಟ್ಸ್ ಗೋ ಟು ದ ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್. ಇವಾಗ ಕೆಲವು ಸ್ಟೇಟ್ಮೆಂಟ್ಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಅವು ಸ್ಟಡಿ ಮಾಡೋಣ. Identify the correct statement. Fe C2O4 thrice minus 3, statement A, is the most stable among FeOH 6 times minus 3, FeC2O4 thrice minus 3, FeSCN 6 times minus 3. ಈ ಮೂರರಲ್ಲಿ ಈಗ ನಾನು ಅಬ್ಸರ್ವ್ ಮಾಡಿದರೆ ವಾಟ್ ಐ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಇಸ್, ಈ ಮೂರರಲ್ಲಿ ಮೋನೋಡೆಂಡೇಟ್ ಲಿಗ್ಯಾಂಡ್ಸ್ ಅದ, 2ರಲ್ಲಿ ಮೋನೋಡೆಂಡೇಟ್ ಅದಾವೆ, ಇದು ಡೈಡೆಂಡೇಟ್. ಡೈಡೆಂಡೇಟ್ ಲಿಗ್ಯಾಂಡ್ಸ್ ಅಂದರೆ ಕೀಲೇಟಿಂಗ್ ಲಿಗ್ಯಾಂಡ್ಸ್, ಕೀಲೇಟಿಂಗ್ ಲಿಗ್ಯಾಂಡ್ಸ್ ಅಂದರೆ ಸ್ಟೆಬಿಲಿಟಿ. ದೇರ್ ಫೋರ್ ದ ಫಸ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಈಸ್ ಟ್ರೂ. ಬಿಗೆ ಹೋಗೋಣ. ದ ಸ್ಟೆಬಿಲಿಟಿ ಆಫ್ Cu NH3 4 times plus 2 is greater than that of Cu En twice plus 2. ಇದು ತಗೊಳ್ಳೋಣ. ಸೊ ವೆನ್ ವಿ ಕನ್ಸಿಡರ್ ದಿಸ್, ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಕಾಂಪ್ಲೆಕ್ಸನ್ನು ನಾವು ತಗೊಂಡಿದ್ದಾಗ CuNH3 4 times plus 2 is greater than that of CuEn twice plus 2 ಅಂದರೆ ಸ್ಟೆಬಿಲಿಟಿ. ಬಟ್ ಇದು ಆ್ಯಕ್ಚುಲಿ NH3 ಇದೆ, ಇದರಲ್ಲಿ En ಇದೆ. ಕೀಲೇಟಿಂಗ್ ಲಿಗ್ಯಾಂಡ್ ಇಸ್ ಬೆಟರ್ ಆಲ್ವೇಸ್ ಫಾರ್ ಸ್ಟೆಬಿಲಿಟಿ. ಎರಡನೇ ವಿಷಯ, NH3ಗಿಂತ ENನೇ ಬೆಟರ್ CFSCಯನ್ನು ಹೊಂದಿದೆ. ಎನಿವೆ ಕಾಪರ್ ಪ್ಲಸ್ಗೆ CFSC ವ್ಯಾಲ್ಯೂಗೆ ಸ್ಟೆಬಿಲಿಟಿಗೆ ಸಂಬಂಧ ಇರಲ್ಲ, ಯಾಕಂದರೆ ಇದು D9 ಕಾನ್ಫಿಗರೇಷನ್. ನಮಗೆ ಸ್ಟೆಬಿಲಿಟಿನೂ CFSC ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನ್ ಇರೋದು D4 to D7 ಮಾತ್ರ. ಮೋರ್ ಓವರ್ ಇಟ್ ಈಸ್ ಅ ಟೆಟ್ರಾಹೈಡ್ರಲ್ ಕಾಂಪ್ಲೆಕ್ಸ್. ಸೊ ಅದಕ್ಕೆ ಕೀಲೇಷನ್ ನೋಡ್ಕೋಬೇಕು. ಇಲ್ಲಿ ಕೀಲೇಷನ್ ಇಲ್ಲ, ಅಲ್ಲಿ ಕೀಲೇಷನ್ ಇದೆ, ಅಂದರೆ ಈ ಸ್ಟೇಟ್ಮೆಂಟ್ ತಪ್ಪಾಗತ್ತೆ. ಸೊ ಇಟ್ಸ್ ಅ ಫಾಲ್ಸ್ ಸ್ಟೇಟ್ಮೆಂಟ್. Fe, the hybridization of Fe in K4 FeCN 6 times is D2sp3. ಇದು. Therefore, when we have this, it is Fe plus 2, 3d6 configuration. So we have D2sp3 configuration. I mean hybridization possible. ಯಾಕೆ ಪಾಸಿಬಲ್ ಅಂದರೆ 5-6 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಕೂಡ ಪೈರಪ್ ಆಗ್ತವೆ. ಪೈರಪ್ ಆದರೆ 3 D2 ಪಾಸಿಬಲ್, sp3 ಅಂದರೆ S1 P3 1 ಪಾಸಿಬಲ್ ಆಗುತ್ತೆ ಇದರಲ್ಲಿ ಕಾನ್ಫಿಗರೇಷನ್, hybridization. Therefore I can say it's a statement which is true. Let's go to D, the statement D. FeNO2 thrice Cl thrice. FeNO2 thrice Cl thrice minus 3 exhibits linkage isomerism. Linkage exhibit ಮಾಡುತ್ತಾ ಮಾಡಲ್ವಾ? NO2 is an ambidentate ligand. So ಖಂಡಿತ ಇದು ಎಕ್ಸಿಬಿಟ್ ಮಾಡೇ ಮಾಡುತ್ತೆ. NO2 ಆಂಬಿಡೆಂಟೆಡ್ ಲಿಗ್ಯಾಂಡ್ ಇದು ಪ್ರತಿಯೊಂದು ಕೂಡ ಲಿಂಕೇಜ್ ಐಸೋಮೆರಿಸಮ್ ಅನ್ನು ಎಕ್ಸಿಬಿಟ್ ಮಾಡುತ್ತೆ. ಅದರ ಜೊತೆಗೆ ಇದು MA3X3 ಫಾರ್ಮ್ಯಾಟ್ನಲ್ಲಿದೆ. ಇಟ್ ಆಲ್ಸೋ ಎಕ್ಸಿಬಿಟ್ಸ್ ಫ್ಯಾಕ್ ಅಂಡ್ ಮರ್ ಐಸೋಮೆರಿಸಮ್ ಅಂದರೆ ಜಿಯೋಮೆಟ್ರಿಕಲ್ ಐಸೋಮೆರಿಸಮ್. But if they give it exhibits cis-trans isomerism, it's a wrong statement. But if they give it exhibits geometrical isomerism, it's a correct statement. If they give FAC and MER also, it is a correct statement. But it is a correct statement for now, so it's a true statement. There is one more. NO2 minus SCN minus are not ambidentate ligands. This is funny, but this is a false statement. So NO2 minus and SCN minus are definitely ambidentate ligands. They can donate through both donor atoms that they are available with. Therefore, it is actually, a wrong statement. So we have A, B is false, A, C and D are the correct statements. Again, looks like we have a set of statements to discuss. The metal carbon bond the metal and carbon bond in metal carbonyls has both sigma and pi character, and it is a correct statement. We know that metal donates electrons and also the ligand donates electrons in metal carbonyls to each other, and carbon monoxide is a pi acceptor ligand. Therefore, yes, that is a correct statement. B, due to synergic interactions, due to synergic bonding interactions, between metal and CO, metal and CO ligand, the metal carbon bond becomes weak. This is a false statement. Why is this a false statement? Because we have metal donating electrons to carbon monoxide and carbon monoxide donating electrons to metal, and as a result of which metal and carbon bond gets stronger, not weaker, and rather the C triple bond O bond becomes weaker. Idu weak agatte, adu strong agatte. So this is a false statement. Next one. The metal carbon sigma bond is formed by donation of lone pair of electrons on the carbonyl carbon into a vacant orbital of metal. And of course that is true. Carbon monoxide nalli carbon nilliruva lone pair enide adanne metal nalliruva one of the empty d orbitals ge donate ಮಾಡುತ್ತೆ. ಹಾಗಾಗಿ sigma bond form ಆಗಿದೆ. Next one. The metal, next statement. So C is true. The metal carbon bond is formed by, the metal carbon pi bond is formed by donation of electrons from filled d orbital 2 of metal 2 pi star orbital of CO. ಇದು ಕೂಡ ಕರೆಕ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟೇ. ಯಾಕಂದರೆ ವಿ ಹ್ಯಾವ್ ಮೆಟಲ್ ಕಾರ್ಬನ್ ಬಾಂಡ್ ಪೈ ಬಾಂಡ್ ಫಾರ್ಮ್ ಮಾಡ್ತಾ ಇದೆ. ಆವಾಗ ಮೆಟಲ್ನಲ್ಲಿ ಆಲ್ರೆಡಿ ತುಂಬಿದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಏನದಾವೆ, ಇದರಲ್ಲಿ ಒಂದು ಪೈರನ್ನು ಈ ಕಾರ್ಬನ್ ಮೊನಾಕ್ಸೈಡ್ನಲ್ಲಿರುವ ಪೈ ಸ್ಟಾರ್ ಎಂಟಿ ಆರ್ಬಿಟಾಲ್ಸ್ಗೆ ಡಂಪ್ ಮಾಡುತ್ತೆ ಮೆಟಲ್. ದೇರ್ಫೋರ್ ವಿ ನೀಡ್ ಟು ಸೇ ಎಸ್ ದಟ್ ಈಸ್ ಟ್ರೂ. ಸೊ ಇವು ಸ್ಟೇಟ್ಮೆಂಟ್ಸ್ ಇಲ್ಲಿ ಇವೆಲ್ಲ ಕೂಡ ಎ ಈಸ್ ಕರೆಕ್ಟ್, ಬಿ ಈಸ್ ಫಾಲ್ಸ್, ಸಿ ಆ್ಯಂಡ್ ಡಿ ಆರ್ ಕರೆಕ್ಟ್ ಅಗೇನ್. ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್. Statement 1. Each electron in Eg orbitals destabilizes the orbitals by 0.6 delta O. And each electron in the T2G orbitals stabilizes the orbitals by minus 0.4 delta O in an octahedral crystal field. To statement. ಈ ಸ್ಟೇಟ್ಮೆಂಟನ್ನು ಈಚ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇನ್ ಇ ಜಿ ಆರ್ಬಿಟಾಲ್ಸ್ ಡಿಸ್ಟೆಬಿಲೈಸಸ್ ದಿ ಆರ್ಬಿಟಾಲ್ಸ್ ಬೈ 0.6 delta O and each electron in the T2G orbital stabilizes the orbitals by minus 0.4 delta O ಅನ್ನೋದು ಸ್ಟೇಟ್ಮೆಂಟ್. ನೀವು ಟೆಟ್ರಾಹೈಡ್ರಲ್ ಆಕ್ಟಾಹೈಡ್ರಲ್ ಕ್ರಿಸ್ಟಲ್ ಫೀಲ್ಡ್ ಸ್ಪ್ಲಿಟ್ಟಿಂಗ್ ತೊಗೊಂಡ್ರೆ ಇಲ್ಲಿ T2G ಬರುತ್ತೆ ಆ್ಯಂಡ್ ಇಲ್ಲಿ ಇ ಜಿ ಬರುತ್ತೆ. ಈ ಸೆಟ್ನಲ್ಲಿ ನಮಗೆ ಈ ಗ್ಯಾಪ್ನಲ್ಲಿ ಇದು ಬಂದುಬಿಟ್ಟು -2/5 ಅಂದರೆ -0.4 delta O, ಇದು +0.6 delta O. ಹಾಗಾಗಿ ಎಸ್, ಇಲ್ಲಿ ಹೋಗಿದ ಪ್ರತಿ ಎಲೆಕ್ಟ್ರಾನ್ ಸ್ಟೆಬಿಲೈಸಸ್ ದೀಸ್ ಆರ್ಬಿಟಾಲ್ಸ್ ಬೈ I mean complex by minus 0.4 delta O, and that destabilizes by 0.6 delta O. Absolutely, this statement when we consider, we have to, each electron in the EG orbitals destabilizes by 0.6 and stabilizes by T2G stabilizes by 0.4. That statement is correct. We will go with the next statement. All the d orbitals of the transition metals have all the d orbitals of the transition metal have same energy in their free atomic state. Absolutely correct. Without the influence of ligands, all the 5 have same energy, and so we call them degenerate orbitals. But we are not done with the statement yet. But when a complex is formed, the ligands destroy the degeneracy of these orbitals on the basis of crystal field theory. This is correct. ಈ 5 ಆರ್ಬಿಟಾಲ್ಸ್ ಕೂಡ ಫಸ್ಟ್ ಫ್ರೀ ಸ್ಟೇಟ್ನಲ್ಲಿ ಹೈಯೆಸ್ಟ್ ಎನರ್ಜಿಯನ್ನು ಹೊಂದಿರ್ತವೆ. ಬಟ್ ಯಾವಾಗ ಈ ಲಿಗ್ಯಾಂಡ್ಸ್ ಬರ್ತವೆ ಆವಾಗ ಇವು ಸ್ಪ್ಲಿಟ್ ಆಗ್ತವೆ ಈ ಥರ. ಸೊ ಇದು ಕರೆಕ್ಟ್, ಡಿಜನರಸಿ ಹೋಯಿತು. ಸೊ ಫಸ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಇಸ್ ಟ್ರೂ, ಸೆಕೆಂಡ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಇಸ್ ಆಲ್ಸೋ ಟ್ರೂ. ಬೋತ್ ಆರ್ ಕರೆಕ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ಸ್. We'll go to the next part. The next question is NiEn thrice plus 2 NiCl4 minus 2. NiNH3 6 times plus 2. ಇವುಗಳಲ್ಲಿ what we need to understand is frequency of absorption ಪ್ರಕಾರ ಅರೇಂಜ್ ಮಾಡಬೇಕು. ನಂಬರ್ ಆಫ್ ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಕೂಡ ಬರೀಬೇಕು. ಇದು ಎ, ಇದು ಬಿ, ಇದು ಸಿ. ಸೊ ಫಸ್ಟ್ ನಂಬರ್ ಆಫ್ ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನೋಡೋಣ. ನಿಕೆಲ್ plus 2. Configuration is 3d8. The filling goes like this, and the number of unpaired electrons is 2 for sure. And here the same nickel plus 2, same 3d8. So we have 1, 2, 3, 4, 5. So when we consider this, it's an octahedral complex, you know. Even if this goes for a pairing here, there is only one d orbital available, so there is no rearrangement possible, even though this is a strong field ligand, since it is a d8 complex. You know, d8, d9, d10 complexes have or behave not differently to the strong field and weak field ligands. Whether you use a strong field ligand or a weak field ligand, the d8, d9, d10, d1, d2, d3 complexes always show the same behavior like I mentioned yesterday. As a result, the number of unpaired electrons would remain same, and there is no rearrangement because there is no use even if there is a rearrangement. Whereas nickel tetrachloride is a tetrahedral complex, therefore we may expect a rearrangement, but the ligand that we have here is a weak field ligand, so no rearrangement, and hence the same unpaired electrons as 2 would remain here too. Whereas in case of ammonia also it is 3d8, and hence we cannot expect ammonia ligand to behave as a strong field ligand here, because even if it behaves like that, there is no use because all the electrons would remain the same way. Even if they rearrange also, you don't get D2 hybridization. There is no opportunity for 2 orbitals to get participated here, and hence it remains the same way, and hence the number of unpaired electrons would remain 2. So D2 ಬರಬೇಕು ಅಂದರೆ rearrangement ಆಗಿದ್ರೂ ಕೂಡ ಒಂದೇ ಆರ್ಬಿಟಾಲ್ ಉಳಿದಿರುತ್ತೆ, ಸೊ ಯೂಸ್ ಇಲ್ಲ ಅದು, ಅದಕ್ಕೆ no rearrangement is possible. So 2, 2, 2 is the first part of the question, and the second part of the question asks to arrange these complexes in the increasing order of frequency of absorption. So that depends on the crystal field stabilization energy. In the spectrochemical series, En plays the highest role. I mean hierarchically A comes first because En is hierarchically first, and then C, and lastly we have B. So this is the correct order according to the question. We'll go to the next question. Here we have statements. The first statement is among zinc, manganese, scandium and copper, the energy required to remove third valence electron is the highest for. They are asking in which one the third ionization energy is the highest for. Is the highest for zinc and lowest for scandium. This is statement 1. Let's analyze this. Zinc has a configuration of 4s2 3d10, manganese has 4s2 3d5, 4s2 3d1 with argon, 4s1 3d10 is a configuration. If you are removing the electrons, removing 2 electrons is fine from all. But the third electron when you remove, it is very, very difficult because 3d10 has the highest exchange energy. It has the highest stability. Therefore, 3d10 you cannot remove electron from. 3d5 stands in the second place. From scandium it is very easy to remove electron because by removing that electron it would attain stability. Whereas copper, when we consider the 3d9 configuration it has, it is difficult. Therefore, 3d10 and 3d5 configurations is what we need to understand here. So we have 3d10 being the highest, scandium having the lowest, as the statement says. It is correct. Let's go ahead with the statement 2. In statement 2, they mention that the correct order of CFSC is. Order of CFSC find out ಮಾಡಬೇಕು. ಅವರೇ ಕೊಟ್ಟಿದ್ದಾರೆ. We have to ascertain it, whether it is true or not we need to verify. CO H2O 6 times plus 2. CO H2O 6 times plus 3. CO En thrice plus 3. Charges nodi first. Higher is the charge, higher is the crystal field splitting energy. So plus 3 stands first. Then in spectrochemical series we have En standing first. So En goes first there. En and then water, and then water. Therefore plus 2 ide idralli, so kammi bande barutte. Plus 3 idu first barkobeku, plus 2 ಆಮೇಲೆ. Plus 3 dalli yes, crystal field splitting energy spectrochemical series prakara En first barutte, so En barutte. So idu correct statement. So both statements are correct. So they gave a few complexes in the next question. We need to find out which one would observe or which one would exhibit the isomerism, especially the coordination isomerism. We'll focus on that. So we are going to find out the species or the complex that exhibits coordination isomerism. The first one is AgNH3 twice AgCN twice A, B, CO NH3 6 times, Cr Cn 6 times, C NH3 6 times, CO 6 times, D, Fe NH3 6 times, CO Cn 6 times, E, CO NH3 6 times, Fe Cn 6 times is what we have here. We need to analyze all of this now. ಇದರಲ್ಲಿ ಅನಲೈಸ್ ಮಾಡಲಿಕ್ಕೆ ಅಬ್ಸರ್ವ್ ಮಾಡಿದರೆ ಇದರಲ್ಲಿ ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ಸ್ ಎರಡು ಒಂದೇ. ಅದಕ್ಕಾಗಿ ಎರಡು ಕೋಆರ್ಡಿನೇಷನ್ ಸ್ಪೇರ್ಸ್ ಇದ್ದರೂ ಕೂಡ ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ ಒಂದೇ ಆಗಿರೋದ್ರಿಂದ ಇದರಲ್ಲಿ ಕೋಆರ್ಡಿನೇಷನ್ ಐಸೋಮೆರಿಸಮ್ ಬರಲ್ಲ. ಇದರಲ್ಲಿ ಬೇರೆ ಬೇರೆ ಅದಾವೆ, ಲಿಗ್ಯಾಂಡ್ಸ್ ಕೂಡ ಬೇರೆ ಬೇರೆ ಅದಾವೆ. ಸೊ ಡೆಫಿನೆಟ್ಲಿ ಎಸ್. But this one when we consider no, because the central metal is again same. Here yes, there is a possibility, and here too, but they are not different. Actually they changed the ligands here, so it's the same, but either way it will be. So B, D and E are the three which will actually exhibit this isomerism. Let's go to the next question. The next question is about the absorption, which we already did, so I'll just skip that and go to the next question. The correct increasing order of spin-only magnetic moments values of complex ions is. Spin-only magnetic moment depends on number of unpaired electrons. So firstly, we need to calculate the number of unpaired electrons in the given set of species. Spin-only magnetic moments is what we have. So the first one, MnBr4 minus 2 Cu H2O 6 times plus 2 Ni Cn 4 times minus 2 Ni H2O 6 times plus 2. A, B, C, D. We need to arrange them according to spin-only magnetic moments. We'll start with manganese first. The charge on manganese is plus 2 The electronic configuration is 3d5 and this Br minus is a weak field ligand, no chance for rearrangement, and hence all the 5 unpaired electrons would remain the same way. So, number of unpaired electrons is 5 and hence the magnetic moment also corresponds to that. So, it should be 5 point something. We will go with the next part, copper. This complex has copper plus 2 with 3d9 configuration. No matter whether the ligand is weak field or strong field, either way D8, D9, D10 complexes have the same number of unpaired electrons as they have always. Therefore, it is 1 unpaired electron. Nickel tetracyanide, when we consider the electronic configuration is 3d8 and it is a tetrahedral complex, and hence there is a possibility for the rearrangement. So, we have unpaired electron, we have no unpaired electron left and hence N equals 0. Whereas a nickel hexa-aqua complex, we have Ni plus 2 with 3d8 configuration, and then we have this 1, 2, 3, 4, 5, 6, 7, 8. And when we consider this here 1, 2, 3, 4, 3D this one, this 8 configuration is, it's a weak field again. So, N equals 2, there is no rearrangement. So, now we have to arrange them in order of this. So, the highest number of unpaired electrons is present in A, followed by D, followed by B, lastly C. And hence we need to say this is the set of complexes arranged in the increasing order of their spin-only magnetic moments. The last question, we will take a look at that. CONH3 6 times plus 3, we call it 1. COH2O 6 times plus 3 is 2. COCN 6 times minus 3. 3. CONH3 5 times H2 plus 3. 4. CO F6 minus 3, 5. So, we need to arrange these ligands, these complexes in the order of wavelength of absorption. These are all from the tabular form given in the textbook, the same complexes. Looking at the nature of the ligands, you can arrange them in a particular order, where we first understand it according to CFSC first. So, the highest CFSC by third one, because cyanide is the strongest ligand we have. Then comes the first one, because it has 6 ammonia ligands. Then comes the fourth one, because it has 5 ammonia ligands which are stronger. And then comes the second one, what is a stronger field ligand than fluorite. Last is 5. So, if you need to arrange them according to lambda, it is the reverse order. So, 5, 2, 4, 1, 3. This is the correct order to arrange. This is all about various questions based on complex compounds. We shall stop here for today. We will discuss question paper of tomorrow from 11:50 to 12:50. It is a question paper session allotted for chemistry. We will meet in that. Thank you.